I'm very happy with this approach because this uses only differential approaches rather than other areas not using. So that is tool. Then the database input should be the person information you will get the rockets to the validate R, etc. And so that's dashboard. And then the dashboard, the personality Google than people what it is. So it is basically input not only the addition to personal information and the disclaimer reports. Then the data components that are areas include categories, programming data, and attributes, and have the response to obtain the report and database. Then it use this including there is a lesson of data regularly on the website. And there is a suitable database system. I got some mistake of the slides and the obvious. That is okay. So this is now so these are some reasons for what happening now. This is the application. This one I have watched in the for IAM
അതുപോലെ പരിമൻ അഴകന്മാർക്ക്
more than 1% from 1992 to 2016 with the increase observed in every state of the country. Kerala's capital Tirunelveli is one of the major cities in India has a very high breast cancer incidence with a significant increase by 3.3% annually during the period 2005-16. Breast cancer is influenced by several well-established factors, including aging population, change in the reproductive patterns such as early aging menarche, late aging menopause, and increased duration of breastfeeding, and lifestyle transition like a decrease in physical activity, increased obesity, etc. Recently, some studies suggesting an association between outdoor pollution and breast cancers. These different in the status across regions create a distinctive spatial pattern with traditional economic patterns. They are not fully captured. So, assessing the individual level exposure to environmental factors studies, making spatial analysis essential for understanding patterns in disease incidence. Despite the significance of breast cancer problem and that the socio-economic, cultural, and lifestyle variations in India, spatial economic studies on breast cancer are scarce and becoming few focusing on incidence clustering in the country. The spatial distribution of cancer incidence in Kerala has been initiated in Kerala by basic cancer incidence base. But actually, what data is not much sufficient in involving the highest area of cancer incidence. So, some vaccines model is widely used for forecasting technique in cancer patient. In spatial thermal models, spatial thermal models are modeled simultaneously. Only by considering and space together, we can address how geographic entities changes over time and why they change. Incorporating the spatial dimension of radiation in cancer research helps to examine simplify job filters so that disease will not be there. For these rare diseases such as cancer, the doctor also cases for this connected and five spatial tendencies. So this situation will become more obvious when many dimensions are considered simultaneously, such as gender, age, and business status.
പതിനാറ് ബി 25 ബി 1150 വേറെ എവിടെയാണോ ഇല്ല 26 സി കുഴപ്പമില്ല ഇത് 10 മിനിറ്റ് വന്നിട്ട് 25 രണ്ടു മൂന്ന് പേരെ പതിനാറ്
basic models are widely used now, especially in spatial memory. This spatial models mitigation gaps are often a gross area over time and thus provide uniform approach to molecules. Classification system. This is usually combinations system method offer new ways to analyze these spatial targets and identify high-risk areas in tourist novel types. The system is affiliated over time. It becomes difficult to evaluate the concept of radiation across spatial regions. The studies use the spatial thermal approach to assess lag effect to make exposure and spatial risk distribution. Basic spatial thermal models importantly conduct orthography together and widely used to analyze these spatial targets and identify risk areas influenced by local factors like gas. The cancer model is studying for total beneficial and provide more convincing evidence of radiation than separate spatial or forensic analysis. So the present objective of the study is to examine the cluster target of breast cancer influence into regular using spatial analysis. Investigate the association between the equivalent test and breast cancer incidence group creating spatial models. And the study area comprises regular administrative area and terminal elevation of 3 years. That is, we compare the data to the local years, that is 2005, 2007, 2008, 2010, 2011, 30, and 2020. And the more number of cases, that is the otherwise the small number, you can have an estimation. And the person 70 to 90 values for the study. So, administrative units comprises the examination first paper.
കോൺക്രീറ്റ് 120 തീരും 3 ചേർക്കട്ടെ രണ്ട്
Method was used for estimating the population number for years, based on 2011 population, and the growth rate from 2001 to 2011. So this we use this 10, it is not 0. This 10 and 10 are software we use for space analysis and spatial development. We use population results, population density, the population component that is PM2.5, PM10, sulfur dioxide, nitrogen dioxide, and some of that is also called carbon monoxide. The population data are obtained from the Kerala State Pollution Control Board. This is for procedure. Nobody was done using Google and software. And the demonstration was estimated at a more unwanted location using the image distance reading and the method. And it's based on even for this data. The model is used for the data revolution. That is device database or exchange, right? Rather than the statement database where it used to be every years 94 the system. And the spatial evolution and exploring spatial data analysis were connected to it. And they also the analysis were carried out using the software.
Related. China
And for explorative data analysis, we use more and more aspects, including the capacity to the existence of significant spatial targets and sustain the use of spatial organization. Similarly, these sometimes LD to determine the precise location of statistically significant clusters of low or high values of cancer incident specified distance. Another honestly often more sensitive. That is the customer analysis tool. Or some high or low values of the spatial updates. Also generalized linear model was initially used to calculate on the incidence incidence. Without the spatial So there are components which we know about. And the beta rate is under the levels of 6 in given area where you use values indicated. Humanized 70 cases of and sure it's a little bit of circumstances will be less likely with offset accidents solely for the outside body and 64 from other public units. It was a 5.07 because the name is there, because the name is there, etc. So we are by English is there. We can include the English language also in this field. Percentage administrative area where food incidents rate will affect during the study period. The other area with the high incidence rate show a significant increase. Compared to the services in 2017 to 2024. So that and in 2017 and in the drop 72.31 500,000 periods. So mass of station solution presents research show and the correct in the cancer in place. Like the uncaused injury incidence of cancer. And then is the station frustration that is significant every year during the year. The station incidence of cancer research show the increasing trends over the years. With the final for the period already. And the portion is already and the red portion is big minus incidence and most of the cancer cases from state in the United area. These number we need a population of 500 cancer clusters in Central India. Normally, most of these virus clusters are really on the easy. And they more or less they only have and sensation from surface of areas and it was performed to locate where these surface were concentrated. And the latest on case statistics shows that the highest cancer districts are mostly located in residential area of study area and relatively high radius. Which one only like in 2005 and 2006. And in 2017 data, we 4.5. And this is actually after more than this chemistry. And that correlation is on the start of the analysis confirming the first one as clusters of high and low values of cancer. And there are a lot of people for my as we have a more deep statistics to be question between high value and low values. Statistics show that ammonia, carbon monoxide, oxygen, and and based on the WAC and WAC value, is the most better more because it was DAC and WAC. So we consider more more is the best more. And the reason that we did the relative result. And number two, and the 2.5 should be specific formation with the many speech only the speaker. So this can be example
अरे हाँ ठीक ठीक हाँ रान हाँ हाँ
by analyzing the systematic over time, we observe an upward trend in terms of respective incidents with a significant association observed between the scales of incidents and algorithm being 2.5 and urgent measures the special development model to create
I'm legal I find my mom
also influence the incidents with the aspects of the lead to ministers lead to benefits like lead chaser, private funding, and the however, the lack of availability of public data related to these perspectives in Australia is the evaluation and assessment of their preventive effects. Analysis really on incorporated every and data from the limited number of movements among stations, which may not fully match and find spatial variation in political participation, particularly in less non-tech and lower in less potentially quantitative business study. So the studies also focus on a small area around approximately 7.5 kilometers. The lead from the sensor will expand the coverage to 100 intent. Now, as a token of our gratitude, we would like to present honors to our esteemed speakers. First, I invite Dr. Mohammed Parekh to kindly come forward and receive the monitor from our session chair, Dr. Ashwin. Next, I invite Professor P.T. Saraju to join us on stage to receive their monitor. Thank you, sir. On behalf of the organizing committee of ICSTC 2024, I extend my sincere gratitude to Professor Ashwin Valley from Memorial University, Newfoundland, Canada, for sharing this session. I also take this opportunity to sincerely thank our esteemed speakers, Mr. Mohammed Salim TP, Mentor Performance Rating Private Limited, and Ms. P.T. Saraj from Regional Cancer Center, Toronto. Both presentations have been reviewed into the incredible potential of innovation research on an application level across various fields. We are deeply grateful for your contributions today. We will now take a short break and we gather in a short lunch break.
those who are new to the math, please, you know, you can see എന്തെങ്കിലും വിളിച്ചോനെ ഇതില് അതെടുത്ത് പുറത്തായിരുന്നു അത് ചുമ്മാ സാധാരണ ഇങ്ങനെ എടുത്തിരുന്നതാണ് ഇതാണോ ഇതാണ് തോന്നുന്നല്ലേ അല്ലേ സ്ക്രീൻ വന്നോ അങ്ങനെ അവര് സുധീഷ് കാട്ടുമല്ല മ്യൂട്ട് ചെയ്തു മ്യൂട്ടിലേക്ക് എടുക്കാം
Moving more to the second technical session of ICSTC 2024, which is the first conference session that will be chaired by Dr. Mohammed Farid Kiki. Dr. Mohammed Farid Kiki is first of our college, associate professor at the institution until 2018, with the into the industry. He worked as a technical leader at Ford Global Analytics and later as director of IT and Analytics at Mentor Performance Rating Private Limited. He was as the principal of WMO Arts and Science College, Vayana. Additionally, he has been an executive member at the Institute of Actuaries for India for the past 20 years, which reflects his dedication to education and professional excellence. He will be very fortunate to have you for chair the session. Over to you, sir.
Thanks for the nice meeting. Welcome back. This is session number 7 of the session. We have 3 speakers. First, Jagan Krishna is Division of Chemistry, Technology and Biostats, Indian Cancer Center, in India. He was Professor of his department and a PhD from science. Second speaker will be Vijay Pataraji, Assam University, Assam, India. The third speaker will be Dr. K. Jarupa, University of California. I think 3 minutes each. So I will complete the session of 30 minutes and the following 3 minutes. Okay, thank you. First, Dr. Jagan. I would like to thank the organizers for this opportunity to present my work here. It's my privilege and honor to be here to give back my partner to give a presentation on what we are working on right now. So, I will be talking about the efficiency of monolithic integration methods in joint modeling of longitudinal and surveillance outcomes. And specifically, we will be thinking on the cancer surveillance studies and surveillance risk estimations. And the talk will be outlined as follows: some of the foundation and the information, and about the joint model. Then the choice of the design answer, how it's being affected, and the estimation procedure, model, that is the motivation, model, then estimation study, followed by calculation and references. And when we think about cancer, we know cancer is increasing exams is increasing of the field. And so by going through different cancers, we have observed that we know breast cancer is top most of the exams and first among the rare cancers in India. The other cancers, when we go through the early cancer types, also that colorectal cancer is being recently, and the incidence of colorectal cancer is third most in the world as well as in India, and it's the major cause of mortality worldwide. So we thought of looking my interest is on survival, so I thought of looking into factors associated with colon cancer or colorectal cancers. That motivated me to look into aspects of colon cancer. And when we go through the survival part of it, we have seen that is, if you want to have a survival analysis or survival data, then of course you have to follow the patient for a long period of time. Right? So when we go to meet and follow the patients, we are seeing that during the follow-up visit, in each follow-up visit, we used to have certain biomarkers, like plasma chemistry and values. And that also has an impact on the survival of the patient. So we thought that also has to be accounted in the survival point so that we can have a better reliable estimate. So with that, I studied this cancer. You can see that colorectal cancer usually is colorectal cancer or colorectal cancers will be it takes some 10 to 20 years for it to turn college into the carcinogenic or malign form. So that is the first figure, and the second figure comes here for the staging of this colon cancer. So if it is on the mucosa, that is the inner layer. So it's the stage 1, when it goes with the mucosa, and then if it goes with the muscles, and further the serosa, and further it may go to the lymph nodes, and then it may go to the neuron and so on. So the fourth stage it will be going into the organs, and this will be called the stage. And apart from this, we have seen that we check for the associated risk factors for colon cancer. Of course, it is diabetes is one of the major risk factors for colon cancer. We are not looking into that instead, but looking into it, we have seen the longitudinal weightage for the rheumatoid. So in order for that, going out is longitudinal value and the survey comes together. Thus, we figure results are model. And coming to joint modeling. So joint modeling of longitudinal and time-domain data is a statistical method which combines both the longitudinal and the survey cost. So the longitudinal data measured values. It can be for the age of which is measured in categorical way or as a continuous value. And the second part generally involves our focus is mainly on the endpoint like the maintenance, supply, etc. And here the focus is on now. Actually. So as this national outcome is measured effectively over a period of time, they may exhibit a correlation structure between the longitudinal and the terminal events what we are looking for here. And the reason is this longitudinal and circle data being modeled separately, like the sample part separately and longitudinal part separately. So which won't give an insight into how this longitudinal part is being associated with the circular part. And actually, when you look into it, it occurs in the measurement at the site. So these are some of the work that has been done in the survey model. Survey model for the survival and the part, the initial work was taken up by Wilson and ICSTC in 1997. And later, Henderson et al. In 2000 formulated a class of models for the joint behavior of longitudinal and event data. Here is an ingredient given an overview of the joint model. And in the semi-parametric Cox model also discussing literature and J package was introduced by so-called demonstration 2010. And what was technology used including the rate of change of longitudinal category to receive the joint model. However, in 2012, increased the community risk use not in the setup of the joint model. Several other articles if you want can go through several of them, and this is predominantly there are a lot more work is being done in this area recently. And to give a nutshell of this, how the model is being implemented, this is the picture of it. So the first part you can see. The first one represents the longitudinal part that is being modeled. You have used the linear mixed model for modeling the longitudinal part, and the time-driven part is being modeled using the cylinder cost or the normal cost model. And here you can see the way the observations are being repeatedly measured during the project. This is the play. And we also derived also similarly on the project. So here YIT represents the longitudinal outcome, and this MIT is the true value of observed value, and we take the fixed effect parameter. XMP is the fixed effect design vector, and DI is the random effect. ZIP is the random design vector, and epsilon I is the random incorporating it. And these coming to the survey model, we have the Cox model here, lambda LFT, and the LFT is corresponding to the and lambda is the baseline CASA. And these two models are being linked using the late position. And here the lambda naught of T represents the baseline CASA. Our interest for the present from light for this baseline CASA. How it goes and how is based on the choice of this basin. So, coming to the joint modeling part, the longitudinal submodel, that is the longitudinal component, consists of a model of the longitudinal biomarkers, which include fitting linear mixed model. For that, let me define the true event time, slope of time, and this is the sensory time. Clearly, the observed event time for the eye subject event time is the minimum of TI star SCA. The SCA is the sensory and delta represents the indicated function. combination of MIFT and error term. And MIFT is again the combination of fixed effect and indirect effect. And IFT follows attempt to follow a normal distribution with not square and the energy. And beta is the fixed effect excited, and T is the vector I is the vector of coordinate, and V is the vector of magnetic, and is the vector T is the vector of design. So coming to the survival subpart, we have the survival model, Fox model here, and it is given in equation number 2. So here is lambda naught of T into e power gamma prime W plus alpha, and this is the link function we are using here, so that we can link the longitudinal product to the survival part. Our interest basically here is on the T. And where MFT is the history of the true and observed longitudinal process up to the time 20. And W is the vector of baseline coordinates. Lambda T is the baseline alpha function. Gamma is the vector of regression coefficients. That is the effect of underlying longitudinal outcome to the risk of the event. So now we move on to our focus, the baseline. In joint model, the longitudinal and time given data, the baseline hazard function is very unspecified. And here for the hazard function, it defines the overall risk of the event as that here for the temperature event and given the effect of longitudinal and time leading to the. And in general, the baseline hazard here we consider the two baseline hazards. That is single adaptive. So it is a constant baseline hazard using the Gauss Target rule, and this is baseline hazard using single adaptive Gauss Target. These are the two methods that we use to sustain the baseline hazards. There are several other baseline hazards can be obtained like AFT model, isolated phenotype model, or we can have spine models. That is also there. We have published a paper on this, which we have discussed on all these 4 models essentially. Here my focus is on target efficiency of these 2 that I have picked up on these 2 models. And these question operations are known as integration techniques that can be applied for calculation of the likelihood of these models. And the TCS function baseline hazard, this approach what we have just is split the partition the state into several intervals like 0, U, not less than U, etc. And I think that the baseline hazard is constant within the intervals. And let's see model the baseline hazard lambda naught of T using J parameters lambda 1 to lambda J, each representing the risk of individual on a particular interval. So under the TCS function model, the baseline function takes the form given in equation number 3. So this is lambda naught, the baseline takes the form lambda naught of T equal to J equal to J, lambda J within this interval that is in if it is 1, then lambda that J exists as 0, that is the function, and lambda J is the value of the hazard in this particular interval. So the single adaptive Gauss Target rule, the model is similar to that of the earlier model, but the difference is that the choice it shows the definite indirect or the definite indirect or that is similar of this indirect. It means only lesser number of orders a point compared to that of the basic one. And here the relocation of orders point at each iteration can be avoided by using a single adaptive Gauss Target rule. Now coming to the estimation part, we use the natural likelihood estimation for this estimating the parameters. And the natural likelihood estimation in joint model is based on the maximization of the log likelihood according to the joint distribution of the longitudinal and the survival subpart. So to the this load distribution, we will assume the condition independence of the student and OEA and the given outcome TI given the concept here. That means we count the probability given equation of O and T of OA given VIT the parametric value of anything is probability function. And the parameters theta, 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 y dash, theta, b dash, the bottom is the full parameter vector with intensity denoting the parameter for the event, namely root of, and y represents the parameter of the last order alpha, and these are the parameters of conductor of the vector. So the log value for the I subset is given by log E of A that is given by log of this given. Accordingly, the log value we can represent using this representation equation of this, and we can obtain the parameters. The parameter estimation can be done using this is a complex model which source from this solution is not available, so we go for the numerical approximation. And for this, solving this generally we can have either an acceleration maximization algorithm or Lassen algorithm. And here we can have adopted the acceleration maximization algorithm. And so the inference function, baseline function, and the other part of the log value function takes the form of your equation of the standard. And here, I of P is starting with the standard function, and that incorporated the link function and the corresponding coordinate, and along with the longitudinal outcome. And Dij is the best indicator for the J interval for the piecewise constant baseline standard function. That's the indicator function given here. And delta Ij is the minimum of Ti to J minus 1, that is over the interval, the minimum of the time point is being taken. Okay, now we will be using the numerical approximation for solving this, and for illustration, we use the moderated example of column cancer data. So here we have taken about 343 column cancer patients from other cancer centers also registered during the period 2016 was considered, and they have been followed up in 2022. And a joint model approach was used here with different ways to choose the decision clusters. And the longitudinal variable used for the present study was the Castner integration condition values, which is measured by mg per ml. And the other coordinate considered for the modeling purpose age, which has been categorized into less than or equal to 50 and more than 50. And we chosen the standard. About the stage as 1, 2, 3, 4, we have already seen how it is stage. And the classification of cancer. And there are several other variables associated with the colon cancer, like perineural inversion, lymphovascular emboli, and several other variables, which we have looked into. That we haven't found much significance in our data because most of the data is not complete, or there are a lot of missing information in it. So we excluded those variables from this present study. And before going for the starting with the study, we have gone through the trajectories of the longitudinally measured markers, that is the CA value, and we can see a different pattern for each of the patients. So, and it can be more clear from the next graph, that is for each patient. Patient 1 to randomly chosen some of the patients are given here. You can see the trajectories are different for each of the patients. That means each of the patients has different survival based on the trajectories or based on the CA value. So that forms the motivation or reason for having a joint model rather than simple proxy.
So here we fitted two joint models under two different baseline risk functions. And one is piecewise PHGH model and the other one is piecewise PHGH model. And for each of the variable, we have done a varied analysis and we have gone through it and we have assessed it based on the AAC and VAC criteria. And we have observed that for both AAC and VAC are significantly better for piecewise PHGH model. And this is the parameter estimation corresponding to longitudinal process of each of these joint model. And we can see that both coefficients are obtained here. There is slight difference in the coefficient estimate based on each of these model. And comparatively, this piecewise model is giving a better estimate in the sense the confidence level is also slightly it's not. If you look into the width-wise, the piecewise PHAG is giving a lower width. And coming to the hazard rate, that means the survival part risk for each of the events, we can see that both the models are giving almost the same hazards, and comparatively, and also the in function alpha is also very significant. That shows me the ring function is significant in the sense the longitudinal marker has a significant role in predicting the survival outcome. That's what alpha, significant alpha represents. And based on the AAC and BAC criteria, we are saying that this is better model. But we need something concrete to say that this is a better model, right? So that's what we start with looking into the simulation study. So for assessing the consistency of the model, the simulation study is more useful, right? So we consider the sample sizes of 100 to 50, 500, and with different proportions of 10%, 20%, 50, and 20%. And the generated data were fitted to 4 joint. So here we fitted for the 2 models. Random variables corresponding to variable 6 was generated from a uniform distribution with probabilities 0.4. That means we are considering a variable is random. We are asking it to be equivalent to a gender. Equal to gender. So we consider the proportion as taken as 0.4. And the longitudinal data we have generated using the linear mixed model approach, given equation number 8. And the survival time were generated from the general hazard model, that is the Cox model, given equation number 3. So the piecewise PHAG consistently exhibited the least AAC and BAC values across all the sample sets. You can see the result here. So this is the simulation study. The comparison of the joint model, here you can see the piecewise PHAG model. You can see it has the least AAC, BAC, and apart from the AAC and BAC, we are looking at the computational efficiency here because the PHAG model is taking only a pure line compared to the piecewise PHBH model. If you look at here, for 20% sensing, if you look at the runtime for PHAGH is only 32 minutes, whereas it takes on 39 minutes. So computationally, this model is performing better. So also here for 50%, it is 27.45, and here is 133. And here it is 19 for 70% level sensing case. Here it takes only, it takes about 130 minutes for action. So when we go for further models or further complex models, this model will take longer. And when we use this model for the multi-stage model, I think yesterday my student Divya has presented his work on multi-stage model. And it is more complex than this joint model and takes longer time. So when we use this model for a multi-stage model, it takes more than a day to get a result. And if you use this AGS model, still takes some time for multi-stage model to run for another 6 to 8 hours. So this is comparatively better model based on the computational, because the result what we have seen is the hazard rate or the COVID rate what we have estimated is almost similar, but the computational wise is so different. And based on the bias and RMSE and the corresponding coverage probability also we can see it is performing, there is slight difference, and in most of the cases we can see the precise PH model is giving a better bias and RMSE as well as the coverage probability. So the main advantage of any joint model is dynamic prediction. So one of the here using the fitted joint model, I have shown one or two couple of patients. So based on fitted joint model, you can have a individual dynamic prediction. For each individual, we can have the risk prediction. Available. When the first CA value is available, the patient survival looks like here. And when the over the follow period, we gather more information. When you add on to it, you can estimate the risk for each of the individual society, but each regular period of time. That's the advantage of the joint model. So individual prediction or dynamic prediction. Dynamic in the sense, whenever you get additional information, you keep on adding into it, then it gives you the risk prediction. And this will be useful for the clinician to make a decision to change whether they have to change the plan of treatment or not. So that's how this model is more useful and becomes more relevant. So this patient number 40, the first two has using the two different models, and the second shows that for patient number 317. So we can see the changes in both the models also based on this particular patient. And to conclude, all these models considered in the present study showed almost similar values for hazards. However, they differ only with respect to the AIC, BAC value and based on their computational efficiency. Right? And the mean function for this model alpha showed strong association between the longitudinal time-to-event outcome for all the models. And we identified composite stage along with the longitudinally measured covariate PA as a significant prognostic factor for assessing the risk for survival among the colonies. That means it is not the longitudinal path alone and survival path alone we are estimating here. Here, the alpha function shows that the longitudinally measured CA value linked with the covariate, like composite stage or other family history or whatever factors we are considering, along with those, they are found to be a significant predictors. I haven't discussed much on the risk factors here. The simulation study further reinforced the superiority of the piecewise PH model, demonstrating its stability across varying sample size and sensory proportion and its computational efficiency. In conclusion, we can say that the study highlights the importance of selecting the appropriate baseline hazard to improve the accuracy of the risk estimation in joint modeling of longitudinal and time-to-event data. Thank you. So this is a part of the project what we have from the Department of Health Research, ICMR Government of India, the funding agency. Thank you. It's a some of the
Next suggestions are very interesting.
Yeah, next good question. Accordingly, data is generated. And the record is being kept. It is being visible ball by ball income. This tells that every ball in cricket is illegal because it generates a lot of data. Even a ball which is not being scored against also generates a lot of data. And so that the statisticians will get interested in cricket. It's going to obvious because obviously there is a role of statistics and those who are from the discipline of statistics find a lot of data
to analyze to reach to meaningful conclusions. The first paper which we appeared and is actually statistical problem solved with that in 1945. Subsequently, different people contributed to the statistical techniques to be applied in cricket analytics, and with the advantage that these days we are having so far as data storing, data retrieval, and data analysis is concerned. So a lot of machine learning and AI tools are also being developed that can do this analysis. So let us before going to today we will be looking into a particular bowling performance measure of cricketers. But before we do that, let us look at a highlight of what are the different fields of cricket analytics that are popular and quite a lot of people are watching. There are several other subfields also which will not be covered. Let us look at some of such subfields. So cricket, as you know, is played in a circular field with a maximum action takes place in the center of the cricket field, which is called as the pitch, which is 22 years long, where the bowler comes in and bowls towards the batsman. And the job of the batsman is to hit the ball and to score runs. And there are some the runs are scored in a district manner, like 1, 2, 3, 4. And six occasionally there might be 5 runs also, but these are rare and 5. These are basically there are three formats of cricket. Okay, we'll cover it later. Let us look at this. What are the top areas where actually statistics is in apply? So let us look at betting awareness. So when let us look at this simple formula that this is just like that of an average that if a batsman scores runs say I take 8 innings, maybe any number, n number of innings. So in that betting average of the batsman is also a measure of betting performance. The summation RI, it is runs scored across defined balls. But the denominator is not the total number of innings, rather the total number of innings in which the batsman has got out. So this creates an interesting problem that there might be a series of matches in which the batsman was not out all the time. And in that case, you don't have anything in the denominator. So then the betting average remains undefined. Another situation is that the batsman plays a series of matches but remains not out in all the innings except one. So the denominator is one, and in that case, the betting average is equal to the run score, sum of the runs scored across all the innings. So these are some situations, and this is very simple thing it looks like. These are actually inverted statistician to work on. And many people try to solve it in different ways. Some people use survival analysis, some people use different techniques for Bayesian estimation, and some people use the concept of trim release, some people use the concept of stochastic dominance. So this, though it appears to be a very simple problem, but it has always invited statisticians in different ways, and maybe now papers are actually written on redefining the betting error. But in statistics, sorry, in cricket, when you see this is the formula that is used. If you look at the betting average of Mahendra Singh Dhoni, you will find that Mahendra Singh Dhoni is betting average is actually overestimated because he comes at number 7 or number 6 generally. Because he remains not out in many of his innings. So this is the reason why his betting average is getting big. Not only few matches where the batsman might excel in the inning, then it happens in real. In this so this is one area which is quite fertile, a lot of people are watching. Another area is team selection. In team selection is something like that a cricket team consists of different experts. We require openers, we require fast bowlers, we require spinners also. We require all-rounders, we require a wicket keeper. And batsmen can be divided into two groups. One is opening batsman, which is called the top order batsman, and then comes the middle order. So when you form a team, you just can't go and measure the performance of players and get the best performing one. But you have to keep in mind that you will be ordering which the players of different expertise are in your team. So if we assume that these the players of different expertise, they are colored differently, and then we want to select an opener. So from these red players who represent opener, we select two of them based on their performance. We select some middle order batsman. We select some fast bowler.
we select one wicket keeper, we select a all-rounder, say, and we select a spinner, so all-rounder might be a spinner also. But then this is a hypothetical combination of players. This is a statistical problem, and here different techniques like binary integer programming problem is used along with performance measurement because there are two sides of this particular exercise. First is that you require a measure which can quantify the performance of the player into one single figure, and then you find an optimized setting so that some constraints like two openers, three middle order batsmen, this optimization takes place depending on the your opponent and on the ground in which the match is to be played. It's condition weather conditions, etc. And get the best optimum player. So this is quite popular these days because of some seen that from 11 circle or that some such playing 11 fantasy. Fantasy apps are means commonly available. My circle, then might be 11. All these things are there. So in that case, you need to select players from two different teams and give your favorite 11. So there also this may come handy on these techniques. And so this is becoming very popular and applied a lot of machine learning and computer scientists are also found to actually exercise with this. Okay. Let us go to the third problem, the target rescheduling. This is a very interesting and a very statistical problem. Now, what happens is, let us take an ideal situation like this that cricket match is going on, and the team there is a team who actually bats first. They have scored, say T20 match, they have scored 157 in 20 overs. So the target for team B is to in order to win the match, B is to the team B, that is the team who bats second, needs to score one more than 157, that is 158 in 20 overs. So team B is placed at 56 for 2 in 6 overs at the end of 6 overs, but just at that point of time, some weather changes. Suddenly clouds start coming from okay, fine. And then dark clouds are coming in and it indicates that there is a chance of rain and well we can see some thunder also coming up and it may rain any moment, light drops and then oh God, it starts raining. It starts raining and then we wait for the match, but unfortunately the match does not start. So after waiting for some time, the match has to be about. But having said all these things, we need a solution or we need a winner in this match. In this case, that when there is some information available with us, the target is available with us, which is 148. And currently in 6 overs, CP has scored 56 to 2. And if the match would have continued till 28 over, who would have been the winner of this match? This is a problem of target rescheduling. It might also happen that match starts after a delay of say 10-20 minutes or 30 minutes, 1 hour, leading to lots of some overs. That instead of a 20 over, the team B will be having 6 more overs. That is, match will be terminated at the end of 12 overs. So if the over diminishes by 8 overs, that is comes down to 12 overs. What shall be the target for team B? That is called a target rescheduling. And we know that there are some such problems often that television, that now DLF method, backward twist and then steep start, who actually modified it more for T20 cricket. So now one of them is not there. So Luis is not working, so very senior person. So only Star is there, so Star modifies all these things. And from India also we have Jajavan, who is from Kerala. He is one of the challenger of the backward twist method, so he has an alternative approach. It's one other alternative approaches are there, but out of this, ICC has adopted backward twist, but then in BCCI has adopted Jajavan's method. So far as domestic cricket is concerned, and Jajavan's method is more scientific than backward twist is because in different cases, Jajavan has tweaked it, and backward twist method is where Jajavan method gives a reasonable. So this is another area where a lot of people are working. There are some great areas also. And what performance measurement? There are a number of other topics also under cricket analytics, but these are the of well sort topics. Here the problem is quite interesting. A player, for example, this is an example of Mahendra Singh Dhoni. In one of the matches, what happened that he was betting also. Some stage he actually his being job is he is a batsman betting, wicket keeping also. But at some stage he came down to bowl. When he was bowling, he was feeding us. So this player was doing four things together in a particular match. Not together in a particular match, he was doing four things. He was feeding us, he was bowling, he was wicket keeping, he was feeding. And the question is, how can I combine the performance of the player in all the different expertise into one single number? So this is about performance measure. So how to combine? You may tell that okay, this is an excellent exercise. I agree with you. Some batsmen and bowlers also, some bowlers are betting also. There are some people who are betting and some bowlers or batsmen, even if they have one single extra bet, they feel also. So at least two things everyone does. So how to combine all these things into at least to one single measure of performance? Because if we try to do that, we cannot optimize settings. So we require something like that. So this is a very background of now. So we are actually on this particular area, performance measurement, and that is performance measurement of bowler. If there is no performance measurement of bowler, definitely not. There are so many performance measurement of bowler. So what is the need of another performance measurement? Need is that performance measurement of bowlers are there, but there is no format specific performance
Redmi
measurement
Note 7.
for batsmen or bowlers.
Redmi.
So here I am concentrating on bowlers only. So let me tell you that cricket is played at three different formats at the international level. Some other formats are there also. But at the international level, three formats are there. One is the Test cricket,
Yes.
one is ODI, and another is T20. In Test cricket is an unlimited overs cricket, so I think today India is playing against Australia in Test cricket. So this is 5-day affair, and 556 hours on 4-5 day affair, and this is unlimited overs. However, ODI is a 50 over per innings where each team gets only one innings to play. So one for team A, another for team B, so two innings, and that innings last 50 overs. Similarly, T20 is a reduced limited over match where we have 20 overs assigned. So here there are more innings so these are limited overs. We want to focus in these two components of the game. We want to actually find out the bowling performance measure. Now, bowling performance measurement, why it is necessary? Because we are actually batsman has good, sorry, bowler is good response. The aim of the bowler is either to dismiss the batsman or to restrict the batsman from scoring runs. So in this case, what happens, we have two things to be studied together. The ability of the bowler to dismiss the batsman, and the ability of the bowler to restrict the batsman from scoring the runs. And so we come with is there any measure? Yes, you will get the measure. One is bowling right, and which is killing measure. The runs considered by the bowler, and wickets dismissed by the bowler. So we want the bowler to dismiss more wickets. So bowling is actually indicating measure. Small the game better. Bowling bowling over is 12, bowling over is 18. It means that bowling over is 12. This particular bowler gives to a 18 runs to play. So when you compare these two bowlers, definitely the one bowling over is 12. So this is the wicket taking ability of the bowler, and another is the economy rate of the bowler. So that is the run considered by the bowler, by the balls scored by the bowler. So if a bowler is good, then he will concede less runs. So that is the thing. You see, in both the cases, numerator is the same. The problem is changing the denominator. One is wicket dismissed, another is ball scored. So these are already existing measures available in cricket. And bowling average and economy. Now, where we apply statistics, because statistics is a technical subject and not for everyone. But whenever we redefine anything and use statistics and define a particular bowling, particular measure with
my ideology, it is my understanding that we should use the terminologies or the statistic which has been used in that particular game so that ordinary fans also can follow your vision. They can understand, well, this is based on bowling average and economic, something like that. So there are might be other complicated tools, but it has to be associated with everyday terminology of the game. Okay. So I want to use these X and Z and find out the bowling performance of a set of bowlers. So first problem that I think in doing this is that the bowling average and the economy rate, they are having different ranges. When I collect a host of bowlers, say I take first of 20 bowlers as per the ICC ranking and take their bowling average and take their economy rate, I find that the range of bowling average are not same. They are quite different. And so the question
LED in the CR, CBR, CBR, CBR and the click. Yeah,
similarly for economy rate. Economy rate of the particular board divided by the average economy rate. So all the board money considering order. And that means
is stored in this. Now, when we use two particular things or 3, 4, 5, 6, whatever, into a composite index that is reaching into a single number using two particular more than one measure. Then there is a well-known paper of 1982 by Iyengar and Sudarshan who deal with composite index, and then they told that when some parameters or variables participate in the index, we should make a variance stabilization because otherwise the one with more variance will start dominating that. So what we can do is that we can do variance stabilization by using X dash and Z dash from this point for the measure. So we find out the particular value of beta whose power is the variance of Z dash and X dash C. That is variance of X dash similar to variance of Z dash beta. So this value of beta we can find it through a trial and error method. We start with one and then we see what happens when one is increased, whether the variance is come closer or goes apart. If it goes apart, then we will go below one for the value of beta. And if it is as we increase beta, if they come closer, then we keep on increasing. At some stage, they become equal. So ultimately, the bowling performance measurement is denoted by this. So we are already aware about beta. We multiply these two things so that the simultaneous effect is there. That simultaneously you need to take it and you also must restrict the runs of the bowler. So in that case, we need to use alpha, that is the relative importance of wicket taking ability. If alpha is equal to 0, then this first term does not exist. And it becomes equal to 1 in that case, the first term. And so if alpha is equal to 0, so this term becomes equal to 1. So the entire onus of the bowling performance measurement lies on the economy rate of the function of the economy rate of the. But if I take alpha equal to 1, then this term becomes 0. And the entire onus of bowling performance measurement lies on the wicket keeping capability of the bowler. So that is the role of alpha. This is keep on increasing alpha. So alpha is meant to lie between 0 and 1, as you can see here. And as you increase the value of alpha, the importance of wicket taking ability increases, and the importance of economy rate, that is ability to concede less runs, keeps on decrease. So that is now we want to, because beta can be determined once we have the data. Now question is how to determine alpha versus the ideal value of alpha. And we can make a hypothesis in this case that alpha will be more in ODI because dismissing batsman is more important in ODI than dismissing batsman in T20 because T20 if you can restrict the runs, that is also a very good way of keeping the score low. So we can hypothesize this and let us see what when data comes into it. So if we take the first top 20 bowlers of as per ICSTC ranking, and we calculate their ranks as per different values of alpha. So alpha is the important wicket taking ability that we are varying, as you can see here. We are starting from 0 and then we can go up to 1. So we start from 0 and we go up to 1. And then we see the rank. What we see is that some bowler like this bowler is starting with 17, so 17 is Mohammad Sami of India. So Mohammad Sami of India, when you give more importance to wicket taking ability, less importance to wicket taking ability, a little more importance to economy rate, his rank is 17. But as you keep on giving more importance to the wickets taking ability of the bowler, his rank ultimately comes down and he is the top bowler. When you get actually 68% importance to taking of a wicket. Some such great movers are Hanisha Afridi. We have this. Okay, Hanisha Afridi. You can see he starts with 19th and comes down to 7th. This is of Hanisha Afridi. And then we have some overs who are very slow overs, like this is Jasprit Bumrah. As you can see, he starts at 4th position. When you give entire importance to economy rate, but then he comes down on the 2nd position. So there is not much shift in his ranks, though you are wearing a below alpha. That means we cannot say that alpha largely influences the rank of the bowler. Nothing like that. It varies from individual to individual, depending on their economic and economic and bowling. Now, we take as a gold standard the ICC ranking of the bowler. At the end of every month, ICC releases this rank. And then I see that I calculate, I get for his zero alpha, I get 1 rank set. For these 20 players, I get 1 rank set, and for the same 20 players, I get their ICC or rank. And then for the 2 rank set, I calculate the candle distance between them, because this is calculated for rank set. I found that I tried to find out that which value of alpha gives me the minimum candle distance. That value of alpha is actually telling me that this is the closest to the ICC ranking. So ICC ranking we are taking as a gold standard, and then this is the formula of the candle distance. And when we do repeat this exercise both for T20 and ODI, we find that the candle distance is minimum. This red line is T20, that is alpha equal to 40, and alpha equal to 0.3, we get the minimum value of candle distance for T20. That means you give 40% weightage to dismissal or wicket taking ability of a bowler in case of T20 and ODI, as you hypothesize. So ODI the importance increases only to 30%. So in ODI 70% importance is given to ability to restricting runs, and then here we get around 56% importance ability to restricting runs in case of T20. So this is so accordingly we for ODI we have taken the data and did the computation for top 20 bowlers, and as you can see, so this is the bowling performance measurement. So ODI the value is like this, and then we have for T20 cricket, run stabilization is 3.117, and so alpha is equal to 0.14. That's now we show it, and then this formula for computing bowling performance measurement. There is a typo here. It should not be 0.3, rather it should be 0.14. So this is the formula for the bowling performance measure in case of T20. So this is very weak, and then we actually compute the bowling performance of top T20 bowlers, and this is the bowling performance. Rashid Khan is at the top with these two formula which you have seen yesterday. So this is for T20. So at the top, Rashid Khan is in second position, and Samsi is the last position out of the. Some Indians are there, you can see here, Arshdeep Singh is there, Kuldeep Yadav is there. Kuldeep Vishnu is there, Akshay Patel is there. So,
already you have problems.
okay, yeah, so I'll just get the conclusion on this. So next we have ODI. So ODI we have the same bowlers, which is kind of Mustaqil once again top the list, because these are negative measures, so lower the value to better it is, and somewhat like the effect moderated. And then we have third position, this Samsi moves from last position to the 19th position to go with ODI bowler. So these are the position of the bowlers within this formula, but then what are the limitations? This formula also has some limitations. Let us look at this. So we have here, okay, the values of alpha and beta are based on the data of the pool of both. So these values of alpha and beta are endogenously determined from the data. So if your data changes, then these values of alpha beta might also change. It means if you change the player or you increase the player, it is the same, but their economy rate changes, then the values of alpha beta might suffer a change. So this is one problem with this limitations of this method. The second problem is that whenever a player changes or the value of its player changes, value of one single economic rate or polling average of any one player also changes, or even if the player changes. In that case, all the computation has to be done afresh. Now, these are two problems, L1 and L2, I call it, and then we have the third, what is the solution to the problem? But we can develop a program in Python, which is area of future research in metal, which when we give the command goes into the ICSTC ranking, collects $20 or how many number of dollars you want, and then go to another website where the economy rate and strike rate of the dollars are available. So from there, this program can collect the economy rate and strike rate of the dollars, and then using this method, they can determine the values of alpha and beta, and then accordingly determine the ranking of the dollars, and is an output with the rank of the dollars. But any instant, we can get format specific ranking of dollars using this particular program if developed based on this program. So with these words, I would like to thank you for giving me patience. This program is still very small.
The question is clear.
Question no, question is not clear. I didn't hear the question.
So can you be little louder?
Hello. Hello. Can you hear?
Yeah, I think.
I am Holway.
Yes, sir.
I was an old man and not serious, so I just look at it with a screen, that is TV screen, it is really protected by that. And there are two constants, alpha and beta, we are saying. To some extent, beta can be accepted. We calculate from the contents data. What about alpha? Alpha is totally subjective, you see.
No, to avoid subjectivity, we have taken the ICSTC ranking, which is available at the end of each month for the bowler, as a gold standard. And we have computed that value of alpha, which takes minimizes hurdle distance of the ranking that we have got for a particular value of alpha with that of the ICSTC rankings. The problem is that we don't have any gold standard. So we have to actually resort to some gold standard, and we have taken ICSTC ranking of the bowlers based on gold standard. The problem with the ICSTC ranking is that it has been well accepted, but the thing is that the methodology is never excluded. So we don't have the methodology of ICSTC ranking. So we could have gone with the ICSTC ranking. Now, when you want to apply this to say local cricket or not international cricket, whose values are not retained by ICSTC, in that case, you can use this method and taking the values of alpha and beta actually determine to compute this.
Right, we have to look into it, but I feel that this alpha is going to create a problem.
Yeah, alpha is selecting alpha is challenging because someone may tell that why you have taken ICSTC ranking, or if already there is an ICSTC ranking, what is the need of defining another bowling performance measure? This can be definitely a question. But the thing is that we can actually go beyond those players whose ranking is being done once we know the value of alpha and beta. But I agree with you that alpha determination of alpha is challenging because where you should give how much importance you give to dismissal of batsman and how much importance you give to restricting of runs, there remains the point of discord. But some solution has to be reached. Otherwise, we cannot actually use this method. So we are trying. This is the one methodology, but we never have agreed or we never tell that this is the only methodology available for determining alpha. This is an open area of research. Anyone can come with a new methodological approach of determining alpha. We are open to that.
Okay, right. First of all, I thank the Department of Statistics, University of Kerala, and Professor Satish Kumar in particular for helping me in organizing this conference. And the topic of today's discussion is on a generalization of the boundary distribution, distribution, and some of these topics. Now, first of all, I will give some, as you all know, the boundary distributions are relevant in various contexts, and I will give an outline of what are the importance of boundary distribution, and then go to the applications of the geometric maximum of function distribution in the boundary distribution. So, as you know, why especially statistically distributions are widely utilized across various fields of study, they often fail to adequately model data in diverse scenarios, and as a result, it is, as all of us know, it is interesting to develop new probability distribution, and one of the area is on the study on boundary probability distribution. And study on boundary probability distributions are important due to various reasons. And because of some of the reasons, the realistic modeling of data, where in some of the situations, we have obtained some proportions or the maps which are rated by a massive value for some other code. And these things, they will have to model with boundary distributions. Boundary distributions provide a more realistic and accurate representation of these kinds of data, as they ensure that the values remain within a specified range. And the second one is the enhanced flexibility. Boundary distributions allow for the modeling of data with upper and lower bounds, which is suitable for the wide range of applications, including modeling ratings, percentages, and probability. This flexibility ensures that the distribution can capture both shape and constraints of the underlying data. And the prevention of outliers. Boundary distributions are particularly useful in the situations where data points cannot exceed certain values,
and they provide outlines of experiments that might arise in abnormal distributions, ensuring that the data remains limit. And the next, the fourth one is to improve the predictive accuracy. By extreme values to a certain value, model distributions can improve the accuracy of statistical models, particularly when dealing with the data that is inherently. This leads to the better predictive performance in the areas like risk management, decision making, reliability analysis. And the applications in some specialized fields, our distributions are commonly used in fields such as finance for modeling performance within a certain range, biology for modeling population sciences for growth rates, and in engineering for reliability testing and surveillance. They offer tailored situations where traditional and bounded distributions where it is applicable. And the next one is the better interoperability. Since bounded distributions are confined to a specific range, they often offer more interpretable results. This is particularly helpful when presenting findings to stakeholders or decision makers who are concerned with the realistic and constrained outcome. And we are familiar with some of the bounded distributions, and some bounded distributions that are familiar in the literature are the power function distribution, Kumarasamy distribution, Beacon distribution, totally distribution. So these are some of the bounded distributions that we are well known. That are well known, and the first one is the given equation one is the beta distribution. That is the effect alpha beta, which has the well-known beta density. And you can see that in equation 1, when alpha and beta are equal, it will turn out to be the classical uniform distribution. And when alpha and beta take only half, it is the upside distribution. And when beta is equal to 1, it turns out to be the power function. And now let me look for a review of literature on the beta and its generalization. What is the work by Libby and Lee? They have proposed a three-parameter analysis of the beta distribution, and this is given by the density in case number 2, where it is bounded on the zero of 1. And the other one is the Webber distribution, which is again a generalization of the beta. It has the density given in case number 2. And where you can see that it has the density varies over the range 0 to Q. So Q can take any positive. And there are some other recent ones on the licenses of data distribution. And one is by Gomez, Phillips, and Ferrari. And they have studied another the license of the data distribution, which is known as equation number 4. And the other one is that is closely connected with our work. It is the work by Almeida and Bayani. They have introduced both hyperbolicity distribution. Both hyperbolicity distribution is having the density function that is k is alpha minus 1 minus x is k is beta minus 1 minus beta is minus 1. Where x is positive and you can see that it is and you have the constant change if I connected with the hypergeometry function. And that is why this is both hypergeometry. And the distribution that we are discussing here is a specific summary. So this is the latest one. This was both hypergeometry. Now, some other works related to the beta R. This is that a five-parameter analysis of the beta distribution considered by McDonough as a generalized of this distribution. McDonough and Stone, they negative considered the distribution of this PDF. And another analysis is doing equation number 7, where the distribution is about 1. And these are some other connections with some bounded distribution where we can try to help this using the contour hypergeometry function 2 millimeters. Where this is your constant x, your constant quantity x, AB, R, x, in theta. This is like relativity
the function hypothesis function is here. This is here. There is minus alpha, beta, gamma, x, y is this is where A is in the initial function. And apart from this, the realization of beta. So all the things in fact tells that why one you have to consider this type of realization of beta is this is relevant on. And you can see that almost distributions are in fact appearing in the situation some of the distribution that hence the relevance of that is the beta distribution is. And apart from the generalization that we have already discussed, some of the other generalizations of beta distribution not to be able to go see by the textbook by Gupta and Nadaraja also. That in fact is represent some generalization. There are different types of beta distribution. And some other recent ones are exactly 2021 introduced the beta distribution as an analysis of the two parameter beta distribution analysis. And this is a work by ourselves, which in fact is going to appear in communication statistics theory and method, where we have considered a generalization of the beta distribution. So the beta distribution that we have considered is a generalization of it is built using the classical hypergeometric function, and you can see that it is a bounded distribution featuring both day shape and it has both day shape and bottom shape data. So that is in fact the application. And so the construction of the distribution is as follows. So let's say the random variable y for the generalized hypergeometric distribution, it is given, that is the Gauss hypergeometric distribution which has the equation number given in the equation number 5, that is in how the reference is equal to kx to the power alpha minus 1 minus x to the power beta minus 1 minus beta x to the power minus lambda, where x lies in the x and theta lies in the interval 0, 1, and alpha, beta, lambda are positive, and this is in fact this k is connected with the hypergeometric. Conservation you will obtain the PDF at this point. And you can see that the range of the variable x takes the value between 0 and b, and we have the constants, then you have the parameters that these are greater than 0 and theta. That is in fact the relative parameter that lies between 0 and 1, and k is in fact connected with the both sides. So that is in fact the concept of the distribution. And so here we have some motivation for increasing the parameters. The value of C causes the rapid change in the height of the period curve. And by keeping the same speed level because of the gauge distribution, the value of B helps to model any positive data instead of the data to change in the value to be. So these are in fact the advantages of introducing the values range. We are shifting to the to 0 b, and it is making it from the transformation. It is equal to b by the power of b. So that is in fact the advantage. And so a random variable x is said to follow a generalized hypergeometric distribution. So that is what the one that we have to do. Here, if it's a PDF piece of the formula, the generalized goes hypergeometric distribution, that you can see that within such distribution, you may be able to go through the graph that will appear in the communication distribution.
clear images. That is in fact the generalized inverse hypertrophic distribution. The randomly axis that follows the generalized inverse hypertrophic distribution. It is really used as a program, and the distribution we may denoted by GGS alpha beta lambda theta CG, and the figures corresponding to this you may be able to calculate. And we can see that as a special case of this DGS, you may get a number of well-known distributions. And then when C equal to 1 and D equal to 1, it will turn out to be the it will become the most hypertrophic distribution, which was in fact studied by Ankaro and there in 1994. And whenever this that is C equal to 1, D equal to 1, theta equal to 1, it will in fact be DGS distribution. Our distribution the beta distribution. So for it is already able to refer by the beta and and the other thing is that it is again a generalization of the actual distribution, and also when C and D equal to 1 and lambda if I take alpha plus beta, then the distribution will turn out to be the generalized parameter distribution. That in fact was studied in the and these are all some other distribution. That is, as a specific case of our distribution, you will get the McDonald distribution, and also another specific case was this is under independent case. We will get the Kumarasamy distribution, that is the well-known Kumarasamy distribution. It is studied by various projects, and it was introduced in the commercial in the context of hydrological data model. And another way there is under some then you need to continue to follow the data source where the function is that commercial model is a legal or normal and explorative model is free. This is support the relationship for proposing the complex distribution, we will consider the technique of the developing Mexican collection, developing Mexican. So we consider the situation where we have the general situation where we are interested in the underlying the land. Can verify the next of where animals are very where we can see that these type of distributions arise, situations arise. When we are modeling the reliability of some farming system, some TV systems, so the way we are replacing this maximum by minimum, or some situation we will come across the minimum moment where we are looking for the reliability of farming systems or the reliability of TV systems, or both combined. Then we will arrive the another variable in studying the landscape of the kingdom. It is specifically modeled by x is equal to maximum function expression for x, where x's are any random variable and they are independent of the random variable. Then where we assume that mathematical use is that we discrete variable. Usually it is a discrete variable. Let us assume that let us expect the IED variable. You can see the let me restrict the expression that is expect the to a full table of the expression and C. Look at that how this is in fact a sort of cost of the distribution. That the annual x is that very something and let's by C that is possible. Now let NPS nothing matter. So when there is certain variable n, I assume that it has a geometric distribution with the parameter 1 minus 3. Then if you look for the distribution function of the random maximum, you can see that the distribution function of the random maximum is this into 1 by 2, 1 minus 3 by 2, it's making it into 3 by 3 by 1 minus 3 by 3 into 3, and that is our distribution. And this is in fact we call it as the geometric maximum of the distribution. Now you can see that the geometric maximum of the distribution, that is in fact a special case of the family that we have already discussed earlier. That we will come to here. So this is the geometric maximum of the distribution, and we will be able to just because we will get the after the game. And you can see that it is a non-random variable, non-random dimension also 3. and we have the parameters we see and theta, as we use the three parameter distribution, where V is greater than 2 and theta is greater than 0. So these are the parameters like how is the CDF solved? Then we call it as the geometric maximum power function distribution. And we will denote it as GM theta to B, where I so this is our distribution that we are going to see. Now you can see that the GMP distribution is in fact a certain case of our generalized was hypergeometric distribution that we have in this element. So that you can see that after two things, that is BBS 112 theta B distribution is our distribution. So this has some well-known application. And you can see that this distribution can be used as an alternative to the Weibel, normal, exponential, and the normal. And that's why we are incorporating some of the so let's really focus on the visualization of the PDF and PDF of VMPF distribution. And you can look at the structure of the PDF. You can see that it is the internal setup will be related to B segment 2. And then you put the VMPF distribution for the really for the parameters. And you can see that it has the various things. Here it is so much decreasing, increasing, increasing number. Line, this is line, passing to the origin from 0 to 2. And you can see that here it is again the increasing one, here it is slowly increasing and so on. So the relative state of the videos coming once here, look in the DMC distribution. Look in fact applications of the distribution in the relative state. If you look at the distribution of the type of the distribution, you can see that these are the groups that are typical to distribution. Okay. Now this is in fact there. So while weighing the values of the parameters, you can see that the period of the video can achieve these characteristics. So when you have a histogram, later with a histogram of this one, you may be able to model that with particularly this DMBS distribution than the conventional distribution. If you look at the still radio rate of the Hassad rate of the distribution, you can see that this is the shape of the Hassad rate function distribution. And you can see that it will in fact depends upon the guidance experience. It can be the shape of the density where the text becomes upon the guidance experience. And based on the shape of the experience, you can be maybe able to see that this is in fact a factor various things. That is the reason that the key motivations for making a discussion on top of the domestic example of contribution. That is the key motivation. That is the distribution function of this is in fact a close system. You can see that in the area case, it was the network and whereas if you look at the GMP distribution, you can see that it is in fact a very well processed. And you can see that if you look at the density function, you can see that it can easily calculate the right distribution. So these are in fact the motivation for taking about study on GMP distribution. With the distribution first of all, well, you can see that it is capable of providing data where that is the data with the histogram or the frequency of that is with increasing or with decreasing or not a failure rate. This types of failure rate is captured by that you can look at the shape of this index. So you can look at the shape of this index and you can see that these effects can be either increasing or it can be decreasing or it can be bifurcating. This is well known formed by the DMB systems. And you can see that it has a lot of constant failure rate field, which is capable to model second piece of bottom node. So that is in fact captured by the DMBs. So that is in fact Yeah, some of the reasons for this particular study on this. And you can see that this particular family, the family that is the family that is what's in here. That is in fact it is geometrically maximum steady. So that is it means that the distribution of the geometric maximum and in fact belongs to the same type. If you are taking extra expenses are either other variables and any geometry and you are exercising a thing that GLBO, then you can see that it is again. If you want to take in the geometry maximum, you can say that it is again here. That is, the geometry maximum is, that is the distribution is the close under geometry maximum. That is in fact means that the geometry maximum is. And you can see that the concept of geometric expressibility means that both geometric maximum and geometric minimum stability. That we will connect as to geometric expressibility. That is the product of the distribution, the geometric maximization and the geometric minimization. The concept of geometric expressibility is significant in probability theory and applied AD because it gives how extreme events from harmonious behavior into the distribution. So whether the extreme events that can be modeled with the same distribution itself or another distribution. And we can say that in the case of the GMF distribution, it is closer of the both geometric maximization and geometric minimization. See, this is the first that you can do between model and the distribution. Whether however, large the extreme event or the outlier, the outlier are under the same distribution itself, so that we can be able to model it with that relative. That's what that is. So this property helps to understand the behavior of the distributions and also provides insights into the extreme values behavior under certain conditions. So that is in fact the advantage of the distribution. I said that is in fact in modeling rare events and outliers. The geometric expressibility is valuable for modeling rare high frequency events like natural disasters, financial crisis, and extreme weather. All of these things, in fact, you can see that these are some extremely low. And the standard probability distribution such as Gaussian distribution to account for these extreme events. When the extreme value theory which leverages geometric stability offers more accurate models for the both phenomena, as you can see that our GMU plan is this one. And so it is in fact useful for modeling this type of range. And also it is in fact a long time distribution. That is when a real phenomena estimate long time behavior where extreme values are analyzed of within high frequency that is being predicted by the normal law. So the geometric stability helps in identifying and modeling these long-time distributions, such as Pareto, log normal, or power distribution, which are used in fields like economics, political sciences, and enablement of studies. And all distributions that we have proposed, research of the long-time distribution, which is in fact useful for modeling these types of extremely values and long period as compared to the usual competitors, such as Pareto log normal and power. And it is in fact applicable in insurance and risk management. And in risk management, especially in the risk type insurance, understanding experiment. That is the test process also is crucial. The geometric expressibility process aids the design of knowledge that can account for these rare but highly impacting. For example, the rate of the distribution representing extreme level plays a critical role in pricing insurance policies and calculating research. And your distribution, that is the distribution that we have today. It is the best maximum of the distribution that is used for research. And this is the study of robustness and stability of system. So if one is interested in the study of robustness and stability of system, it is in the engineering of network design and applied sciences. Systems are often defined to discuss extreme changes. The geometric expressibility property helps quantify the robustness of a system by predicting how it will behave under extreme or rare. And This is applications in the field ranging from telecommunications to infrastructure design. And we can see that our distribution is in fact it is very stable. And so that this in fact is robust with respect to this degree. And another area is in data analytics, anomaly detection. In this big data analytics, detecting anomalies or extreme values can be crucial for identifying fraud, cyber attacks, or malfunctioning systems. And the geometric sensitivity property of also a framework to study the behavior of our lives and understand this difficult data analytics. Another one is in the statistical inference that is extremely compared with geometric expressibility. Is the fundamental estimation of extreme quantity, and this is important in the fields like finance, calculating variables, hydrology, environmental science, and so on. The stability of extreme behavior and the scale transformation is essential for actual statistical inference. And the other areas in applications in answer social sciences in fields like sociology or art, where extreme behavior, extraordinary performance of potential events are studied. Under these situations, understanding the explain how is the system distributed and because from the insights into the dynamics of human behavior and perspective. And these insights can be moved. The geometry space stability property is rooted in understanding the behavior of things values in geometry distribution. And this has broad applications for finance, insurance to engineering, consultation, and even renewable energy. So this is the applications of that means you can do some properties of it and let it go. This is the applications, the various areas where the geometric maximum function distribution is successfully able. And if you look into the quantum function, you can see that the quantum function is able to work and the random very second. Well, these are some of the notable properties of the GMP distribution. You can see that it is a uniform distribution. It's a model distribution. And it is closely related with some random distributions. That is, you can see that you let explain having GMP distribution. And if you become the random variable y1 as the inverse of the GMP variable. And if you look at the random name of the inverse random variable, you can see that the random of the random acting of the inverse random variable, where the random variable is provided the GMP is the type of it. And if you take the exponential IED exponential random variable and n is the geometric 1 minus theta random variable, then n and f is are indifferent. Then you can see that with minimum this exponential random variable, minimum the random number of exponential random variables, and minus those where one is in fact by the GMBA. These are in fact connected with other distributions. And for the it's a connection with the binomial distribution. If it's so, it's the binomial entity distribution. And the prior distribution of the field evidence is from probability to success. So then when you take it as the prior distribution of data is real given, then you can see that the posterior distribution is again in the same. That is the GGS distribution. That is in fact the application in the Bayesian process. And if you exist here, we have kind of prior distribution people with standard data. Then again you can see that the GMBF, which is again in the BTS class, you can see that the prior is different in the posterior law. That is, it is again in the GTS. That is the GTS is the positive prior for the GMBF. And these are the parameters estimation rate. I am not going into the details. You may be able to derive the essential uniqueness of the parameter, MLE, and you will be able to find the estimates of the parameters and the variance of the MLE, and you can be able to find the confidence in that. And also you may be able to find the consistency capability of distribution, and from the data analysis, we have taken some data set, and we have seen that the data set, the distribution fits well. People versus competitors, additive influence, and upload it. So all those things as competitors for that, they may be able to support on a behavior. The RBA-based distribution performs well in terms of the performance of the KX, AEC, and BEC. You can see that for the use of this data, it is performing well. And these are the featured attack rate function, GTP, close of the data, and this information. That's the application of that one. Then we have applied this distribution in the characteristics product, and we can see that in the characteristics product also this distribution fits well, and we have considered that this autoregressive model, and we have fitted it, and we have seen that the AI expected more in this with the during this situation. We were in this situation. We can still consider that behavior. The excellence person will process with the behavior. And we have then illustrated. What is the communication illustrated? So in symbol that we have established that so the data set and then the scalability, indexability, reduce the resources, and have to use the resources. And then with this data set, which is taken from the science ministry petroleum and natural gas petroleum planning analysis study, we have illustrated that how the model, our model works for. What the model works in. What that was, first we have considered the parameter estimation within the TNS model, and then this we have transformed the data to the interval 0 to 1. And the transfer data, we find people get to the GRDS distribution, and we have seen that we have found the issues of the and we have seen that our model is better than this way. And these are different processes. We found that the longer distribution, that is the power function, hypergeometry, beta, galaxy beta, Kumaraswamy, and what we have special pieces of our family, that is linear distribution from the distribution. And as a special piece of it, we have considered the GMDS distribution that is capable of modeling data with increasing, decreasing, and water failure rate. And we found that the GMDS distribution provides better than other quality distribution on water failure. And these are some of the references. And this is in fact the standard of the other.
Thanks to Dr. Vedina. Any questions? If no questions, I'll start the speaker answering. Thank you.
Now, I invite Dr. Muhammad Farid to hand over a token of love to our honorary speakers. First, I invite Professor J. Kumar to receive the memento. Next, I invite Professor Jagannath Krishna to receive the memento. Now I welcome Dr. C. Suresh Kumar to present a memento to the session chair, Dr. Muhammad Farid TP, as a token of appreciation. On behalf of the organizing committee of ICSTC 2024, I extend our heartfelt gratitude to Dr. Muhammad Farid TP for graciously accepting our invitation and chairing this special session. Your extensive experience in academia, industry, and leadership has been an inspiration to all of us. We are truly honored by your presence and contribution today. I also thank the speakers for their thoughtful presentations and the participants for their active engagement and thoughtfulness during the session. So now we have a lunch break. The next session will start by 2 o'clock, so everyone should attend the sessions by the time itself. Thank you.
മറ്റേ പിള്ളേരുടെ സെക്ഷൻ ഉണ്ട്. അപ്പോൾ ഡിപ്പാർട്ട്മെന്റ് ഗ്രൗണ്ട് പറഞ്ഞത് സാധനം ഞാൻ അതിനകത്ത് പിന്നെ ചെയ്തു പിന്നെ ചെയറിനെയൊക്കെ ഓഫീസിൽ ശരിയാണ്. മോളുടെ പിന്നെ സൂചിതാന്നൊക്കെ പറഞ്ഞു പിള്ളേരോട് അങ്ങനെ പറഞ്ഞു നിങ്ങൾ ആരോഗ്യം ഞാനത് കേട്ടോ സമാധാനം മേടിച്ചോ സാർ. സൈൻ ചെയ്തിട്ട് സൈൻ ചെയ്യാനായിട്ട് മൗമിത ചാറ്റർജി എന്ന് പറഞ്ഞ ഭയങ്കരമായിട്ട് ഇത് ചെയ്തിട്ടുണ്ടായിരുന്നു. അവര് പൈസ ഇൻസ്റ്റിറ്റ്യൂഷൻ ഫണ്ട് നോക്കണം. ബിസിനസ്സിനായിട്ട് ഉപയോഗമായ ഇൻവൈറ്ററിന് മാത്രമേ ഫണ്ട് ചെയ്യൂ വിഡ്രോ ചെയ്യുക. ആ ആസാമാണ്. ഔട്ട്സൈഡ് കേരള അല്ല.
തരാം, ക്ലാസ് കഴിഞ്ഞ് തരാം. അല്ല തരാം.
നല്ല കാര്യമില്ല.
the main hole. Nothing is going to know. Nothing but the main hole.
രണ്ടേ കാലാണ് രണ്ടേ കാല് ഏലിയമ്മ മാം ഷിബു രണ്ടേ കാല് തൊട്ട് ആ സെഷൻ 3:15. പ്രോഗ്രാം ചാർട്ട് ഇതില് BS 8A എന്ന് പറയുന്നത് ഫോളോ ചെയ്യില്ല. അങ്ങനെ
ഫീസ് 11 ആയിരിക്കുള്ളത്.
BS 11 എന്ന് പറയുന്നത് ഒന്നും ഇട്ടിട്ടില്ല. അതെല്ലാം മെയിൻ ഹോൾ എന്ന് പറഞ്ഞു ഇവിടെ
ഓൺലൈൻ ആണ്.
ഇനി നടത്തിട്ടില്ല. വൈകിട്ട് അത് മെയിൻ ഹോളിലാണ്. മെയിൻ ഈ പ്രോഗ്രാം ചാർട്ട് എടുത്ത് ഇവിടെ ക്ലിക്ക് ചെയ്താൽ കിട്ടും. ഞാൻ ലിസ്റ്റ് ആയിട്ട് ഇട്ട് വരാം. CV എന്തായാലും കാൻറ്റീൻ ചെയ്യുമ്പോൾ കീനോട്ട്, പ്ലീനറി, സ്പെഷ്യൽ ഇൻവൈറ്റഡ് അതെല്ലാം മെയിൻ ഹോളിലായിരിക്കും. കോൺട്രിബ്യൂട്ടറി C, ബെസ്റ്റ് പേപ്പർ D.
Diagnosis, microscopic diagnosis is called histology. So tissue diagnosis is called histology. So lung cancer, again, lung cancer is not a single disease. It is a group of several diseases, and in that group, carcinoma, then other lymphoma, all those different types. So, but for lung cancer, you know that the main cause is tobacco use. So, carcinomas, these lifestyle factors mainly contribute for the development of carcinomas. So, that is the reason this lung cancer, mainly carcinomas. There are different types of carcinomas. So, one carcinoma, adenocarcinoma, then squamous cell carcinoma, large cell carcinoma. These are the common types of lung cancer. That is the microscopic diagnosis. These carcinomas are called non-small cell carcinomas, and again this is small cell carcinoma. So in lung cancer, it is divided into small cell carcinoma and non-small cell carcinoma. The disease has been increasing, cancer has been increasing, and then specifically we have looked into is it carcinoma type, which type has been increasing. That is what in this project, in this analysis we have made. So, in fact, how do we get the data from worldwide data? Worldwide, I have already mentioned Indian data. Cancer registries are operating, and these cancer registries are under the network of National Cancer Registry Program. And so our cancer registries are also under their network. So then India, it is, we know it is through cancer registry program. Then how do we get worldwide data? There are several databases like this is cancer over time. This is one database worldwide. Once in 5 years, WHO publishes cancer data worldwide pattern. So it includes more than 400 cancer registry data they publish. This is one database, and we get this is these are all 12 volume cancer incidence in 5 continents. So 12, this is the latest volume. Once in 5 years, this volume is published. This is made available to the public. So you need to know little bit coding and all to extract the data. Otherwise, it is made available to the public. We can for doing analysis, this data is made available. Another database is CEAR program. This is also available to the public, and the North American Association of Cerebral Cancer Registries. You get the data. You need to analyze the data. It is available. Another data is this Nordic countries, Scandinavian countries. They are also have data. And this is the ENCR, that is European Cancer Information System. So we have all these databases. In India, we have that data is not made completely available so far. Since lung cancer, you can see that among males, we have analyzed screening device. So you can see how the cancer in countries, this is declining. So you can see that the declining in American continent, not in the more countries. This is not that is declining like this. In Africa, Oceania, mainly, Australia, and New Zealand. This disease has been declining. In Africa, it is almost fluctuating, increasing there, but this disease is increasing. In Europe, again, it is decreasing. In some countries, it is decreasing, and in some countries, it is increasing. I have already shown. Then among females also, continent-wise, America declining, Oceania declining, then Europe also declining, then in Asia, it is again declining. Males, these are the declining trend among males. So then, but the pattern among females, it is totally different. So in fact, in America, you can see that in American continent, in Canada, it is slightly increasing, whereas in USA, declining. This is not a declining trend. In Oceania, increasing. In Europe also, it is increasing. Asian countries also, it is increasing. So, on one side, this various cancer control measures effective, started effective in among males. The other side, it is increasing among females. Then coming to the mortality, so incidence and mortality. This is in fact lung cancer. It is we know that it is once it is diagnosed, the prognosis of this disease is little bit bad. So once it is diagnosed, the survival rate is pure, very poor. Then if it can be detected in some in an early stage, then mortality rate little bit reduction. So that is what here we have observed. See, lung cancer, this is incidence and then mortality. So mortality also increasing. I am just lung cancer among males. We have what we have seen among both males. In males, incidence and mortality it is declining, whereas among females it is increasing in many parts of the world. The incidence increasing, similar to incidence, mortality is also increasing. We have looked into, I have shown several databases. We have taken lung cancer data from 35 countries with 36 population. In the USA, whites and blacks, the rates are different. So then we have chosen, we have taken both whites and blacks population. So here 36 population, lung cancer, and then this age standardized rate. We should always use age adjusted or age standardized rate, because age is always used is a confounder. As if the population is an old age population, naturally the rates will be high because the disease is mainly a lifestyle related disease. So that is the reason we have chosen age standardized rates, both incidence and mortality rates. Then we have taken all ages combined. Then we want to know whether this disease is younger age population, the disease is increasing. So that is why we separate, because age data is also available. We looked into the by age, then gender, both, and histology. I have already mentioned about histology. These rate, in fact, for cancer rate, we use the data per 100,000 population. So for just birth rate and death rate, it depends upon the unit is taken based on this. If the disease is rare, you know that the disease is cancer is a rare disease. So that is the reason here we have chosen per 100,000 population. So birth and death rate we use per 1,000 population. So rate is always having a unit. So we should just, it is meaningless 100, but 100 rate, it is meaningless. We should always use unit also when we say rate. So that is why per 100,000 persons, and we extracted data from these database cancer over time and the cancer incidence in 5 continents. I have shown you those publications, and the database also we can retrieve, we can extract data, and we have taken both these databases. And these are the various continents or countries under these continents. There are 36 population data, cancer data available from various 2003 to, in some countries 1993 onwards, in some countries 2000 likewise. This is the starting point of various countries and end point of the data available in some countries, more than 50-year data available. Then we use for India, I have already mentioned that cancer registry data. This is already under this program. In Kollam district, there are 30 years data, and for Trivandrum, we have 16-year data. That is also used, but mortality data in India we don't have, which is lacking. So that is the problem. When we used joint point regression model, I will show you some results why we have chosen joint point regression model rather than nonlinear model. So then that was used to analyze the trend over time by fitting a series of joint straight lines on a logarithmic scale. And this is for our data. 0 to 4 points were used to, and in fact we used crude rate. Our crude rate, this is not for comparison to assess the magnitude. We used crude rate. Then annual percentage and average annual percentage confidence interval. We have used, and permutation test was used to assess the optimum joint point. This is joint point regression model. So model for both in the worldwide for worldwide data, both incidence and mortality rate, and this is X calendar year, and this is the model, and these are the regression coefficients, and K get the join points. It is suppose there are 5 join points, that is the optimum point. Then K is equal to 1, 2, 3 up to 5. The logarithmic transformation, in fact, this is joint point regression model also. It is logarithmic transformation, log linear regression model. Worldwide data 0 to 5 joint points were used, APC and permutation test failed. So this is an example of this is Australian data among men. You can see that a monotonic decline. We have already seen that the rates are declining. So then we can see that a monotonic increase here, a join point. So 2 join points. Here we observed monotonic. Here also, if it is monotonic decline, join point will be number of join point will be 0. So it is like that. So here, in fact, incidence it is almost linear, whereas mortality you can see that increase and decline. So here in such a situation, this numerical transformation only a model cannot be used. So that is the reason we have considered joint point regression model. The same joint point, more number of joint points you can see when we split up the delta by histology. So you see now cell carcinoma, the small cell carcinoma, all these adeno, small, and satisfied with these three accounts, cell carcinoma. So then this contains in fact this is the point that only joint points we have observed. Here, and then here all ages, 3 joint points. This is when we split up the age, then we have 2 joint points, again by age. When the less than 60, also more than 60, even that also the number of optimal joint points are different. So when we see the pattern among females, the number of joint points are higher than pattern among males. See here, how many joint points are 3, here 3, 1, here only 1 joint point. When we split up into this is under 60 and more than 60. So now let us see the pattern among the worldwide. So here, see this blue line indicates incidence and red indicates mortality. So you can see that almost in some here, blue and red almost the same. So what does it mean? So many cases in the same area when they are diagnosed. So that is here. So here in fact blue line is very high. I'm sorry, this is right, this is current. So white indicates for both blue line indicates incidence trend and red indicates mortality trend. So decline, this is the left side, if the graph is on the left side, it is minus, so it is showing decline. So you can see that this is APC of lung cancer. Among men, we have already seen that this is declining, and these are this is not readable, but still, these are, I know that these are various continents. This is America, North America, South America, this is Southern Europe, Western Europe, Southern Europe, this is last is Asia. So you can see that in Asian countries, the graph is on the other side. It shows it is increasing. Asia, whereas in all other parts of the world, it is on the left side. Left side shows it is declining. And except in a few areas in Norway, see here, it is increasing in both the annual percent change is on the plus side. It shows increasing. This is the pattern among, so almost a similar pattern. This is under 60 and this is more than 60. This is we combined all ages and this is under 60 and more than 60. See here, more than 60 when we in that age group, it is increasing. So in the moderate in the Asian countries, they are increasing higher. So this is on the plus side, increasing side, the average annual percentage is when we split it by age, so percentage, less than 60, the rates are declining. Almost all areas, especially in Asian countries, so they will also increase. So that means the compensation programs are necessary. So in average population, rates are declining, which indirectly indicates that the succession programs are because these statistics are combined for cancer control. So this is the way we evaluate cancer control programs. And when we see the pattern among females, see here, females on the plus side. Percentage, you can see that in some cases, very high, but here is this difference. Incidence, percentage is high, whereas red line, this is blue line, incidence, and red line, mortality. So it is considered that the increase is almost the same, not as almost the same as incidence. So the percentage increase for mortality is slightly lower than the percentage increase for incidence. So this indicates that cases are detected in at least in some early stages. So they might be having the screening program for detecting this disease in early stages. So when we see this incidence and mortality, this ACTC annual percentage, that is the way we evaluate the cancer control programs. These measures are by histology. Here, this is large cell carcinoma, and this is very important. This red is for adenocarcinoma. So disease is declining for all these non-small cell carcinoma. You can see that the graphs are on the left side. So that this, except in this red, the graphs are almost on the left side, which shows decline. So overall, the disease has been declining, but the decline is not for all types or histology types. Decline is mainly for non-small cell carcinomas. It's not mainly for non-small cell carcinoma, small cell carcinoma, large cell carcinoma, squamous cell carcinoma. Whereas for adenocarcinoma, decline is not that much there. So in fact, the adenocarcinoma is not mainly a tobacco-related cancer. That is the reason we have observed large number of women lung cancer cases are detected, and we have made the statistics according to histology, and I have shown you in one slide that the adenocarcinoma of women, it is 56%. So women are not smokers, but still, why the disease is occurred? The type is adenocarcinoma. That is the main point that we have observed consistently adenocarcinoma. The portion has been increasing in our registry data also. So this is the same pattern. Whenever the disease has been increasing, it is mainly adenocarcinomas are increasing. That is the one finding. So then here also this is among women. See, red is on the other side, whereas for all other types, this is This is large cell carcinoma. This is small cell carcinoma. This is squamous cell carcinoma. So all these first three are called non-small cell carcinoma. Among these non-small cell carcinoma, adenocarcinoma has been increasing. So we used for the kind analysis. In fact, coming to the methodology, we used adeno model to predict, forecast the disease, assuming that if this is the patient, what would be the next 2030, what would be the next 5 years, magnitude of this. We use adeno model. In fact, in some places we have obtained some 50 points, data points, but still adeno model for cancer forecasting model we use but the data points are small. I agree with you. Therefore, when we assess the forecast error, that is the main tool for measuring the accuracy of this model, then we use the bootstrap technique for resampling the procedure to minimize the bootstrap forecast error. This is the procedure. We convert the original data in the stationary series by decomposition method and then resampled the data. This is the model. So divided into set and tested set. So we have seen that 50-year data. We have primary data 50 years. That 50-year data, 75% we use as set and the remaining data. So not the overall data. Remember that this is summary data, and among the summary data, 75% of the first is, for example, if it is say 50-year data, then it's 75% percentage here. We divided it for sets and the remaining for test sets. Then we used box transformation to stabilize the variance of the data, and this method was used for estimating the parameter, and we restricted the interval to the 0 to. Then data decomposed into primary and remainder component, and local polynomial regression smoothing of models also used. Primary component was fitted and remainder component was the residual for both methods. Stationarity of the test was assessed using this. So the data is stationary, we again transform. Box transformation is applied. Then independent and identical resampling method to generate the bootstrap series. Then data consisted of n observation. Bootstrap series was obtained by setting n observations pattern with replacement scheme and then combining selected observations together. The same order of observation when we use adeno model. This is the software we use for forecasting using adeno model. Then bootstrap aggregating value was used for the final result in forecast. For each bootstrap series, forecasts are calculated from the specific adeno model. Resulting forecasts were combined single mean and single median for final aggregation. Forecasting error accuracy was assessed by numeric inaccuracy. In fact, this analysis was carried out by one of my research scholars, Dindo. So he estimated the forecast error by handling method also by ordered and for removing the nuclear variation. And this method consists of one random method to each series, and then we put the smallest value for least analysis. So then we compared the accuracy, we chose the best model to train the data, and then computed point forecast, calculated the forecast error by accuracy, and compared final forecast error of resampled and multiple data models were computed and taking out this many data sets were And we forecasted the rates till 2030 with best reasonable model. Here we used the data for only 2 minutes. This this flowchart I have already mentioned. Then this is original data and resampled data. Okay. And we have observed this previous this red indicates the best. We observed the least error. Is local polynomial regression mean and mean and the ranking also we have observed this is the least. So this is Australian data I have shown earlier. This is VS.LPR. You can see that here by variation, here in bootstrap technique. This is original. So this is variation is so this is these are the classic line cancer and then this is classic by us. So then all these like 36 regions are using this bootstrap technique and these paperwork is almost completed and these are the same results which these are the points indicates the forecast values. That's the income. So we sample the version. So cancer incidence data provides better performance for forecasting compared to original data, and also we found that the predictive power of the model that is very important for forecasting cancer incidence more accurately. Otherwise, the results will be either overestimated or underestimated. We need to be on what focus research is needed to identify the reasons for that is particularly in India, world manufacturing increasing is very important for targeting cancer control programs. Thank you. These are the references. So minutes from that.
Any questions or comments? Just times this with the website.
But still the question why cancer is the skin and also its disease has been increasing. We will actually want to type for adenocarcinoma, isn't it? That is what isn't it? So you are putting out there at a signal. So disease is declining. Most parts of the world, there are most disease for tablets declining in the field. What is this almost we know that tobacco causes which is for association. Tobacco causes cancer. We can say that. So causation and association statistically we can say we can use the term association. Here I use the term causation. At least carcinogen it is tobacco components. If you know that it is causes cancer. But why this is still? I have shown that adenocarcinoma still. So studies have shown that this is not healthy tobacco-related cancer. Adenocarcinoma is why it is still. contains many components like PM component, PM chemistry, air pollution, components like PM component, PM chemistry, we have observed I think this paper, anyway, we have done a geospatial analysis. Have you listened to this morning session, geospatial analysis? 3%, not for the cancer, but the breast cancer, spatial analysis, very tricky. So, area wise, she correlated air pollution and another study, we did another study correlating air pollution and where is these components going to be cancer in our area. We have observed association. We have to put into 0.500 this is pollutant components. We have some association with the cancer, particularly in older age population. Older age population, the accumulated loss will be most effectively unfortunately, this not association was not observed among 60 years or higher than 60 years. Correlation should be she is also one of she is called 2%, and she published that in also. Older population is spatial analysis in Canada, and therefore association being important people and we are getting and so on. Air pollution components. So air pollution is another piece of the weed. It is less particularly among trees.
This speaker is Dr. Sidhu, and he is talking about the topic neglecting zero-contact castings. Sidhu, please.
First of all, I wish to express my sincere thanks to organizer of this paper. The title of my paper is Zero Target Cost Distribution Engine Regulating Expansion. In this paper, our main focus is to consider this zero target cost distribution using regulated expansions of the second kind and first kind. However, we have shown that some distributions belongs to this regulated distribution of second kind can be included in the regulated distribution of first kind. There is some theoretical aspects of this model are studied. There is a distribution in this models we are in regression analysis due to the flexibility of the distribution. There is it is under dispersed as well as over dispersed in some distributions. Also, the variability aspects of the model are also considered. The parameters of the model are estimated using MLA. The performance of the MLAs are using simulation techniques. Also, some real-life data sets are provided to the real application of this model, especially in COVID data sets. Then, that is in the iteration especially, this control and family. Also, this Garvey and Lowe and Killian's Lee
provided a detailed account of this Lagrangian distribution. There is several Lagrangian distributions belongs to this category. Some of the prominent distributions are this generalized negative binary distribution, there lies the geometric series distribution, there is a postal distribution. Also, this control and family define the Lagrangian covers distribution using Lagrangian distribution type first. Also, this Lagrangian showed that Lagrangian covers distribution was a subclass of the generalized only Eigenberg distribution. Also, this Kim and Lee obtains this Lagrangian covers distribution as a unique distribution of the Markov Fourier distribution. Also, the same authors discuss in the application with Lagrangian covers distribution to time system. Also, in detail account of this Lagrangian expansion second time was also mentioned in detail in the books of control and family. That is some of the distributions belongs to this category are this Riemann distribution and this Harris distribution. Also, in the works of this control and family, he provided an idea about the introduction of Lagrangian type distribution belongs to class 2. Also belongs to class 1 under some conditions. By inviting this motivation, we incorporate this result to Lagrangian the zero target not distribution also. Therefore, that is we derive this Lagrangian zero target covers distribution using Lagrangian expansion the second time. Under some conditions, this value also belongs to Lagrangian covers distribution of the first time. So, the basics of this Lagrangian expansion is the basic idea of Lagrangian distribution. This Lagrangian expansion is two functions we define this K1 is and K2 is with some assumptions this K1 is and this K1 this K1 is and K2 is are two identity functions defined as minus 1 1 which are differentiable with respect to either. Also, there are two power series expansions where respectively given the equation number 1 and equation number 2. Then from this Lagrangian power series expansions, we derive Lagrangian distribution of first kinds. It has the probability of function given equation number 3 with the conditions this K1 is equal to 1 and K2 is equal to 1. Also, that validity condition also holds. This is the probability density probability mass solution of Lagrangian distribution of first kinds. The class of Lagrangian distributions given equation of 3 we denote by LD1 this K1 is K2 is they are respectively called as the transform function and transformer function. Then we have shown some distributions which are based on this LD1 type. The one is the generalized covers distribution. That is this obtained from the by choosing K1 is K2 is in this way we can obtain this F1 part. Similarly, generalized postal distribution. Then in this occasion, if you choose this K1 is equal to say organized to all 5 is minus K2 is equal to normalized is minus 1, then we can obtain generalized distribution. Similarly, now distributions belong to this category as generalized binomial distribution. Okay. Then Lagrangian distribution second times. In this case, one more assumption that is apart from this K1 only is equal to 1, K2 only is equal to 1. We achieve this more condition, then we can obtain the probability function of a distribution belongs to the Lagrangian distribution of the second time. Okay, then the weighted console distribution. These are the distributions belongs to this LD2 type. The first one is the weighted control distribution by choosing this K1Z and K2Z. And also, that receptor condition also holds. Then the rectangular postal distribution, this is by choosing this K1Z is equal to alpha it is a minus 1, K2Z is equal to 1 minus Z raised to n by 1 minus n into 1 minus Z. The other one is the rectangular binomial distribution. Well, in this paper, our aim is to construct the Lagrange zero triangular cost distribution by choosing the K1 results and K2 results as given in equation number 6. With all these conditions, this K1 is 0 is equal to 0, and K1 is equal to K2 is equal to 1, K2 is equal to 0. We obtain the probability sums of the Lagrange distribution of the second values. This is the definition. Then we plot this the graph of this element kb alpha beta gamma for different values of alpha beta gamma. From this figure, you can see that this figure is not going to be decreasing for increasing the values of the parameters alpha and gamma, and also decreasing values of parameter beta at the value of this y increases. That is also the graph takes on a bell-shaped appearance of the value y increases in both alpha and gamma parameters increase with the parameter beta line. The other rate function is also given in equation number 8. For beta equals 0, this area is kd becomes y as 1. Then the following indicates the graph of Elizabeth kb for different values of the parameters alpha beta. Also, the hazard rate function is formed. Then some mathematical properties of this model are considered. First of all, these are the basic things. That is, we obtain this median. This can be obtained by using some mathematical software. That is the mathematical R. Similarly, we can construct the model distribution. The probability generating function. By using that transformation is Z is equal to some u into g of Z, where g of Z is given. The condition alpha is less than 1. This is the probability generating function. The moment generating function is given in equation number 14. There is the conditions. Some x is equal to b minus beta by alpha into log 1 minus 20, where x is less than minus log alpha. The distribution of sample sum in W. Like the factorial moment of the distribution is given by GSU. Then the index of dispersion, that is the coefficient of variation. The skewness and kurtosis coefficients of the distribution are which cannot be expressed in a closed form. Therefore, these coefficients are essential to characterize the shape of the distribution. Also, we compute these statistical measures for different values of alpha or beta gamma. Then from this table, the following table, we can see that if alpha greater than 0, beta greater than 0, this distribution exists around this person, and alpha tends to 0, beta tends to 0. Then we have to kd except the alpha this person. When the parameter value gamma increases, the mean and variance of values of kd increases. Moreover, it is known that kd has various kurtosis levels and is mainly against. The following table gives the statistical measures like mean variance, points variation, kurtosis, etc. Then the next we establish the relation between this LD1 and LD2 distributions. But there is the next K1 is equal to K2 Z and then excited by V and the values with the distributions in this LD1 K1 Z, K2 Z and LD2 K1 Z, K2 Z respectively. Then this probability of y is equal to t is equal to t plus 1 into 1 minus k1 dash 1. Probability of x is equal to t for all values of t. Then This pair, the two says the condition under which the class distributions belongs to LD2 is also a member of LD1. Why these conditions? This K1 is the K2 is the K3 is the analytical functions because of extremely different figures. And in this K1 0 not is equal to 0 and K1 1 is equal to K2 1 is equal to K3 1 is equal to 1. And define K3 in terms of this K1 and K2, then we can include any distribution of LD2 also belongs to LD2. Then the estimation part, can we estimate the parameters by using maximum altitude estimates? Then okay, this altitude function is given in equation 1. We differentiate this parameter with respect to alpha, beta, gamma. Also, there is the we prove that the second that is the natural functions no okay, and the Gaussian matrix of the second order which is negative defects. Then we obtain the parameters of alpha, beta, gamma by using the mathematical software. There is non-linear activity equations. Then also there is by using the fit disturb plus package of R Studio. There is we started some trial values of these parameters and finally the initial the final values are obtained after checking the convergence of the final system. Then we make use of the negatives what to see the significance of the initial parameters involved in the distribution. A simulation study is carried out to evaluate the performance of the estimates obtained by national algorithm estimation. By using the inverse transformation techniques, the following is information algorithm for generating samples from LSF3D. The digital results. First of all, we generate samples for uniform distribution. Then we define T is there, then F is equal to P. If E is less than F, then X is equal to I and so. Okay, then after this, by following these steps, this iteration procedure was repeated for 4,000 times and the parameter steps were calculated. We computed this average, which means average absolute where using MLE. Also, the table 2 provides a summary of the studies for samples of varying sizes as sample size increases, and for the three parameter sets, it can be seen that MSTs are in decreasing order, and the release of the parameters become close to their original parameter values, indicating the consistency property. This is the followed by the table. The relation for different parameter values alpha, beta, this is provided to examples. That is the first one, the daily population reported, and the second one is the number of fatal cases due to COVID. Also, we consider some competitors to this model. That is some of them are okay. Is a PPT, AG, PST, ICSTC, AGST. The husband function of the data sets was determined using the graphical technique by the total time meters. If we found this convex, then concave or convex, or concave then convex, the corresponding HR has decreasing, increasing birth subset or an upside birth subset, especially then these are the descriptive based on the data, the descriptive measures of the minimum first quartile, median third quartile, maximum in the quartile range, or even table 4. This is the DP box. Also, we compute the information measures AIC, BIC, and base value. Table 5 displays the corresponding MLEs, model identification methods and textual values. You can see this table there, the model identification methods and textual values of the LZ daily are lower than those of other surveillance distributions. Another example is the daily death case of COVID-19 datasets. The datasets that is the COVID datasets taken from Bulgaria and Bulgaria in Europe, in this this case also we repeat the same procedure. In both the datasets, we can see that this model fixed value.
Foreigners are involved in communication.
One of my colleagues is Dr. Chesney. He's working in US.
What is their contribution?
He's called, he's an older Indian. His contribution is mainly on the data analysis part. Data analysis part.
Simulated data also. Simulated data and real data.
In both cases, this model fits that.
So what is your conclusion?
Conclusion is that is why in case of the medical data sets, especially COVID data sets, this distribution finds a better model compared to other existing competitors.
Medically, in fact, this is an epidemic. This kind of epidemic. So that in fact cancer.
Not cancer data, not cancer data, but more data.
Cancer. Chronic diseases. This kind of sudden appear out.
Okay.
This is non-communicable diseases. Others are non-communicable. Communicable diseases. You can check the non-communicable diseases also. Whether it is COVID, no, it's not COVID. It is not COVID. So you can check this distribution between other communicable diseases. Communicable diseases. Data will be available.
So in this occasion, this model is better.
Not wrong, very well.
Very good.
To utilize this model for other communicable diseases, other medical systems, this can be done. But
Thank you.
Now, as a token of our gratitude, we would like to present mementos to our esteemed speakers. First, I invite Ariana Matthew to kindly come forward and receive the memento from our session chair, Dr. K. Jagan. Next, I invite Professor Shibu to join us on the stage to receive the memento. Now, I would like to invite Dr. Ariana Matthew to present our session chair with the memento. Thank you, sir. Thank you, sir. On behalf of the organizing committee of ICSTC 2024, I extend my sincere gratitude to Professor K. Jayakumar for gracefully chairing the session. I also take this opportunity to sincerely thank our esteemed speakers, Professor Shibu and Dr. Elena Matthew. Both presentations have been a very informative and enriching experience. We are truly grateful for your contributions today. I thank you all for your active participation and keen interest, which has made this session a success. Thank you all. Now we shall have a tea break and sessions will resume in online mode after the break. Thank you.
Please
start the session. Initiate the session with your other experts. Professor K. Swaru is with you. Professor Khalid is also with us. Good evening, Professor Sushma, my dear colleagues. Good evening to the candidates for the short discuss for making presentation in this course of ICSTC model of institution follow.
Yes, sir. Yes.
Yes, sir. Okay. Good evening, my fellow jurors. This one and Dr. Farid. We are given with the three shortlisted candidates. Sir, Sushma sir,
Yes.
is there anyone from the organizer side?
Yes, sir. Please, so return your camera.
Sir, can I check that whether shortlisted candidates join the meeting?
Yeah, all the three are joined.
All three are joined. But you can call this call them. They are available. Yeah, I will say. Yeah. All these okay. They are switch on their cameras. All right. Okay, please. First, let me invite Madam Professor Bala and Professor Farid.
Yes.
Sir, shall we start the session with the first candidate?
Yeah. When is the other third jury, sir?
Yeah, I am here.
Oh, yeah. Okay. Yes, sir.
Sir, please.
The first candidate is Dr. Veerana. The title of his thesis is Bivariate Pseudo Modeling. Dr. Veerana, can you join the meeting? This is Viru Sukya. Can you join in the other name? I will take the name, but email ID, sir. This is Girish. Okay, Madam, Madam Balu, please speak from the organizers, by the organizers that each candidate can make a presentation for each candidate. The candidate is allotted for making presentation, experience for introduction. I say, we have 25 minutes. You can give a presentation and 5 minutes for 20 minutes for presentation and 5 minutes for introduction. 20 or 25, that's the few. I started planning, that's why I'm asking, that's it. So what can I say? Maybe that's 25 minutes for presentation and 5 minutes for introduction.
Yeah, that's okay.
Sir, please, Sushma sir, when it discuss you questions of your opponent. This will take 1.5 hours. Yeah, we have 1.5. Let's begin with the first candidate, Veerana. Yes, sir. You please start your presentation. Yes. Visible, sir? Yes, visible. Yeah, visible.
Thank you for this opportunity for initiating computer. This was sufficient me. Myself, I'm from University of Hyderabad. My thesis content is direct photo only. I submitted, I awarded 2023. I'm currently working on BSc CAS, Varanasi, BSc Varanasi. This is the content of my thesis. Introduction to Bayesian inference conclusion. Actually, three chapters of this, but I consider it as a main 4 chapters. Bayesian inference and the goodness of faith, Podan data. This is my motivation. Any classical very normal distributions have or normal margins like that x level and y level function. Then especially y bringing x power and say it's also normal. Similar when condition structure is there. This is the Pareto distribution. These are also both marginals and conditionals are being model and structure. This is the equation number 1. And this can also Pareto distribution type 1 also. And another is the classical bivariate bivariate Poisson distribution. These also here 3 independent parameters, independent Poisson random variables x1, x2, x3. X equal to x1 plus x and y equal to x2 plus y x3 inside this is not function here not one distribution condition are Poisson. Here HCl also for Poisson equation number 3 and X is also Poisson. Number 2, number 3, 4, according to the theorem of 4.0 Arnold, in 1990, the joint mass function of x and y in form of this equation number 5. Here, number 3 is equal to 1, then x and y are independent. Here, both x and y are Poisson conditional or Poisson. And it is there. A previous example of this kind of one which x and y are independent Poisson variables, but there is no example exists. So consider the following theorem, Seshadri, and I considered this theorem in 1964. We said that for any given dependent bivariate distribution of x and y, the following statement holds: if x is a Poisson, the conditional distribution of x given y is not a Poisson. The conditional distribution of y given x is Poisson, then marginal distribution of y is not a Poisson. That is, simply conclude that one could not have non-trivial distributions with x having Poisson distribution and finally y. When x given y is also here y x given y is also Poisson distribution. So in this previous studies, conditionals and both marginals are different. Now we choose this problem. One conditional or marginal and one conditional one marginal is a Poisson. Here I definition we have 2 dimensional random variable x and y is said to have Poisson distribution. If there is a positive under lambda 1 such that this follows Poisson parameter lambda 1 and the function that will be non-negative integer x. Y given x follows Poisson to lambda x. And lambda of x is used to incorporate the varieties of the properties such as positive or negative correlation and or equidispersion. here we restrict the form of the lambda x be a polynomial with unknown position. In particular, the simple form we assume that in the lambda x equal to lambda 2 plus lambda 3 is a linear function. Then I know the value distribution will be form of equation number 6 and 7. This is like form of the there is a parameter space is the this is a parameter space here lambda 2 strictly lambda equal to 3. If lambda 3 equal to 0, x and y are independent. And we calculate this PGF from the genetic function with equation number 8. And if lambda 2 equal to 0, then we look at the Arnold sir and Manjuna in 2021 article. The marginal distribution is a even clear distribution with lambda being the index of curve. Now the marginal mass function of y is given equation number 9. Here y has a polar distribution with the parameter lambda 1. By lambda 1 is Poisson distribution with lambda 3. It's also Poisson instead of Poisson distribution. So it's a Bayesian inference for the pseudo Poisson distribution. Equation number 10 is the mass function, direct mass function, and here the positive function h of x comma theta is a point arbitrary and theta is a parameter vector. Here we consider the sum model of is a linear function involving two dependent parameters. Will be focused on the present work. Here denote with three parameters and next function the complete model is the equation number 11. This is the joint mass function of the direct pseudo Poisson distribution. So here we likelihood function of the likelihood function equation number 12 and their factor likelihood factor is equation number 13. Here the factorizations will be to the improvement and importance of the Bayesian inference for the model as is given. Because the factorizations we know that if the pair and lambda 1, lambda 2 and lambda 3 are independent, then they will be independent of positive also. So we consider equation number 11 in nature of it. So assume the gamma of pair here also normally we gamma pair the marginal parameter lambda 1. Finally assume that equation number 40 this is a density function of lambda 1. The choice of the distribution density of lambda 2 and lambda 3 will be independent of lambda 1 is not so obvious. So it means whether it is possible to choose the will be conjugate or not. It is so we consider independent pair. All two parameters are independent. The each parameter has follows gamma distribution. Then it will be equation number 15. Then the kernel posterior kernel of the posterior will be equation number 16. This is the product of the kernel of the equation number 30 and the kernel of the pair equation number 50. So we compute the posterior distribution kernel of the posterior distribution density, and we compute the posterior means lambda 1. It's also form of gamma distributions with parameter alpha 1 plus sigma summation xi and delta 1 plus L equation number 7. Then the second factor of the kernel posterior distribution lambda 2 and lambda 3 is not numerically. So in this case they consider two cases. One is the first one is the we focus on the first one is the lambda 2 equal to lambda 3. So happened in the equation number 11. So lambda 3, the model will be become to equation number 18. We will compute the same likelihood functions, equation number 19, and this likelihood factor, equation number 20. And we choose the conjugate pair density of the two parameters of the model B is the independent gamma model, equation number 21. And we compute this again. We will compute posterior internal of the posterior district density, which is number 22. We need to perform that our choice of the prior independent gamma marginals once they constitute likelihood in equation number 20, and that posterior also two parameters also independent gamma distributions. So we have to compute the posterior only one. We calculate this square error loss estimate of the posterior means. These are the equation number 25 and 26. So the resultant of the basic scenario points at the corresponding images. Another model is that if lambda 3 equal to 0, the model will become equation. This is the form. Here x y equal to the first x equal to 1 to 1 and y equal to 0 to 1. Second, if not exists, if x and y equal to 0, it is equal to lambda 1. So in this case, the factor of sample size n from the distribution is given the following expression is which indicates n denote the number of observations from values of x that are equal to 0. So this is an equation number 27. The likelihood factor is this is the likelihood factor, and the kernel of the likelihood is given by equation number 28. If you choose the prior independent two independent gamma monomers, such as equation number 29, then we consider the again posterior distribution equation number 30, and we confirm that our choice is prior independent gamma marginals are constant, and with the means lambda 1 and lambda 3 is also follows. These are equation number 31 and 32 are and they calculate the error loss estimate for posterior means. We have given calculate question number 33 and 34. And here we introduce another prior information is a pseudo gamma prior. We introduce which allows to the external information dependence between the parameters, and we know that the hyperparameter Z3 is a pseudo gamma prior that plays a crucial role in the defining the prior dependence between the lambda 1 and lambda 3. Here, the importance of the considering the pseudo gamma prior in the developing the posterior inference and reduce the computational complexity and also a closer form expression of the marginals. We consider some special cases of pseudo gamma distributions and layers. And this analytical computations and simulations algorithms are easy to implement and hidden integral consider the following. So we still consider the lambda 3 to lambda 3, and this is the equation number 25, and this we will consider giant square is of the bivalent pseudo gamma prior. But if you assume lambda 3 as follows, gamma with tau 1 diagram, this is the density, and for each value of lambda 3 has conditional distribution density of lambda 1 given lambda 3 is assumed the gamma distribution form. Because infinity practical it will be linear form when it is a function of lambda 3. This is the form. Then the giant prior is form is equation number 36. Here we again we consider in this Soro gamma prayer, we assume again Z2 equal to Z in Z2 equal to 0, the prior density will be form of equation number 37. The corresponding posterior density density corresponding to the sample size n from node 1 will be equation 38. And the marginal posterior distribution of lambda 1 and lambda 3 are equation number 39 and 40 respectively. And if you see again similar to lambda 2 to 3, this is the function, then functions and their likelihood, and this is after the equation number 42, and then we can again the kernel of the likelihood is the equation 43. Again we consider simple Soro gamma prior with assume that Z2 equal to 3, the equation 40. Then we consider the posterior density equation 45. And the marginal posterior distribution of lambda 1 and lambda 3 are equation 26 and 46 respectively. And here when to the simulation study, we go to the marginal and conditional computation, this Soro power distribution. When we do steps, so only the first step x power of power which is lambda 1 and next step we will similar to y from then we will lambda 2 plus lambda 3x. In this section we will the gradient inference for the Soro distribution. Gradient inference, the prior distribution is not full model independent gamma prior also. We need to relate it to the numerical algorithm to compute the marginal distributions and rate moments. So we use using different concepts to simulate the observations from the posterior distributions under the all prior, improper, independent, and pseudo. And so food model and submodels. And we have simulated 10,000 data sets using metabolized algorithm with thinking at the time of and each posterior distribution of lambda. And we generate the sample set, different sample sizes n equal to 10, 30, 50 million, and 250. And we calculate the mean and from the posterior 95 confidence interval for the mean below tables. We compute from then from the iteration of the process. This is the fixed parameter value. This is the coding model parameter value we assume here, and this is the submodel of the submodel 1. Is equal to gamma. We fix the parameter values, and submodel 2 also similarly. We consider the here we can plot the posterior density plot of lambda 1. It is the gamma prior and improper gamma prior. In this the values converges to two values. So the values the equal gamma prior are converges to values. Here see the last first picture and last picture is increase the sample set which will be converges to two values. Similarly, we calculate the density to have also and lambda 3. And here also is the submodel of lambda 1 and lambda 3. And density function of density to lambda 1 and lambda 2. And this is the significant data means we
have 5 more grades to complete.
At least we explain this concept. Okay, sir. This is and we consider the one more data set is a independent study data set. This is the correlation position. This is the policy correlation. In this will be equal to the confidence interval and means. This is the another model is the action data set. This is also here we have calculated the data set. Here we can more goodness we can test for the Soro power model. Here this is the condition. Text based on the this is the new text based on the movements. Equation number 38, 40, and within the random vector Z, their movements are calculated dispersion index is the Balliard equation number 50. It is a over dispersion index. So, and we compute the new Balliard goodness of the Fisher distribution equation number 51, and the null hypothesis is rejected at the larger values of f. Distribution statistics is the equation number 54. We equation some models of the number 3 to number 0. These are the and we consider the and we compute these techniques, and this is also there. And we contributed these supremum tests in the following proposal. The proposal test will be supreme. The absolute values of the KK test with T1, T2 over the minus 1 to 1, minus 1 to 1. The goodness of the test will be 60, equation 62. And also noted that asymptotical distribution with is a typically uncertainty. When the final distribution will be analyzed. When this is a transfer goodness of test with K plus to K component. This is the question number 63 is the test statistics. Here this follows the transfer distribution with the K1 K plus 1 K plus 1 into K plus 1 minus 1 minus 3 because of the and here also we compute the this is the we compute the empirical P value. We compute the empirical P values. These are control function. Model 1 and 2. And finally, we can analyze the power analysis also. We can compare the Balliard Poisson and Balliard Maxwell Poisson distributions with the certain parameter values. And we can be same data set. We can also calculate same data set. There is empirical P values. These are the P values from different test statistics. Please say this is this one. And after that, the pseudo-Poisson distribution may be considered as the first choice of the modally data whenever the one marginal is a weakly dispersion and another marginal source is good dispersion. And due to the simplicity of its structure, the pseudo-Poisson is always reduced impulse relations and the side for the classical and Bayesian inference. The pseudo-Poisson pairs which are in and then both choice for Bayesian analysis with dependence on the pair. We implement a new test based on the various index of the dispersion and supremum of the absolute difference between the calculated and the empirical probability generation equivalent. And the new this test will be reproduced and analyzed. These are the references. Thank you.
Very nice. Congratulations, Dr. Veerana, for making the presentation on time. You have completed on time. My congratulations for carrying out a very good basic analysis for the bivariate sort of distribution. Now the session is open for interaction. Members of the jury board, Madam Ronald.
Just wait a few minutes if audience have any questions. If not, do you have any questions?
I invite the jury members if they have any specific questions.
Congratulations, Dr. Veerana.
Thank you so much
for making a good presentation. Can you justify the title of the topic?
This is a Balliard modeling. In this modeling, we consider only one distribution. Because of this distribution, directly answer regionally. So why I consider these institutions or this group, what is this group of you or the here in the political and literature, not only about possibility is and both manners are there and in the how that become here in this case one module and one condition are not there in the literature. So it considers and one more and consider this. And here we is there parameter value is not constant. It is a linear form. Linear form of linear form will be linear form. And like lambda 1 plus lambda 2 plus lambda 3 is. In the open problem is also there, in solution case also there. We work with consider the linear case. Here we have linear case only. We consider a formula case also.
Well,
We consider this problem.
okay.
Let's see also. The opportunity is this will be in give this model.
Okay, very good. So, sorry. Yeah.
Let's start up for a nice presentation, and I think it's the one thing, first, what would like to destination? Do you have a specific maximum like to destination, or it has to be handled by the
In many we medicine. With the postal distributions, their margins are also followed again prior distribution. So that's why we consider the pure material sir. And if the hyperparameters are equal to 0, it really coincides with the original case of classical model. Similar is the same. It will coincide with the original images.
What is the meaning for lambda 3?
Actually, lambda 3 is
This question is whether it is covariance.
Lambda 3 is estimated lambda 3 is alpha 3 plus summation xi is greater than that is based on this. What is the mere posterior mean is the posterior mean alpha 3 plus summation xi yi by alpha lambda 3
Okay.
then delta 3 by summation yi xi. Why we have here xi is greater than 0, why consider now, sir? Because lambda 2 is equal to 0, and there is possibility is not there, sir. In the section y are equal to 0, it is for minus lambda, sir. So that's why we here we see the submodel 2, sir. That's why we consider that a solution xi is greater than 0. We make it clearly. This argument argued this in the last in the thesis time. Actually, we mentioned it clearly. Appropriately calculate the mention that from this concept.
Okay. Thank you.
Any questions from the session? Audience? No questions. Suppose. Well, now then I have few questions. Lena, availability for value division analysis of the section in the system. The answer to the question is why you have chosen this system?
Yes, sir, I know.
We have mentioned that we have taken two data sets. Right.
Yes, sir.
We have any other demonstrations on statistical results?
Yes, only data set is there, sir. The GDP that is pseudo exponential distribution, sir. That is pseudo exponential.
No. My question is, you can apply variables to passing. We have some conditions for apply passing.
Yes, sir.
The usual variable passing. Like what is only condition for very some possibilities.
Yes, sir.
When we choose the file, the pseudo gamma file. Because we choose the physics for choosing pseudo gamma file.
Then the reason is there, sir. We consider the linear form of the parameter, conditionally linear form, not sir. Parameter. We consider the linear form, not sir. Parameter. The conditional parameter. Lambda 2 plus lambda 3x. In analysis, in a classical analysis, sir.
The parents are of varieties. Of course, yes. So much you have, only you can choose the patterns. And everybody is sure that it's right from zero percent. And it can be what the kind of parents. And this is the parents. Of course, that another also has some parameters. They have higher parameters. How do you recommend when you first schools separate? This is the kind of solutions. This is called problem integration analysis. That's not just making an assumption about the parents, but also understanding the facts of the high-tech parameters. Right. Out of this thesis, how many papers is published?
3 papers, sir.
How many other in SCA journals?
3 journals, sir. 3 papers, sir.
Which is 3 papers published, and all the journals, SCA journals?
It's a, no, sir. 2 is a usage care journal, sir, and 3 is a essay journal, sir. Focus journal, sir.
So, when you read one of the SCA journal, the 2 others are
3 essay journal, 2 essay papers, sir.
published. But you mentioned how many papers in the cases?
This is 3 papers, sir. At that time, 3 papers I published, sir. 3 papers only, sir. After that, I published 2 papers.
Okay, how many
thesis I will not mention, sir. In that, yes, complete CV I submitted, sir.
Okay, thank you, Pragarana, for making presentation. And if there is anything else, so believe that Pragarana should go to the next candidate. Next candidate is Professor State, and he's with us. And you can close the screen and Professor you can go.
One minute. Text of it. You say, no. Sorry, you need,
okay. You know, yes, you are
also visible.
okay.
First of all, I would like to thank Professor Satish Kumar sir and professors for giving me an opportunity to present my work in this conference. Good evening, sir and madam. I am Dalsai Mose. I am going to present my PhD thesis, the title of the thesis is Control Charge Measurements in Cell Cycle. So So outline of our presentation is like this. First, I will give three highlights of the thesis. Thesis contains 5 chapters. I will briefly describe these 5 chapters, followed by some future directions. Then, after the submission of thesis, finally, paper thesis. The highlights of the thesis are as under. The work presented in this thesis falls in the area of statistical process control. Particularly, we have developed the sequential sampling based upon hello.
Hello, Mike.
Network correction. Network failure. Hello.
If you are able to screen is also visible.
Okay, thank you. Thank you very much. So, particularly, we have developed the sequential sampling based control charts in parametric and non-parametric setup. In parametric setup, we have considered the normal and maximum distribution. While in non-parametric setup, we have proposed a static control chart for process location based on sequential sampling test. The general conclusions are the financial performances of the proposed charts are substantially superior to that of the previous corresponding charts in the existing literature. In this, examples are provided to illustrate the mechanism of the charts. The work is published, 4 papers are published in 3 journals: in Quality and Reliability Engineering International, in Journal of Statistical Computation and Simulation, and published Nutrition in Statistics Simulation. And process control technique used worldwide for modeling, manufacturing, and other processes. The first level control chart is the shared control chart, which is highly efficient in detecting large shifts. Control charts are specially developed for detecting small shifts. When in detecting small as well as large shifts, the alternative to the shared control chart is the stability control chart. So, chart is appropriate for applications when observations can be taken one by one with the possibility of decision about the process of taking observation when it is expensive or expensive, and the system any size is expected to detect as efficiently as possible. For example, consider the manufacturing process of automobile airline. And in this process, and important quality characteristics is the deployment of an automobile airline. It is typically created with sensors. Suppose we can that can be tested at a time. Further, the airbags are expensive. It is a expensive. Also, the rejection of system any stress in the deployment pressure rate, how much time value is expected to detect as efficiently as possible. As another example, consider the manufacturing process of plastic as well as lenses. Here, the durability of lens is an important quality characteristic. In the testing perspective, also the detection of system very stress in the durability of lens is expected as efficiently as possible. So, these are the appropriate situations where one can use the static control chart. As the name indicates, the mechanism of the static control chart is based on the wall state strategy. So, therefore, first I will briefly describe the wall state strategy, and then I will describe the general mechanism of the static chart. Let's see the PDF of the variable X. And for testing, H1 theta is equal to theta 1 against H1 theta is equal to theta 1. Take observation from the X sequence 1 at a time and compute the value of X statistic, which is given in equation 1. And B is the less than A is the critical inequality of the test. B and A are the stopping point of the test. So, one is for B and A, which is given in equation 2. There are 2 performance metrics of the strategy. First of all, is the operating characteristic function, which is defined as the probability of accessing H0. And the second one is the average sample number, is the expected sample size required to terminate the strategy. One provided an approximate expression for OC data and ASIN data. However, the exact values are obtained in a multiplication approach. Coming to the description of the static chart, assumption our equations are as follows. Let x is a quality characteristic having to be of f theta x. Suppose the capital theta is to be monitored and its target value theta naught. And suppose an approach is transformed for generates 15 theta. These observations is taken independently within a given time. The mechanism of the chart is at least applications take observations on the exclusive one at a time and apply the standard H0 against H0. If the standard accepts H0, then the process is treated to be in control. Otherwise, declare it is out of control. So H1 is the design parameter of the chart. It is to be chosen such that the chart exhibits optimal statistical performance for detecting shift of particular styles. Figure 1 shows the static chart graphically. So again, there are two performance measures of the static chart. First one is the average number of samples to signal, which is given in equation 3. And second one is the average number of observations to signal, which is given in equation 2. Now there are two approaches for measuring the statistical performance. First one is the zero state performance and second one is the steady state performance. On the measurement chart, zero state and steady state performances are same. However, in case of the measurement chart, these two performance measures are different. So literally about the static chart is quite limited. The notion was introduced by Chambers and Reynolds. They proposed the static chart for general parameter. Also, Chambers and Reynolds proposed the static chart for mean of a normal process. The static chart for mean was proposed by Lee and other. Multiple others provided optimal design of the static chart. And economic general order studies the economic design of the static chart. The particular static chart for mean of normal process was proposed by OU and other. Also, OU and other proposed the static chart for simultaneous modeling of mean and variance. The literature review reveals quality research gap. So, first research is and static chart for modeling the dispersion of a process was not investigated. Research gap 2, the static charts were investigated for normal processes only and not for other processes. The next research gap, the literature suggests only one-sided static chart. The last one, no non-parametric chart based on sequential sampling was developed. Therefore, in the subsequent chapters, we address this research gap. So, chapter 2 addresses research gap 1 and static chart for monitoring dispersion of process was not investigated. Therefore, in this chapter, we have proposed a static control chart for dispersion of normal process, and the mechanism of this chart is based on the static for dispersion. So the static for dispersion is let randomizer X follows normal distribution with parameter V1 sigma square. The statistic for testing H1 against H1 is given in this situation, and G less than S less than H is the critical inequality of the test. So as mentioned earlier, we want to provide the approximate expression for OC delta and ASN delta. We have obtained the expression for OC delta and ASN delta using Markov-Chain approach. Here the details of the Markov-Chain approach are given here, but due to time constraint, I will skip this mathematical details. So equation 8 and 9 are the expressions for ASN delta and OC delta, which are obtained using Markov-Chain approach. Coming to the description of the chart, assumptions of the positions are as follows. Let x is the quality characteristic for distribution is normal. We have to multiply sigma at its target value sigma naught, and assume that the performance of an astronomical class is sigma naught, sigma naught to some other value say delta sigma naught. The mechanism of the chart at least calculates the observations of the target sequence in one data and applying the equality of H1 against H1. If the H1, then the process is treated to be in control, otherwise it is treated to be out of control. So as mentioned earlier, the performance of the extended chart depends on the choice of the business delta. Suppose delta dash is the shift of size that is implemented as efficiently as possible. Then it is observed that the optimal choice of design is delta 1 is equal to delta dash. This is evident from this following table, which shows the ANSS and ANOS values of the proposed chart for three different choices of the design delta 1. So P corresponding to delta is equal to 1.25. The ANSS and ANOS values are millimeter with respect to 1.5. Also, system corresponding to the 1.75, the ANS is minimum at with respect to 1.75. So, the optimal chance of design is that which is desired to detect as efficiently as possible. Based on this observation, we have provided an approach to design the STAT chart. So, that is delta 1, which is desired to detect as efficiently as possible. Compute gamma using this equation and specify the incorporate AS from this and alpha minus 1 upon the 1 and find beta, then equation is satisfied. In case of an upper one-sided scatter, compute the initial values of G and H by using equation 1, and in case of the one-sided, compute the initial values of G and H by using equation 2. And adjust the values of G and H so that we will control ASS and ASM are achieved. So, in order to evaluate the performance of the proposed chart, we have compared the performance with the following methods. So, this slide shows the heuristic performance of the upper one being skeleton, institutional, clear, synthetic air, synthetic heat, and our proposed SLT charts. So, all these values are expressed in terms of the percentage of the skeleton charts. So, the first typical is the heuristic AS values of the orbit charts, and the second typical is the heuristic AS values of the orbit. So, blue color is the curve of AS values of the our proposed charts, and here we can observe that for detecting shift of any size, the heuristic AS values of the SLT curve are substantially smaller than that of the orbit charts. Also, the heuristic AS values of the proposed chart are smaller than that of the skeletal, institutional, and the chart for detecting shift of any size. And also, the heuristic values of the proposed chart are smaller than that of the synthetic and synthetic chart. For detecting small shifts, however, they are slightly larger than that of detecting large shifts. So, also we have compared the performance with the steady-state performances of all these charts and same thing is observed in this case also. This slide shows the heuristic performance of the lower one-sided chart and the same thing is observed in this case also. Here also we also have compared the steady-state performance with the all other charts. So, in this chapter, the conclusions are STAT charts for monitoring upward and downward shifts in the process discussion are proposed. Yet, the statistical performance measures of the charts are often using markup approach. Performance is compared to all existing charts for discussion and found that the proposed charts are substantially quicker than the competitive charts and approach to design the chart in practice is provided. In the cases, mechanism of the chart is illustrated using preliminary exam. This was the highlight published during the international. So, chapter 3 analysis research that is the basis of this one-sided STAT charts. And extension of one-sided in the non-trading class. So, operated by this, we propose two-sided STAT control chart following the normal process. And the mechanism of this chart is based on the STAT control So, the developing that we found the two students, and based on this, we have proposed the So, I will speak some mathematical detail. Cj plus and Cj minus are the statistics of the extended STAT for the mean. And the procedure of the test is as at least observations, take observations of and compute the value of test statistics, Cj plus and Cj minus. If this value is also between this G and H, take another sequential observation and compute the value of test statistics. If any one value of one of the control statistics is equal to G, then from the procedure corresponding to the statistic and calculate the procedure corresponding to other test statistics. If the value of both the test statistics falls below G, then accept H naught, or if the value of any one of the statistics falls below H, then resist H naught. So, again in this case also we have obtained expressions for procedure time using our approach and the details are provided in the thesis. So, coming to the description, the other cells are which is on the same as control cells for the dispersion. The mechanism of this charge is based on the strategy for me. So also they have compared the performance of the control chart with the other existing charts which are designed for the monitoring mean of a normal process. So this slide shows the steady-state performance comparison. So we have compared the performance with the steady-state chart. Blue color, other blue color is the steady-state system of the our control chart. And blue color here, green sticker, blue color is the steady-state yellow is of the here we can observe that the performance of the proposed chart is substantially superior to that of the student question and PWA chart. Also, we have compared the performance, the geological performance of the synthetic question, synthetic PWA chart, and here also the performance is superior than that of the other chart. The geological areas values are similar. However, we have slightly larger for detecting small shift. Also, we have compared the performance with the steady-state performances of these charts. And here also we can observe that the performance of the proposed chart is substantially superior than that of the all other charts, indicating shift of any size. So, conclusion: a two-sided chart for the mean of normal distributed process is proposed. A data statistical proposed measures of this chart are often using the Markov-Chain approach. The proposed chart performs the competent two-sided charts would be in the existing literature. In the literature, related example is provided to demonstrate the mechanism of the chart. This work has been published in Journal of Statistical Computation and Simulation. So, the chapter 4 analysis research gap 2, the extent has been investigated for normal processes only and not for the other processes. However, in practice, there exist several situations where the non-control model describes process more appropriately. One such model is the maximum distribution. The period of this distribution we have taken of here. Also, this distribution in physical and chemical sciences. It is the basis of kinetic energy of process, which is the applications in data and math process. This distribution has every single parameter which is the state parameter. These are the expected of usually this the mechanism of this only is based on the maximum distribution. So we just agree on what it's not only H1, it's not H1 respectively. And the mechanism is based on these two case statistics. So, as we have seen that the optimal chance of the result is that which is indicated as efficient as possible in case of the established chance for the normal distribution. However, this does not hold in case of the established chance for the suppose delta dash is the unsuspicious that is indicated as efficient as possible. Then the optimal chance of the delta 1 plus delta dash divided by 2. This is this table. Table of this column data is equal to 1.2. The delta is equal to 1.1. Also, similarly, see the delta corresponding to 1 delta is equal to 1.6. The lowest values are minimum at
അഞ്ഞൂറ് മുമ്പ് നമ്മൾ അവിടെ എത്തണം അല്ലേ? അവിടെ ഒരാള് ബഹളം ഉണ്ടാകും.
How much of the posted a stat chart is the statistic in this is not more than that.
ഓഫ്ലൈൻ മാത്രമല്ല ഓഫ്ലൈൻ കഴിയാൻ സമാധാനം ഓൺലൈനിൽ ആ ആ ആ എന്റെ ബാഗ് ഇത് എന്താ
അവിടെ ഒരു ചേട്ടനെ നമ്മുടെ സീനിയർ ചേട്ടൻ എണീറ്റ് നിൽക്കുന്നു.
റെസ്പെക്ട് ആണ്
കേരളത്തിൽ ഒരു ബ്ലൗസ് ഇട്ടു. ഞങ്ങളുടെ സീനിയർ
ഒരാളുടെ ടീം ഇതിന് സൗണ്ട് ഇത് സൗണ്ട് ഇല്ലെന്ന് തോന്നുന്നു. ഇതിട്ടില്ല എന്തിനാ അവര് ആവശ്യമുണ്ടോ ഇവിടെ വെച്ചിട്ടുണ്ടോ ഇല്ലല്ലോ റോസ്മി ചേച്ചി ആ ഓ ഞാന് ഞാൻ അവിടെ ജസ്റ്റ് ഒന്ന് ചേട്ടാ ഒരു തീസിസ് കൂടെ ഇതുവഴി ഇങ്ങനെ പറഞ്ഞു. എത്രയായി സമയം? അതാ 4:30 ഇല്ല നമ്മൾ അതിന് വേണ്ടി വരണ്ടേ പിന്നെ ഇതുണ്ടല്ലേ ഫോൺ ആവശ്യമുണ്ടോ ചേട്ടാ കുടിക്കുന്ന അല്ല പോയിട്ട് വരും ആ തീസ് കൊടുത്ത് വേണം പിന്നെ കുറച്ച് കഴിഞ്ഞിട്ടില്ല മതി. കമ്പ്യൂട്ടറിനകത്ത് നാലാണ് ചെയ്യുന്നത്. ഇപ്പൊ ആരുടെ ലാപ്ടോപ്പിലാ? ആ പറയൂ. ആ നാളത്തെ മുഴുവൻ ഫിക്സ് ചെയ്തില്ലയോ സെഷൻ ചെയ്ത്? സമയങ്ങളെ പെട്ടെന്ന് ചെയ്തോളാം. അത് ഞാൻ പറഞ്ഞോ. എന്നെ ഒന്ന് ഇടയ്ക്ക് വിളിക്കുക റിമൈൻഡ് ചെയ്തോളാം. കാരണം ഇനിയിപ്പോ നമ്മൾ 10 മണി വരെ കണ്ടിന്യൂസ് ആയിട്ട് ഇതിനകത്ത് ഇങ്ങനെ ടൈറ്റ് ആയിട്ട് പോകുമ്പോൾ ചിലപ്പോൾ നമുക്ക് മറന്നു പോകാം. എന്നെ വിളിച്ചാൽ മതി ഇടയ്ക്ക്. വാട്സാപ്പിൽ വിളിച്ചാൽ മതി. ചിലപ്പോൾ ഞാൻ അതിൽ കയറിയ അല്ലെങ്കിൽ അങ്ങനെ വിളിച്ചു കേട്ടോ. അല്ലാതെ വിളിച്ചു നോക്കി കിട്ടിയില്ലെങ്കിൽ പെട്ടെന്ന് അങ്ങ് കട്ട് ചെയ്താൽ മതി എന്നിട്ട്. ശരി അപ്പൊ നമുക്ക് ഒരെണ്ണം മാത്രം ഉള്ളപ്പോൾ അതിനകത്ത് ഒരു 70 പേരെങ്കിലും മിനിമം ഇല്ലെങ്കിൽ നമ്മുടെ കുട്ടികൾ ആരൊക്കെ അങ്ങനെ കോൺടാക്ട് ബേസ് ചെയ്തോളാം. പിന്നെ 2 എണ്ണം ഉണ്ടപ്പോൾ ഒരു 40 പേര് വെച്ചെങ്കിലും ഉണ്ടോ എന്ന് നോക്കാം. 2 3 അതിൽ കൂടുതൽ സെഷൻ 40. 2 എണ്ണം ഉള്ളപ്പോൾ 60 നോക്കും. 3 എണ്ണം ഉള്ളപ്പോൾ 50 നോക്കും. 4 എണ്ണം ഉള്ളപ്പോൾ 40 വന്ന ആളായിരുന്നു. ഒരുത്തനെ അച്ഛനെ അകത്തോട്ട് കയറിപ്പോയോ? ബാഗൊക്കെ കൊണ്ടുപോകാൻ മോള് പോയായിരുന്നു. അല്ല ഉച്ചക്ക് ഇപ്പം വൈകിട്ട് ഓക്കെ. ഈ ടാക്കൂർ എല്ലാം മറ്റേ IIT പയ്യനല്ലേ? മറ്റേ കോമഡി അവനും കയറി ചോദ്യം ചോദിക്കുന്നത്. അപ്പോൾ നമുക്ക് അടുത്ത വർഷം പോലെ നേരത്തെയുള്ള ആൾക്കാർ അടുത്ത വർഷം പോലെ നമുക്ക് അങ്ങനെ ക്രൈറ്റീരിയ ഒന്ന് ഓർത്തോണം. ഒരു ക്രൈറ്റീരിയ ഫോം ചെയ്ത് അത് ചെയർമാനെ ഏൽപ്പിക്കാം. പക്ഷെ ഇവര് മൂന്നും നല്ല ടീമാണ്. കാരണം മറ്റവൻ വീരണ്ണ മറ്റേത് കിട്ടിയ ഇതിൽ നിൽക്കുന്നു. പക്ഷേ കഴിഞ്ഞ പ്രാവശ്യത്തെ ISBSന്റെ അകത്ത് ഇത് ചെയ്തതായി ടീസിന്റെ അന്ന് അവിടെ വെച്ച് നമ്മളവിടെ വെച്ച് കാണുകയും സംസാരിക്കുകയും ചെയ്തതാണ്. അല്ല ഇയാള് ഷോലാപൂരാണ്. സ്റ്റൊക്കാസ്റ്റിക് പ്രോസസ് മറ്റേ പൂനെക്കാരൻ അവനാ കിട്ടിയത്. പക്ഷെ നല്ല ഇതാണ്. പിന്നെ ഇവൻ IIT USA തിരുപ്പതി പുള്ളിയെ വല്ലതും എടുക്കാൻ വേണ്ടി ശ്രമിച്ചു. ചിലപ്പോ അങ്ങനെ ആയിരിക്കും. ഞാൻ ചെവി വെച്ചത് നിങ്ങൾക്ക് കേൾക്കാൻ പറ്റത്തില്ല അല്ലേ? മാറ്റണോ? ഉണ്ടല്ലോ. ഇപ്രാവശ്യം ഇവരുടെ ബയോഡാറ്റ കൊടുത്തില്ല. പകരം അവരുടെ തീസിസുകളും പ്രസന്റേഷൻ സ്ലൈഡ്സും ആയിക്കോളും. പക്ഷെ ഫീസ് ആണെന്ന് നമുക്ക് മനസ്സിലാവും ICSTC നടത്തുന്നതെന്നുള്ളത്. അയാളുടെ പ്രസന്റേഷൻ തുടങ്ങി ഇത് ചെയ്യത്തില്ല. ഓക്കെ. കുഴപ്പമില്ല. നമുക്ക് എല്ലാം ഓപ്പൺ ഇതിലായാലുമേ അവരുടെ ക്വാളിറ്റി ഒരു അസസ് ചെയ്യട്ടെ. ജൂറി മെമ്പേഴ്സും പിന്നെ ചില്ലറക്കാരല്ലെന്ന് മനസ്സിലായെങ്കിൽ അവർക്കൊരു വാല്യുവേഷനകത്തൊരു പവർ. അച്ചായി ഏർപ്പെടുത്തിയേക്കുന്ന അവാർഡായിരുന്നു. വ്യാസം ചിലതൊക്കെ പറയുന്നത് കൂട്ടിയും തിരിച്ചും കഥ മാറ്റിയൊക്കെ പറയുന്ന പോലെ ചുമ്മാ ഇതിനെ കുറിച്ചൊക്കെ പറയണം. ഇല്ല ബാറ്ററി ലോന്ന് കാണിക്കുന്നുണ്ട് കേട്ടോ. ഇതൊക്കെ കുത്തണം. ബാറ്ററി ഇത് പോയ പ്രശ്നമുണ്ടോ? അയ്യോ എന്ത് ചെയ്യും? ഇത്ര നേരം നിൽക്കുമോ? ഇതിന്റെ ഇത് മിനിമൈസ് ചെയ്തിട്ടാ കിട്ടുമോ? ഇതൊക്കെ അതിനകത്ത് വരുമോ? എടുക്കണോ? റിയാസ് ഞാൻ ഇതിലൂടെ കൂടെ കണ്ടോണ്ടിരിക്കുക. കുറച്ച് കഴിഞ്ഞ് എന്നെ വിളിച്ചാലും മതി. ആരുടെ? തരും തരും. അതെല്ലാം തരും. ഇപ്പം ബാറ്ററി ലോ ആയോണ്ടേ ഇപ്പം ചെയ്തിട്ട് തരും. ഒന്നും എടുക്കാതെ ഇവനെ ലാസ്റ്റ് വട എടുത്തതിന്റെ സാറ്റിസ്ഫാക്ഷൻ. കടല പായസത്തിലെ പാത്രം എടുത്ത് വെച്ച് അതൊക്കെ എടുത്ത് നമ്മുടെ വെജിറ്റബിൾ കറി ഇല്ല. നമ്മുടെ വെജിറ്റബിൾ പറ്റിച്ചു. പനീർ തരാന്ന് പറഞ്ഞിട്ട് അവര് കടലക്കറി വെച്ചിരുന്നു. ആണോ? ശരി. അതെ, കൂടുതൽ വെജിറ്റേറിയൻ ആൾക്കാരുണ്ടായിരുന്നു. കാരണം അശോകന്, ജയകുമാറ് അവരൊക്കെ വെജിറ്റേറിയനാ. എന്താ കടലക്കറി കൂടെ സാലഡ് തമ്മിൽ കുഴപ്പമില്ല. സാലഡ് പിന്നെ വലിയതായിട്ടുള്ള ആൾക്കാർ ഈ പിള്ളേരെ വെച്ച് ഇങ്ങനെ അവര് പിള്ളേര് അങ്ങനെ നമുക്ക് നമ്മുടെ വലിയ ഫംഗ്ഷൻ നടത്താൻ പറ്റില്ല. ഇവര് മാറി നിൽക്കണം. മറ്റവരെല്ലാം കയറി കഴിഞ്ഞിട്ടേ ഇവര് കയറാവും. മനസ്സിലായോ? ഇതിപ്പോ അവര് അങ്ങനെ കഴിക്കാൻ മറ്റവര് അവരെ മാറ്റി കഴിക്കാന്ന് വിചാരിച്ചാൽ ഇവർക്ക് ആ ഒരു കൾച്ചർ ഇല്ല. അത് ഇനി ഇവർക്ക് പറഞ്ഞു കൊടുത്താലേ മനസ്സിലാവും. കാരണം മറ്റേ നമ്മുടെ ഗസ്റ്റാണ്. ആ ഗസ്റ്റുകളെ നമ്മൾ അതിനാ ഞാൻ അവരെ വിളിച്ചോണ്ട് വന്ന് ഇത് ചെയ്ത് ഇവരായിട്ട് പോലും ഈവൻ മറ്റ് എന്നിട്ട് നമ്മുടെ പിള്ളേർ എന്ത് ചെയ്യണം? ഇവർക്കെല്ലാം കൊണ്ടു കൊടുത്ത് അവരെ ഇത് ചെയ്ത ശേഷം വേണം നമ്മൾ ഇത് ചെയ്യുന്നത്. ഇത് അവര് കയറി ക്യൂ നിൽക്കുക ഇടിച്ചു കയറി അങ്ങ് കഴിക്കുക എന്നുള്ള ഭാഗത്ത് അതല്ല വേണ്ടത്. റിയാസിനും അത് അറിയാമോന്ന് എനിക്ക് സംശയമുണ്ട്. ശരി.
ഏതാണ്ട് കഴിക്കാതെ നിൽക്കുകയാണ് കാരണം അവിടുന്ന്
ആണല്ലേ
കറിയില്ലാത്തതുകൊണ്ട് ഗൗതമി
ആ ശരി
അവിടെ നിന്ന് ഞങ്ങൾ ഓടി പോയി മേടിച്ചോണ്ട് വന്നു.
ആ ശരി ഇങ്ങോട്ടാണോ ആ ഇല്ല ആ
the reality. And PM10 and AQI also I have shown. And I have shown the for each economic zone what
Dr.
is the
Dr.
effect
Thakur,
of. Yeah,
please try to conclude.
yeah, please. I am
The time
concluding.
is
Okay.
over.
Okay, okay, I'm concluding. Okay. So this is the way. And then this is the probabilistic forecasting result. And this is the dependence between the wind direction and PM 2.5. And this is the ANOVA table for all the components. And the results betterment is special copula is far better than special vision fine copula by the literature, Sujit Ghosh, and ordinary kriging by Noel Crazy. And then the conclusions that in northwest part of Delhi and the transport zones are most affected area due to air pollution. Spatial cluster-based, spatial vine copula-based interpolation performs better than traditional geostatistical interpolation, for example, ordinary kriging, simple kriging. And if the wind direction lies within 180 degree to 200 degree, then PM 2.5 is in interval 90 to 100 micron per meter cube under some uncertainty configuration. That's the entire thing. This is the reference, and this is my published papers from the. Thank you.
Thank you.
Sorry for this
Thank you.
inconvenience.
Thank you, Thakur. Thank you, Dr. Thakur. Now the session is open for interaction. Of course, we have only 5 minutes to conclude this session. By 5:30, they have another program. Let me invite the members of the jury board to ask to interact with the candidate. Dr. Bond.
Congratulations, Dr. Thakur. You have stated your problem very well and also justified why you have chosen this topic very nicely. And the work carried out also is
Okay,
very
thank
good.
you.
I just wanted to ask you only one question because we are running out of time. Have you carried out simulation studies also for every result that you
Yes,
have obtained?
yes, 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 yes.
And used real life data sets also? It must be in the
Yes,
thesis
actually,
document.
my thesis is data driven.
Data
So
driven. Okay,
the
so you're
concept
please go on.
I have simulated. I have validated my result by the simulation study, but the main idea is actually motivated from the Delhi air pollution data.
Thank you.
Thank
Professor
you.
Farid.
Yeah, Dr. Thakur, congratulations for your nice presentation. One quick question is actually, you are using C-wine copula, right? The reason why you are using C-wine copula for, other than the other copula? Any other specific reason for that?
Yes. Except vine copula would not have any conditional dependence or pairwise likelihood definition approach available. So we have to choose the vine copula. In vine copula, we have three, the major well-known, the C vine, D vine, and R vine. And C vine is working better, so that's why I'm choosing C vine.
No answer from your side.
Thank you. Thank you. Of course, we have one more minute. Is there any other questions from the audience? Congratulations, Dr. Thakur, for making nice presentation. As my fellow juries mentioned, right? Can you tell me the relevance for this results?
Diligence for the
Relevance for the results which you obtained from this research work. Of course, you made a very good analysis. You constructed the models, right? And
yes, actually,
all
sorry.
are based on the data related to the lockdown period.
Yes. Yes, the resource actually I have contacted to the Delhi government in 2022, and on that time we have actually given this article and shared, but they did not do not respond. Then after that, IIT Tirupati has actually taken the so much enthusiasm to build an app so that it can be applied on the bus transportation system. Okay, so that's why.
Um, yes, it seems that there is a quick question
A quick question, Dr. Thakur. Data is coming from. It's
This is the website, Central Pollution Control Board, or you can download the data from IAMD. But I personally suggest that if you can download it from NOAA or NASA website, you can get more dynamicity in the data set.
There is an authentic resource for obtaining data regarding this index, the air quality
Yes,
index.
that's the problem actually. The satellite resolution level is so much smaller in of the radar, so that's why the CPCB is struggling to predict the accurate.
Have you taken care of that the quantity, that is air quality index, which depends mostly on the quantities which you have considered for the study? Have you taken into account of the air quality indices values?
I'm not getting. Can you repeat, please? I'm sorry.
Air quality index, AQI.
Oh, air quality. Yes, actually, I have considered. I have demonstrated that one table in air quality index. That how in air quality index the transport zone, in transport zone, in economic, in which economic zone, what about the air quality index? I have demonstrated, and in the research paper, it is clearly explained.
Okay.
And actually, the problem is that in 2022, we have suggested to the Delhi government to propose at least week-wise some lockdown, because on that time we have understood that the situation will come. So
Thank you. Thank you for your response. On behalf of the members of the jury board, we thank all the three candidates for making a nice presentation and for
Thank you,
responses. And on behalf of the members of the jury board, I thank Dr. Satish Kumar and his team for giving us this nice opportunity. Now we hand over the session to the organizers. Professor Satish Kumar.
Professor, thank you,
thank
Professor.
you all.
Thank you so much, sir.
Well,
Thank you, Professor.
Thank you, Professor Loganathan, sir. And thanks to all the members as well as the competitors of this award. We are very much thankful to each one of you. Making the very active and vibrant session, very interesting, and everyone is waiting for your resolution.
Due to time constraint only, we have to conclude.
Yeah, yeah.
Three topics are very nice.
Yeah, please. Now we have to move to the next.
Tagore,
yes,
Thank you, sir.
this is Viru Banot.
Sure, Doctor.
I have one small question for you, a suggestion.
Sir, the thing is, we have handed over the session to the organizers.
Okay, let's start.
Just share your mail, otherwise number share. I will contact you. Just share.
Sure.
Share me. In chat
Okay,
box.
I will share in the personal chat. Okay. Okay. Sorry for this inconvenience.
Mail ID. Thanks.
Welcome, Professor Bala. Now the right time we have to move to the next session. In fact, the other earlier session they have lot of further questions. They can join by other media, the email or phone. Okay, Srilakshmi.
Okay, sir.
Okay, please initiate the session. Invite the chair and do the needful for the conduct of the session. Welcome.
Okay, sir. We are moving on to the 10th technical session of ICSTC 2024, which is a keynote session that shall be chaired by Professor K. Kalyanaraman. Krishnamurthy Kalyanaraman is a retired professor of statistics with decades of experience in teaching and research. He served at the University of Kerala, Thiruvananthapuram, and later conducted short-term courses in statistics in Chennai. He is an elected fellow of the Kerala Academy of Sciences. Professor Kalyanaraman is also passionate about Carnatic music and training activities. His commitment to innovation and knowledge sharing makes him an ideal leader for today's session. Please join me in welcoming Professor Kalyanaraman as our session chair. We look forward to his invaluable insights and guidance.
Welcome, Professor Kalyanaraman, sir.
It's always a pleasure to be in association with programs organized by the Department of Statistics, where I worked for the entire lifetime. I retired from service 23 years back. Still, I am continuing with this kind of, say, what do you call, events organized by the department because I have a feeling that I still continue to be in academics. And along with that, to chair a session where Professor Balakrishnan will be delivering a lecture is something that I do not know. I deserve it only by age. The kind of experience that one derives by hearing his lecture is something that you cannot explain in words. It's just like M.S. Subbulakshmi singing Carnatic music. Apart from music, whatever that I enjoy, similarly I enjoy here also, even though I don't do any serious research work, but I'm able to understand, I'm able to appreciate, I'm able to enjoy the presentations to a large extent. So I never miss uh, sessions by Professor Balakrishnan whenever he delivers a lecture here in the department or anywhere else for the matter. And I would like to say more about him because if I start telling the entire time allotted for his lecture will be going further. So I request all members to look into Google, what do you call, lecture scholar and see for themselves the kind of work that he has done and the kind of citations that he has received. The first item in the list received 31,000 and our applications. That is not an ordinary kind of thing. It's not a paper just thing. It's more than a paper. The citation is more important and even for one or two citations we try to say that it is very happy about it. No, it is not a problem for him at all and he takes it very lightly and he always has a very kind heart with the department and I request him to continue to have this association with the department for the next years, coming years also. So now I hand over the mic to Professor Balakrishnan. He is available. He is available.
Yes, I'm here.
So Professor Balakrishnan is there. So I just invite him and hand over the mic to Balakrishnan sir for delivering his lecture. Over to Dr.
Thank you very much, Dr. Kalyan Raman. Appreciate it. I always appreciate seeing you and being active. And congratulations. Continue to do the same. Um, Dr. Satish Kumar, thank you very much for inviting me to give this talk. You are doing a great service, yeoman service to the department and also the country by organizing such events, which are valuable for young researchers and also upcoming researchers to listen to people, to see some different topics, and get into research work, which is a very important feature. So, thank you very much. Once again, I'm sorry I cannot be there in person due to health reasons, but I am glad I could take part online. Hopefully, in the summer when the conference is organized, I'll be able to come in person or next year. Can we magnify the screen a little bit so that it's clear? That's better. Um, okay. I'm going to talk about degradation data. A lot of people work on reliability and they always talk about success and failure of components, of systems, etc. But there are many devices where the unit does not have to fail, but it becomes unstable or cannot be used effectively beyond a certain threshold.
Uh, for example, you may be looking at a luminosity in lights. If you go to a room, the light may be bright and you can see all the objects, but the luminosity over time decreases. It doesn't have to completely fail. But for practical purposes, once the luminosity goes below a certain level, then the unit has failed. You can look at a photocopier. The quality of the print that you get will diminish over time, but it doesn't have to become completely empty. When the threshold level is crossed, you say that the print is not of good quality, you consider the photocopier to have failed. And there are many, many such devices. For example, startup engines, if the power goes below a certain level, then you consider the unit to have failed. So, the modeling of reliability of such devices is not like the modeling of reliability of usual devices. You wait until they fail. These are what are called as degradation models. And there is a huge literature on degradation modeling. There are books. There is a very nice chapter on degradation data modeling in the book by Meeker and Escobar. And there are several articles that have been published on degradation modeling. And one of the degradation model application is in the fracture mechanics. If a fracture time, the fracture becomes larger and larger, but the unit is still continuing to operate. It may not have failed, but simply because the fracture becomes too large, the unit cannot be used safely. So the manufacturer will try to withdraw it. And there are instances where, for example, in the airplane fans, propellers, a crack occurs, and when the crack is minute, they may not care. But when the crack becomes bigger, at some point they will say that the unit is not safe to operate, it has degraded too much. Now, most of the work until last year was always on one crack, never on two cracks or three cracks. The modeling is done on a single crack. So, if you have degradation characteristics more than one, how do you tackle degradation modeling? That is a question I asked. Oh, this work just got published. If you do a Google search with this title, you will find the paper in Reliability Engineering and System Safety. A rather long paper of 25 pages, but I'm going to summarize the findings. Basically, this is one of the earliest work on a bivariate degradation model. When you have two characteristics that are used for assessing the degradation of the product, they will be invariably correlated. For example, if there are two cracks on the fan, as you use the fan more and more, propulsion is used more and more, both cracks will continue to get bigger, probably at different rates. So there will be correlation. How to model the bivariate degradation in practice? And I use a shared frailty model as one way, flexible way of modeling bivariate degradation. This work is in collaboration with two of my former students. Both are my PhD students. Sandeep Barui is an assistant professor at Indian Statistical Institute, Kolkata. Debanjan Mitra is a full professor at Indian Institute of Management in Udaipur. Next page, please. I'm going to start with an introduction to the problem, and I will explain why there is a necessity to consider a bivariate degradation model and inference. And I am going to explain how I construct a flexible bivariate degradation model. That's a modeling aspect. That's a new construction of bivariate degradation model. Then we have to come up with a model fitting method. So I will describe the method of estimation, something like a profile maximum likelihood estimation, or I can use Markov chain Monte Carlo method for the maximum likelihood estimation. We have to validate the method of estimation or the fitting method. I'm going to use an empirical study to demonstrate how the results are coming out with the use of this method. Finally, I will use a data analysis to illustrate the practical utility of the model and the inference and conclude with some comments on future work. Next page, please. First, let us look at bivariate degradation data. What is the reason we need to consider? Advancement of model degradation data over the last 2 decades, there are more than a couple of hundred papers on degradation data and applications to lithium ion batteries and motors, fans, etc. Measurement of performance characteristics is necessary for the degradation data analysis, like I mentioned. For example, length of a crack is a measurement of performance characteristic. If the length is bigger, then the unit is more likely to fail due to degradation. If the length is small, the unit is still maybe safe to operate. So, the performance characteristics are used in order to assess whether the unit has degraded too much or not. Luminosity in lights, for example, is another. You measure the luminosity. If the luminosity has decreased, then the light that you are looking at is going to degrade fast and it's going to fail soon. Often, units have more than one performance characteristics that degrade over time. So, you may consider to start to begin with, focus on products with two performance characteristics. In this case, we have to come up with a bivariate degradation model. And obviously, the two performance characteristics will be correlated because they are performing the degradation characteristic on the same unit. Inevitably, they will be correlated. And I give you some example here. Example is the first example was brought by one of my Chinese visitors, a former Chinese student, a PhD student of mine, Zhengchen Pan. He came from China and he brought me a rubidium discharge lamp data, which came from his university in the lab. And what it had was two performance characteristics. One of them is rubidium consumption of the lamp. How much of the rubidium is being consumed? The more it gets consumed, it's going to degrade faster. The less it consumes, it's going to take a longer time to degrade. The other one is decreasing intensity. I mentioned earlier luminosity. In this lamp, they measure the intensity of the lamp. If the intensity is high, the product is still performing well. But if the intensity becomes slowly reduced, then the unit has degraded too much. In this case, for the lamps, you are measuring at different time points these two performance characteristics. You may inspect every day, every week, etc. You have the measurement on rubidium consumption of the lamp as well as the decreasing intensity. Now, how do you assess the reliability of this product? How do you guess that the product is going to cross the certain threshold level? Next page, please. So the two PCs, the performance characteristics, are likely to be dependent. Why will they be dependent? Because there are inherent mechanisms. When you use the rubidium lamp, the usage is automatically going to have impact on the performance characteristics, no matter how many you have. So the model should always incorporate the dependence. You cannot treat the two performance characteristics on their own to be independent because you are observing them on the same unit. So they are inherently correlated. Correlation may be weak in some case, correlation may be strong in some case. It depends on the unit. A key consideration in this case is quality of model fit. When I fit a model, not only I just use it for inference, I should also be able to say what is the quality of the fit of the model that I have proposed. So coming up with a new model may be easy, but coming up with a good new model is difficult. So you need to construct a very general method where you can capture all sorts of behavior of the bivariate degradation data. Next page, please. So I am detailing here some kind of review, a brief review, but the review will tell you there is a paucity of work in this direction because even when I mentioned the first work attempt was made only about 15 years ago, 2009, and that was by Barker and Newby. They used a multivariate Wiener process. You all know a Wiener process is nothing based on normal distribution. So they used a multivariate Wiener process to model bivariate degradation data. And that was the only paper that was on bivariate degradation. And my student Xinchen Pan, when he came, he noticed that the bivariate degradation was not fitting the data that he had. So he came up with this thesis question, how do I construct a better model? And I said that the multivariate Wiener process is not a good fit for the data because the Wiener process, as you all know, goes up and down. It's an oscillating movement. But in a crack data or luminosity data, it doesn't go up and down. When the luminosity is observed over time, it's monotone decreasing. Or when you look at the crack length on the product, it's monotone increasing. They don't go up and down. This week you have a crack length. Next week the crack length cannot become smaller. It doesn't oscillate. So if you use the Wiener process on degradation, which are monotone, it will not provide a good fit. So that was our starting point, and Xinchen Pan's thesis was on gamma process. So we used gamma process for the performance characteristics, and we specifically introduced what is called as a bivariate Birnbaum-Saunders distribution to approximate the reliability, joint reliability of two performance characteristics based on two performance characteristics of the product. After that, there were a few more. Can you lower it a little bit, please? There is a paper by Sari et al. Where they used a copula-based method for bivariate constant stress degradation model, and then we also compared the bivariate gamma process with a bivariate Wiener process under various circumstances and how to use the copulas in a paper with my former PhD student Pan. There are only a few more copula-based approaches. I have given here three more papers. So in total, the number of articles that have appeared on this in the last 15 years is less than a dozen. So this tells you that this is a very complex area and not very much research has been done. So it's an open area for further research. Next page, please. Yeah. So use of frailty models. Marginally, you want to model the degradation processes. So some of the information you want to say, if I have two performance characteristics, is the chemical consumption on the lamp is much more serious than degradation of luminosity. So you should be able to comment on it. Not only you want to model jointly, from the joint model, you also want to make inference on that marginal degradation process. And at the same time, you want to capture the dependence. And that is where we use the shared frailty model. Advantages of this approach: the frailty model can capture unobserved factors. You may observe the specific factors, but there may be some unobservable factors that may be affecting jointly the performance characteristics. And the frailty model would try to capture it. Capable of capturing unit to unit variability. If I test one lamp and I go to another lamp, there may be some inherent variability between the kinds of lamps, and the frailty model can also capture unit to unit variability because it has a random effect component in it. And Zhu et al. Used Wiener process as marginal models, bivariate normal distribution for the shared frailty, but that may not be appropriate because the process that results in is not monotone. The performance characteristics cannot be monotone when you use a normal distribution. Song and Chui used gamma process as marginal models, gamma distribution for the shared frailty, and that is what we build on. Because the gamma frailty is a particular case. We want to make a more flexible model based on the data. We will be able to choose what is the best model within this parsimonious family. So the construction of the model has to have a parsimonious structure, which is flexible enough that you can find what is the best model for a given data, rather than forcing a particular model on the data without knowing whether that is the best model. Next page, please. So, choosing a suitable frailty distribution is important. Asymmetric effect of the observed factor, adequately capturing the dependence of the two characteristics should be kept in mind, and you have to choose a proper frailty distribution. And then you have to discuss also specific frailty factors in terms of fit. What kind of overall fit you get in the data. And a paper of mine in 2006 in Statistics in Medicine, I noticed that the frailty, people who work on frailty model, all choose either gamma or log normal or Weibull, and different groups work on different frailty models, but the frailty is chosen based on convenience rather than the data demanding what frailty you should use. So in a biomedical setup, myself and Yingwei Peng in Statistics in Medicine, we published a paper in a very general frailty model called as generalized gamma frailty model. And the generalized gamma frailty model is a parsimonious model which includes a exponential, gamma, Weibull, log normal, all of them as special cases. So rather than forcing a log normal frailty model on a given data, whether it is suitable or not, what we can do is fit the generalized gamma frailty model, allow the data to dictate which one of the special cases is more appropriate, if you like, or just use the generalized gamma frailty model itself to make inference, capable of providing adequate fit for different types of data, right skewed, left skewed, heavy tailed, light tailed, etc., because of the flexibility of this model. Next page, please. Here is the generalized gamma distribution that many of you may not have seen. The density function looks complicated, but do not look at the whole form. Only look at what is the function of T. You see the density function FGG, the T is the argument, which is a time scale. It has three parameters. Two of them are shape parameter, one is a scale parameter. And the scale parameter is alpha. It has two shape parameters, Q and sigma. Q is the model which separates different special cases. And sigma is another shape parameter capturing the kurtosis in the data. Now I want you to look at only the density, the function of T. The normalizing constants are not important. They are just normalizing constants. Look here. I it tells you that the log normal, particular member of this family. What happened to the page?
Network issue.
Satish.
Professor, this is a network issue. Just this retaining. Yeah.
Okay. Yeah. Thank you. Um, and you can see here the scale parameter is alpha, shape parameters are 2, Q parameter differentiates between variable exponential and gamma, and when Q is equal to 0, it becomes a log normal distribution. So this generalized gamma frailty model is a very rich model that consists of many well-known models, special. So our modeling is now marginally, I'm going to use a monotone degradation process like I mentioned before. One of the nice, simple and interesting monotone process is a gamma process. So I'm going to use marginally two gamma processes for the two performance characteristics. Then I'm going to incorporate a shared frailty by the two characteristics to capture dependence between the two marginal degradation processes. And the frailty I'm going to use is the generalized gamma frailty. So I can capture any variation between different frailty models. Use of the generalized gamma frailty helps capturing the dependence between the degradation processes in a flexible and suitable way. Fitting the model by using an estimation method based on Markov chain Monte Carlo approximation to the likelihood function. And then I will be able to estimate the joint reliability of the unit, which has two performance characteristics. If I want marginal reliability, I can secure it from there. Let us take a motivating example. Suppose you look at, I give you a simulated data, and at the end, I will give you a real life data. Degradation of a product with respect to two performance characteristics, crack A and crack B. Or in the light data, I add the chemical composition and brightness. Those are the two performance characteristics. There may be degradation measurements, and I may be testing 40 units, for example. So I have 40 lights that I am testing, and I test at 15 different time points. I may look at it at 1 week, how much of degradation has occurred, 2 weeks, 3 weeks, etc., 15 weeks. So that means I am evaluating the degradation at 4 months, for 4 months. Gamma processes I use for the two degradation process, and that is a natural choice because the two performance characteristics are monotone and a normal distribution is not appropriate. Model for the shared frailty, I can use any of the special cases, but I am going to use a generalized gamma to encompass all of them. Then I have to choose, if I want to choose one of the special cases, I can use a information based criteria. I can use the AIC or BIC to tell me the data, which special case it wants to dictate. Next page, please. So, here I have given, and this is what I will take later on to explain how I do it in a real life data. Comparison of model fits using AIC. And I have here 5 models. The 5 models are denoted by M0 to M4. I denote the exponential as the baseline model because many people use exponential frailty, whether it is appropriate or not. I have used gamma, I have used Weibull, log normal, and generalized gamma. I have calculated the maximized log likelihood, and I have calculated the AIC. I have highlighted here what gives you the minimum most AIC or the maximum most log likelihood. You can see you should use. For example, had I used, you went too fast. If you had used the gamma frailty, when the generalized gamma, you can see that the difference in the AIC is about 72. And you may think that 72 out of 5,000 is a small number. Wrong way to think, because AIC is in the log scale. So in the log scale, if you have a difference of 72, in the actual scale, in the original scale, the difference is e to the power 72. So that tells you that you can gain a lot by using a flexible frailty model. And that is a motivation for this work. Next page, please. Let me go a little faster. So, Kalyan Raman, please let me know when I have 5 to 10 minutes. Then I can try to conclude.
Yes, sir.
Okay. I have n items on test. Unit I is measured at different time points. I denote them by Tij. And unit I may have mi measurements. They don't all have to have the same number of measurements. Each unit is measured with respect to two performance characteristics, and then xktij is measured degradation value for the kth performance characteristic. In our case, k is equal to 2. But at the end, I will tell you how to generalize it to multiple characteristics. So the bivariate degradation data that I will have will be xktij. Xk means it is the performance characteristic k that has been measured on the ith unit at the jth time point. Ti0 and xk0 are 0 without loss of generality. Next page, please. So the model that I'm going to use is the model for the degradation process. I'm going to take the first performance characteristic, x1t, to have a gamma distribution. The second performance characteristic, x2t, has a gamma distribution, and they have some scale parameters which are going to be functions of time because it's a process. So the scale parameter is changing, or the shape parameter is changing, and they have scale parameters. And that is this lambda mu1 and lambda mu2. So mu1 and mu2 are the performance characteristic parameters, but they are dependent because I have introduced a shared frailty lambda. Lambda is not a parameter. It is a shared frailty variable. So I give a distribution for lambda. The lambda is the generalized gamma. So the two characteristics marginally have a gamma process, but together they will have a bivariate gamma process because they have a common shared frailty lambda, which is governed by a generalized gamma distribution. Now you have to make the model identifiable. Model identifiability comes because lambda can be multiplied by a, mu1 and mu2 can be divided by a, you won't be able to identify a. So that means you have to set the mean of the frailty distribution to be 1. This is the identifiability condition for estimation purposes. Next page, please. So, denote Z to be the increment in the degradation values. Remember, the degradations are increasing as time goes. So, when I measure the degradation at the time point j, I ask how much the degradation changed from time point tj minus 1. So, this is the degradation rate of change from time point j minus 1 to j. And I look at then the zk, which has a gamma, and I now write down the likelihood function for the bivariate degradation data conditional. Conditional on lambda. Lambda is a frailty for each unit, lambda 1, lambda 2, lambda n. So if I condition on it, the two degradation processes are independent. But if I uncondition, they will become dependent. So I have the product I equal to 1 to n because there are n products, k equal to 1 to 2 because there are two performance characteristics, j goes from 1 to mi because there are mi measurements, the product of two gamma processes, and lambda or the unobserved shared frailty. Next page, please. So, if I want the marginal likelihood function, what I have to do is take the conditional likelihood, multiply by the frailty density, and the frailty is the generalized gamma density, and I have to integrate. So, this is the likelihood function, and this is not the likelihood function which is friendly. into 100-dimensional integration that I have to do. And you are integrating with respect to each lambda. And there are n integrals. So we have to come up with this model. Next page, please. So the marginal likelihood is not in a closed form. It involves this integral, and there are n integrals. Optimizing the marginal likelihood function is numerically unstable and a challenging task. So what we do is we use the Monte Carlo approximation. We approximate the integral involved in this. Look at this integral. There is a generalized gamma density, and this is some kind of weight function. So what I can do is, if I want to evaluate this integral, think of it like an expectation of this function with respect to generalized gamma. I use a Monte Carlo approximation by using weak law of large numbers. This results in a computationally efficient and a stable solution. Next page, please. So, one estimation method, one scenario, when remember the generalized gamma has two parts in the density, Q not equal to 0 and Q equal to 0. So, I have to give two different scenarios. When Q is not equal to 0, this is the integral that I have to do. And what I do is, I convert this integral into an expectation with respect to a gamma random variable. And I have written here, nu I is a gamma random variable. Remember, the shape and scale parameter have to be the same because the mean has to be 1. So, I have a gamma random variable, 1 over q square, 1 over q square as the two parameters, and I need to get the expectation. Notice, these gamma random variables do not depend on other parameters. So, for a given q, I can simulate this gamma 100,000 times, calculate, store the data, keep this expectation, and use it in the likelihood function. Can you move down, please? The likelihood function can then be approximated. This is what is called as a Markov chain Monte Carlo approximation of the likelihood function. So for a fixed value of Q, I can maximize this likelihood function in R using optim numerically. Then how do I find Q? I do a profile likelihood. So that means over the entire real line, I choose different values of Q and then try to narrow down what value of Q maximizes this objective function, likelihood function in 2. This is what is the Markov chain Monte Carlo approximation. Next page, please. When Q goes to 0, remember, it's a log normal distribution. And life is very easy here because a generalized gamma becomes log normal, which I can transform it to standard log normal. I need the expectation with respect to a standard log normal. So I generate a 1 million standard log normal variable. When the parameters change, I have to just take the expectation, just average. Very easy calculate. The whole simulation can be done within a few minutes. So the integral is approximated by generating R independent values from the standard log normal distribution. The approximated likelihood function is much simpler in this log normal case. Can you go to the next page, please? Then we have to get the optimization for this likelihood function. Next page, please. I'm going to give you the results of a simulation study. I have taken here multiple simulation groups with different combinations of test units, different measurement times, 15 and 30, 20 and 50.
Sir, 10 minutes more.
Different parameters.
10 minutes more.
Okay, thank you. Thank you. I can conclude it. Next page, please. And here I have given the results. You see, the true value of the parameters are given, whatever the value of the degradation model parameter that I chose. And I have got the bias and the root mean square error of my estimate. Of course, you could have fitted any of the frailty models. So I have given here the results for exponential, gamma, Weibull, log normal. Go down, please. And generalized gamma frailty model. And you can see that the generalized gamma frailty model has almost unbiased results for the estimation, even when n is equal to 20. See the bias of the parameter estimates, they are all almost zero. So that tells you that the method of estimation is producing almost unbiased estimates. So the root mean square error is similar to standard deviation. And you can also see that the method is consistent, because when I increase the sample size or the number of inspection time, the root mean square error will decrease. Next page, please. Here I have given the same results for n equal to 20, but the number of inspections is 30. And you will notice that the bias is becoming even smaller and the root mean square error is becoming smaller. Go down a little bit, please. And you can see that the mean square error decreases as the time increases. Same thing, next page, please. When the sample size increases, when n is equal to 50, the number of units, the number of measurements is, and you notice that the mean square error becomes smaller. So what that tells you is that, as you would expect, the asymptotic theory of MLEs as asymptotically consistent, asymptotically normal, and etc., unbiasedness property, etc., are all inherited by this approach. You can skip, go to the next page and the next page. Here I have given the results for n equal to 50 and m equal to 30, and similar findings as I said before. Now I am going to talk about reliability. When I talk about the unit, it has two performance characteristics. So the reliability has to be a joint reliability. You cannot use marginal reliability for the unit because there are two degradation processes. So the joint reliability is what is called as a first passage time of two degradation processes. T1 and T2 be the first passage time of the two conditional gamma processes, C1 and C2, as the respective threshold values. If the brightness is lost by more than 90%, you would think of it to have failed. If the chemical is lost by more than 80%, you will think of it as failed. C1 and C2 are the threshold values. T1 and T2 are the first passage time. Then, in my paper with Zheng Cheng Pan, we give a joint reliability function conditional on lambda. And that is this bivariate normal distribution function based on the central limit theorem and marginal normal distribution function, which we can evaluate. But this is conditional on lambda. We have to use this and unconditioned with respect to lambda. So we multiply by the density of lambda, integrate to get the joint reliability. Next page, please. Just 1 second. Can you go to the previous page, please? Notice here that there are two marginal reliabilities, but there is a joint distribution, bivariate normal distribution. Notice there is a rho. Rho is the correlation coefficient. So the correlation will alter the joint reliability from the marginal reliability. And that is what is an important fact of this modeling. Next page, please. So the marginal reliability of a unit will be just the reliability function multiplied by the generalized gamma density integrated. But this is nothing but the expected value of the reliability function. So I can use the Markov chain Monte Carlo approximation to get at it immediately. The estimated reliability at a particular time. If I want to know what is the reliability in 6 months, I can put T star equal to 6 in this equation. I can find the prediction. Next page, please. So here is the fatigue cracks data. The fatigue cracks data was one of two data sets that Zheng Cheng Pan and I analyzed. This is one of the standard data in the reliability literature now. Many people are using it. So data on development of two fatigue cracks. Two fatigue cracks, which we denote in our paper by crack A and crack B, and it is being observed on 10 units. Each unit is measured at 10 measurement times. The measurement times are scaled we denote them by 0.00 to 0.09. What exactly is the measurement time? It is nothing but the million cycles. So you start with 0 time, 0 million cycle, 0.01 million cycle, 0.09 million cycle. So the interval here is 0.01 million cycles for each unit. Next page, please. And here is the plot of the fatigue cracks. How the crack has enlarged, has become bigger as time lapses. The left side is panel for crack A, the right side is panel for crack B. You can see that they are positively correlated, because when one becomes larger, the other one becomes larger, which would make sense, because the cracks are becoming larger based on the million revolutions, million cycles. So as the revolutions become larger, both cracks grow according to time. Next page, please. And here is the estimation of model parameters with log likelihood value that I have given here and AIC. And I have given here AIC. Notice here, had I used a gamma model, my AIC would have been very high, even double the amount as generalized gamma. And what becomes interesting here is the Weibull frailty model, M2. And that Weibull frailty model is almost the same as the generalized gamma. And that is because the generalized gamma is picking the Weibull model as the most suitable model for analyzing this data. You see there that if you had stuck to an exponential gamma or log normal, you would be making a grave mistake, and it will have an impact on wrong estimation of reliability of the product. Next page, please. So I have given here the fatigue cracks, different model. You can see the exponential and gamma fit very differently than a generalized gamma, whereas the Weibull fits very close to it. Next page, please. Next page, please. This is for the two cracks. And next page, please. And I give here the confidence intervals, estimates and bootstrap confidence intervals of the reliability of the product. I have different measurement times. I want to estimate the reliability based on the different models. What is the reliability? What is the confidence interval? For example, when I ask what currently, we are coming up with some swarm particle optimization methods, for example, to optimize the multi-dimensional surface of the objective function. And thank you very much. The rest of them are references, and I appreciate you all patiently sitting through the talk and also the technical problems we had in the process. Thank you very much.
So, very thankful to you, sir, for the kind thought that you have towards the department. And I request you to continuously be having us in your mind whenever you are invited here. That's
Thank you very much.
For. And is there any questions that you can ask anybody?
Sir, I have a question.
Yes.
Thank you very much, sir, for your nice presentation. I have a general doubt on modeling.
Yes.
So, along with the AIC and BIC values, can we also conclude the model validity by using the p-value? For example, one model shows the highest p-value.
I think people do not use the p-value to model validate, and there is a reason. In fact, I am opposed to using p-value. The reason is p-value is based on one particular trial. You see that you calculate the test statistic and you calculate p-value, the probability that this test statistic, first of all, you have to have a null hypothesis. For example, I have a null hypothesis as gamma, and I test the data whether gamma is distributed or not. and the p-value doesn't tell whether gamma is better than Bible or not. All it gives you is a value of a test statistic that it is against gamma or it is for gamma. But that is an estimate of the probability based on one data. So it is like tossing a coin and then you decide based on one trial whether it is half or not. It's the same. P-value is a calculation, estimate of probability based on one sample, which is just one value. So if I get for log normal a p-value of 0.36 and for a gamma a p-value of 0.6, it doesn't mean gamma is a better fit than log normal because it's an estimate based on one trial. And one trial, we all know statistically, has a lot of variability. And therefore, a p-value justification for model selection is not desirable. That is why people never use p-value for model validation. You can tell that I fitted this model, this fit is good, but you cannot use it to discriminate between models because the p-value is not justifiable in this case.
Thank you very much, sir. Thank you.
I hope it was clear.
Yeah, thank you very much.
Thank you.
Yes, I think that we are coming to a close of this talk.
Hello, sir.
The best thing.
Yes.
Am I audible?
Yes.
Is there any question? Yes.
Yes,
sir. I think Bindu is going to ask a question.
Bindu.
Sir, very interesting and nice presentation. I have two doubts. The first one is regarding the estimation part. You have mentioned that it has 8 parameters and use the profile likelihood. Which software is used and what is is there any specific package for the computation?
Well, we used a nonlinear optimizer in R. It's called optim function. But the profile likelihood is just optimizing the function, the objective function by optim. And then we do that for various values of Q on a discrete grid search. We chose 1,000 values for Q and then identify what value of Q gave rise to the highest maximized log likelihood under optim. That is the profile likelihood approach. So it's a standard package in R that anybody can use.
One more question regarding the identification. You have mentioned that I was not clear about that identifiability problem of this generalized gamma fidelity model.
Identifiability means that when I give you a data, you should be able to show that there is only one parameter configuration corresponding to that model. So if you look at a gamma distribution, I have a parameter lambda mu1 and the second gamma process as lambda mu2. So mu1 and mu2 are the parameters corresponding to the two gamma processes. They are multiplied by a common shared frailty lambda. So lambda mu1 and lambda mu2 become the new parameters for the two degradation processes. But this model is not identifiable. All you have to do is change lambda to a lambda, change mu1 to mu1 by a, mu2 to mu2 by a. When I multiply lambda and mu1, a will cancel. When I multiply lambda and mu2, a will cancel. So that tells you if I change lambda to a lambda, mu1 to mu1 by a, mu2 to mu2 by a cannot be identified because you don't see a cancels. This is what is called as model non-identifiability. So I can change a lambda to a lambda, but I can never find a. So that tells me that I have to force the model to be identifiable. The only way to do is to take expected value of lambda to be equal to 1. So you cannot multiply it by a. That forces a to be changed so that the mean is 1.
Thank you very much, sir, for the wonderful presentation and very nice work. Thank you, sir.
I hope it was clear.
Yes.
Yes. So I hope that we are coming to the close of a very interesting talk. We hope the one of the major items that I have noticed is your problems are only based on your observations. That is more important. Not just playing with functions, that kind of a thing is not coming here. That is, you
Correct.
observe something and then try to model it and then establish it. That's something that I appreciate always right from the beginning. And I thank on behalf of the organizers for your continued cooperation with us, and we expect you for further years also. You continue to have this attitude towards us. Please, thank you very
Thank
much.
you. Thank you very much. Appreciate it. Sorry that we went over time. Thank you very much.
No, no, actually it was, you started only at 25.
Right.
And so it was only 5:25 you started. So it's no
Okay.
problem. Yes.
Thank you very much. Okay.
Thank you, Professor, for your wonderful talk. We are very much grateful to you for supporting us through your a very informative talk. And we are very, since we are running out of time, we are not the other queries, other way, directly or email.
People can write to me. Thank you.
Once again, thanking you, Professor Mala, for your support, and also our Kalyanaman sir for chairing the session in a very nice way. And let us move to the next session. They are ready. To Professor Vikas Singha and Professor Jain to chair the session. My students, please introduce the chair. And Professor.
Thank you.
Welcome.
So good evening all. We are moving to the 11th technical session of ICSTC 2024, which is a keynote session that shall be chaired by Dr. Kanjan Jain. With several years of teaching and research experience at the Department of Statistics, Punjab University, Chandigarh, Dr. Jain is an eminent scholar in areas like actuarial statistics, regression modeling, distribution, and so on. She is a fellow of the Royal Statistical Society, London, and an elected member of both the International Statistical Institute, Netherlands, and the National Academy of Science, India. Also, she has contributed to several prestigious journals as an editorial board member. So, with great pleasure and honor, I invite Dr. Kanjan Jain for chair the session. Over to you, ma'am.
Thank you. Thank you for the kind introduction. So it's a pleasure to chair this session, and I thank Professor Satish for giving me this opportunity. Here, the talk is by Professor Vikas Kumar Sinha, and he doesn't need any introduction, but it's my duty and privilege to introduce him. Professor Sinha is a professor of statistics at Indian Statistical Institute, Kolkata. He did his graduation from Calcutta University and then later on completed his PhD from same university. After completing his PhD, he went on to join as the youngest faculty member in the Department of Statistics, Calcutta University. Later on, in 1979, he joined ISI Kolkata. He was awarded BC Mellon Gold Medal in 1980. His research interests are theory of optimal designs, design and inference in finite population sampling, social network analysis, randomized response techniques, meta-analysis, and scaling techniques. He was also appointed an expert on mission for UN Statistics Training Program on survey methodology and a consultant for United States Environmental Protection Agency. He has served as a visiting faculty in a number of universities in US and Canada and has visited a host of universities. He has written 3 books and has authored or co-authored a large number of papers published in reputed journals. He is also an elected member of ISI Netherlands and has served on the editorial board of several national and international journals. He was nominated as a member of the National Statistical Commission from 2006 to 9, which is the highest policy-making body for Indian statistical system. So I can go on and go on to list his achievements, but I think I will have to cut short. So I invite Professor Sinha for his lecture on repeated Bernoulli trials, a glimpse on unknown frontiers. Over to Professor Sinha, please. Professor Sinha? Is he there?
Just I have to check. Sometimes
I saw him some time back.
Yeah, he's here in the group.
Yes.
Professor, please.
He is there.
He has to unmute. He has to unmute.
Yes, he has to unmute.
Yes. This is what is called aging effect. Aging effect. Okay.
Good evening, Professor Sinha. Good
Yeah.
evening.
Yeah. Good evening. Good evening. Yeah.
Kanchan
Madam, it is very nice to
thank
see
you,
you
sir.
like this after a long, long time. I don't remember when we met last and where. It may be about 20, 30 years back. And it is very nice of Dr. Satish to invite me to come over here and make a presentation online.
Thank you,
Going
sir.
back to the root, repeated Bernoulli trials. In our first course in probability at honors level, we study these repeated Bernoulli trials, the genesis for binomial and negative binomial distribution. Over there are still some unknown frontiers, and I wanted to appraise the learned audience about this some aspects of repeated Bernoulli trials. Next, please. I hope Nikhil is giving this thing to me. Yeah.
Yeah.
I'm a twin brother, Bimal Sinha. I'm Vikas Sinha, my twin brother Bimal Sinha. By the time I had earned my doctorate degree from Calcutta University, understandably, my twin brother, he was my only research collaborator. In the post-PhD period, we wrote several papers together on a number of research problems from time to time. One topic that continues to attract me since that time, that means for the last 50 years, is what I'm going to discuss today in my talk. Next. Yeah, so we have been labeled as Institute of Mathematical Statistics, Statistical Twins in 1990. So we had a paper together in what is called Tokyo Annals, Annals of the Institute of Statistical Mathematics. Next. Repeated Bernoulli trials, a glimpse of unknown frontiers. I'm referring to a series of lectures given by D. Basu. Basu is the famous probabilist cum statistician who coined the term ancillary statistic and who had a lot of deep contribution in the area of sufficiency and ancillary statistics. Devasu posed a problem at Indian Statistical Institute during his lectures in probability and statistics. That was in 1970s. Under the setup, this was the problem posed by Devasu. Under the setup of repeated Bernoulli trials with success probability P, describe an event whose probability is square root of P. So can you describe an event which will have the probability given by square root of P? That was the problem posed by Basu. By then, we had a published paper, as I mentioned, some problems of unbiased sequential binomial estimation that was in the Annals of the Institute of Statistical Mathematics. From our joint work, my brother, he got a clue and he could resolve this problem. Next, he was prompted to take up the case of p to the power alpha, where alpha is a known rational fraction. Instead of p to the power half, he was told to work on p to the power alpha. Next. So my brother, along with our collaborator Banerjee, Pradeep Banerjee, they got the result and their paper came out in Shankha generating an event with probability p to the power alpha, alpha being a positive rational number. Their paper came out in Shunka, as I said, that was in 1979. For arbitrarily chosen positive rational number alpha, we have the representation, the integer part, this is the integer part, plus the residual. Residual is a fraction. The first part we can easily take care of by performing so many repeated Bernoulli trials. And the second part amounts to p to the power alpha, or now alpha is a non-negative rational fraction. We have to take care of alpha between 0 to 1. This is exactly what Banerjee and Sinha, my brother, they did in explicit terms. That's a very nice paper to read, fascinating and illuminating. Next. What am I up to? I'm going to talk about some existence and non-existence theorems. This is the first striking result. In the framework of repeated Bernoulli trials with parameter p, there does not exist any event for which the probability will be 4pq. That is the non-existence result. A proof of that result follows here. Note that this event E presupposes that there is a number small n, the number of trials which have to be performed, and then the event E has to be defined on the space. So E is a subset of the omega n, which has got cardinality 2 to the power n. So we start with probability of E equal to 4pq as an identity in P. If we set P equal to half, then immediately PE becomes 1. And because it is a discrete sample space, E immediately identifies itself with the whole space, which again means probability of E equal to 1, whatever be the value of P, which is a contradiction. And hence, this is the impossible proposition. You can never ever define an event for which the probability will be exactly equal to 4pq. Next. The question is about what happens if it is slightly less than 4. Here is the existence theorem. In the framework of repeated Bernoulli trials, there indeed exists a compound event E for which the probability will be 4 minus C times PQ, where C is between 0 to 1. It is a rational fraction. The minimum number of trials needed, naturally it will be a function of C, which is assumed to be known. For C equal to 0.5, that means I want the description of an event for which the probability will be 3.5 PQ. Or when I take C equal to 0.4, I want the probability to be 3.6 PQ or 3.7 PQ and so on. So what are the values of the sample size? What is the minimum sample size needed? And how do I describe the compound event? The compound events can be described explicitly based on what is called a blow-up technique. Let us try to familiarize ourselves with the blow-up technique. The results are based on an application of, as I said, blow-up technique. So let me look at 3.5 PQ. 3.5 PQ I can write as 3.5 PQ multiplied by P plus Q whole to the power T or any arbitrarily fixed positive integer T. Now FP looks like a homogeneous polynomial of degree P plus T plus 2. I already have P and Q, and then we have degree T, so altogether it is of degree T plus 2. And hence it is trivially bounded above by P plus Q raised to the power T plus 2, so that the two are comparable. Now I expand this part 3.5 PQ times P plus Q to the power T. I use the binomial expansion for this and I multiply by PQ. So that is my P to the power J, Q to the power T minus J, and then I have additional P and I have additional Q. This is all, and this is the binomial coefficient, and this is 3.5. This whole thing is less than Over here I have got p plus q whole to the power t plus 2. So p to the power j, q to the power t plus 2 minus j, t plus 2 combination j, and j from 0 to t plus 2. So this star tells me what what is to be done in order that I can find a value of t. So now I need a value of t such that the left hand side is less than the right hand side indicated by star. I have note that I have got in the left hand side there are t plus 1 terms because j runs from 0 to t, and in the right hand side you have got t plus 3 terms because it is the power is t plus 2. And the two extra terms in the right hand side, they correspond to, next, they correspond to p to the power t plus 2 and q to the power t plus 2, which are absent in the left hand side. We now claim that there is a choice of t for which we can achieve term by term domination between the left hand side and the right hand side. Of course, we are referring to the smallest value of t for which this will happen. It transpires that up to t equal to 4, this domination fails, and for the first time we have domination for t equal to 5. We are showing the details. So I start with the left hand side, 3.5 pq times p plus q whole to the power 5, and that expansion will give me 6 terms. And when I look to the right hand side, that is p plus q to the power 7, because this is of degree 7, this is of degree 7. And so these are the 8 terms, and the two extreme terms are here in the binomial expansion. Now we see that it is readily verified that the domination holds term by term. I've got 3.5 against 7, 17.5, 21, 35, 35, 35, 35, 17.5, 21, 3 and 7, 3.5 and 7. So there is a term by term domination going on between left hand side and right hand side, and therefore it is possible to define an event, a compound event, which will ensure that the computation of the probability of the compound event will lead to 3.5 PQ. Next. So now I am going to describe the nature of the event. Thus far, we have sorted out choice of n in repeated Bernoulli trials. For example, for 3.5 PQ, which we have taken up, I need n equal to 7 for term by term domination. We now proceed to describe the compound event E. For each t equal to 1 to up to 6, let AT and BT be two non-positive rational numbers such that AT is less than BT. So this will correspond to the coefficient in the left-hand side. This will correspond to the coefficient in the right-hand side. Define an event Ft such that probability of Ft equal to AT over BT. Note that AT and BT are non-positive rational numbers. So this quantity is entirely known, so the event can always be described with a assigned known probability. Also let GT event that in random repeated Bernoulli trials with n tosses, there are T heads. So this will take care of the left hand side part along with the right hand side part, because I will be having this kind of definition of the compound event. G1 is the event that in n tosses there is only one head, followed by F1, A1 versus B1. Similarly, two heads followed by F2, A2 versus B2, and so on. So AT and BT correspond to left hand side and right hand side numbers for each T in term by term domination. So let us go back. Yeah, please go. Yeah. 3.5, this is my A1, this is my B1. A2, B2. A3, B3, like that. So here I have term by term domination. Therefore, what I will do, I will toss the coin 7 times. I'll ask for 6 heads and 1 tail. And the moment I get 6 heads and 1 tail, then I'll take auxiliary randomization with a success probability half. So this will be my AT and this will be my BT. That's the whole idea. Next. Yeah, so let me read the remarks. The events DIs are generated through auxiliary known randomization because these are all known quantities independent of coin tossing. That's the whole idea. Next. So this is where I show 3.5 PQ. What are my AT values and what are my BT values? So AT less than equal to BT, and this is done to take care of the actual quantities over there. I had 3.57 as good as 1 to 2. Then I had 21.5 and then 27 as good as 5 to 6. Then I had 35, 35, 35, 35 like that. And for 3.6 PQ, it transfers that I need 9 trials, and over there, the AT and BT values are given by this, as is obtained by the binomial expansion and term by term domination. Now, there is a general theory which says that there is a necessary and sufficient condition for existence of an event is indeed this term by term domination by choice of an integer in terms of the repeated Bernoulli trials. A question might come, is it a blind search for appropriate t, or is there any theory to get hold of this value of t? It is not really a blind search, there is a systematic approach to get to this value. So let me explain. Next. General theory for 4 minus C PQ. In the setup of repeated Bernoulli trials with n tosses, necessary sufficient condition for the existence of an event E is that the uniformly minimum variance unbiased estimator of a QMB of a P is less than equal to 1 for all conceivable values of the variable X, which is coming up in the expression for QMV. So what is the big idea? We are in the framework of repeated Bernoulli trials. We are tossing the coin n times, and therefore the number of heads X that follows binomial distribution, and we know X is UMV for P. Therefore, when I am talking about PQ, this is nothing but P minus P square. So for P, this constant is of course there is no problem with the constant. Therefore, the UMV of F is given by P minus P square. For P, it will be X over N. For P square, it will be the factorial moment, X minus 1 over N into N minus 1. And upon simplification, it will come to this quantity. So I want a value of N such that this whole thing is less than equal to 1 for every conceivable value of X between 0 to N. That is the necessary and sufficient condition for the existence of a compound event E. So how do I maximize? It's a trivial thing now. If n equal to 2k, x is equal to k, that's where the maximum is coming. And if I simplify this expression, this is what I get. N is at least 4 divided by c. And if I take n equal to 2k plus 1, x equal to k, and hence n is greater than equal to 4 by c minus 1. Now I put c equal to half. It becomes 8 minus 1, 7. And I put c equal to 0.4. It becomes 10 minus 1, which is 9. So we are settling for 7 for c equal to 0.5. That means 3.5 PQ. And if c equal to 0.4, that means 3.6 PQ. We settle for 7 or 9. Once domination is ensured, the rest are routine descriptions of the compound events as we are doing by using F and G. The events F referring to the auxiliary non-randomization and the events G referring to the actual coin tossing experiment. Next. Yeah, next please. Nikhil? Any problem?
അറിയില്ല ഇപ്പൊ സ്ലൈഡ് മാറുന്നുണ്ടോ? Slight network issue, bro. So he will.
It's okay, it has come. So let us consider now 6p square q is an asymmetric function of p and q. The presentation has to come back. Yeah.
You want the previous page?
Yeah, this is okay. So now let us look at an asymmetric function. Yeah. Oh, sorry, it was. What is this? No, please go back.
Illustrative example.
Yeah, go back, please.
Okay.
Yeah, this is good enough. So let us consider an asymmetric function p square q. So I'm talking about a p equal to 6p square q. Then, oh, can you go back, please? I think we have skipped something. Please go back. Yeah. General theory for asymmetric polynomial functions. This is over. This is over. Go forward. Yeah.
Go forward.
Yeah, please stop here. Yeah, just fine. Consider the function CAB is a function of A and B, P to the power A, Q to the power B, where A and B are two known finite positive integers, and we can assume A not equal to B, so that it is an asymmetric function of P and Q. Now, if P less than equal to 1 for all P implies that C is bounded above by this quantity double star. It is very easy to fix this thing. We know how to get to the maximum of P to the power A, Q to the power B. So CAB is dominated above by this quantity. There is a non-existence theorem. Just as we do not have any event to match with 4PQ, here also there is no event to match with CAB equal to in double star or given A and B. So we can never get to an event which will give the probability given by FP function if CAB attains this quantity as indicated in double star. But if CAB is something less than this, then we can always get it. That is the non-existence theorem and existence theorem akin to what we are talking about 4PQ and something less than 4 times PQ. Exactly the same thing is happening here. Now, for existence theorem, we have to get to the value of little n, the sample size, and also we have to be in a position to describe the event. Next. Yes, here I'm taking an example. I'm taking 6p square q. What happens is for p square q, the C is 6.75. Anything less than 6.75 will do. So I'm talking about p equal to 6 times p square q. So my A equal to 2, B equal to 1, CAB is less than 6.75, that's the upper bound. Now towards finding adequate n, we proceed to find out even function fp. So 6 is there, and p square q I write as p square into 1 minus p, which is p square minus p cube. For p square, it is the factorial moment of order 2, and for p cube, it is factorial moment of order 3. And the moment I simplify, I'll be ending up with this expression. 6 times this whole expression, that is the UMVV of fp, because we are under the regular binomial setup for a given little n. And its maximum, this is again very easy to fix, that the maximum of this for variation in x, that will happen when x is to third of n in an approximate sense. So if my n is 3k, x will be equal to 2k. Now choice of k will come such that this quantity evaluated at x equal to 2k is less than the quantity evaluated at n equal to 3k. So this whole quantity is here and less than this whole quantity. Upon simplification, it comes to this thing. And we try out with 5 and 6. So that means n is between 15 to 18. It worked for n equal to 16. And 80 and bt values they satisfy 80 less than equal to bt. For every t between 1 to 15, and they arise out of the binomial expansion of. So now you are getting, it is already of order degree 3. So you take 3 more, 13, 13 plus 3, 16, and all the way it is p plus q to the power 16. So now you can verify the term by term domination between the left hand side dominated by the right hand side term by term. That is necessary and sufficient condition for existence of an event. The left hand side has 14 terms, the right hand side has 17 terms, and in the right hand side, the terms, the highest power terms, p to the power 16, p q to the power 15, and q to the power 16, these are the tail enders in both parts. They are absent in the left hand side. So if something is absent in the left hand side, we don't have to worry. That's a good sign. We have to make sure that whatever is present in left hand side is dominated by the corresponding term in the right hand side. Next. And that is what is happening here as shown in the table. So you start with the value of t. It is p square q, so it is already 3. So you look at the 80 values and look at the bt values. There is a term by term domination going here. And if that is verified, we can suggest a compound event for generating 6p square q in 16 repeated Bernoulli trials. It is indeed a fascinating exercise in probability involving repeated Bernoulli trials. Next. So the closing remarks are Professor C.R. Rao's book, 1952 book. That book describes some discrete probability models for blood group classification in the context of phenotype and genotype studies. There is a tetranominal distribution mentioned there. It is a 3-parameter model. There are 4 classes, p square, q square, r square, and 2 into these, subject to p plus q plus r equal to 1. The 3-parameter 4-class model described in Professor Rao's book, and exact simultaneous unbiased distribution of the key parameters P, Q, and R naturally because the total is 1, so we can talk about any 2 of them. So how to estimate the parameters of this model in an exact sense, providing unbiased estimation. What is the sampling procedure and how to get to the estimates. It is a non-trivial sampling problem and corresponding estimation is also highly non-trivial. So in a recent paper, I worked on this problem with 2 colleagues. Monisha Pal is from Calcutta University Department of Statistics, and this lady, Madam Papia Sultana, she is from Rajshahi University in Bangladesh. So we had an interaction and then we could come up with the exact inference in a tetranominal distribution, and it was published in the Sequential Analysis Journal. So this is where we could figure out a good application of what we did. If I want only p, that is very easy because I can think of p square versus 1 minus p square. And p square, if I call theta, p is nothing but square root of theta. That's the problem that my brother took up. Square root of p, like that, square root of theta. But if we want 2 of them, because there are 3 of them, so if we can figure out 2 of them, then the other one will be done. So if I want 2 of them simultaneously, that calls for a non-trivial sampling scheme and the corresponding estimation procedure. Anyway, this is the reference, and this journal is easily available, so there should not be any problem for anybody who wants to learn about the procedure and theory and application. Next. So this is a recent book I wrote with Monisha Pal Madam of Calcutta University. In this book, there is a big chapter on sequential estimation, and all these things that I have discussed here and much more is contained in the chapter 2 of this book. Recently, this year, this book is published just this year. Next. That's the end of my presentation. Thanks for your attention. I look forward to some questions. If it is there, then I can definitely try to give answers. Kanchan Madam, thanks to
Yes,
you.
sir.
After a long time, we meet personally through this online arrangement.
Thanks to Dr.
Okay.
Satish Kumar.
Yes, of
Any
course.
questions from the audience? So your lecture was so good and simple that nobody has any
Yeah.
to ask.
Right.
Just a small query, sir.
Yes,
So Sina,
please.
you were taking C to be 0.5 and 0.4. So we can choose more values of C also and then decide the
Yes. Let me, yeah, yes, definitely. Let me take C equal to 0.1.
that
Then
means
4
N is
minus
quite
C, that
large.
becomes 3.9. So if it
Yes.
is 3.9, that suggests that I need 39 trials to be able
Yes.
to find the term by term domination. So for 3.9 PQ, I need 39 trials to be able to find the term by term domination and hence define a compound event. If it is 3.99 PQ, then I need 399 trials to be
Yes.
able to match the left hand side dominated by the right hand side and accordingly define the compound event. This indicates why at 4 it is impossible because it is tending to infinity. So there is a sharp discontinuity at 4. If slightly below that, it is doable, even though the number of trials will be exceedingly high, but still you can get it. But at 4, there is a sharp discontinuity. That is the beauty of this result.
Thank you, sir.
Thank you.
So, thank you, Professor Sinha, for your wonderful presentation with many interesting and simple results and observations regarding these repeated Bernoulli trials.
Exactly.
You also introduced to us to the technique, blow up technique.
Yes, blow up technique. When I got it, I thought it's so simple but so cute. So cute and very powerful result because we could prove that it is a necessary and sufficient condition. That was the most interesting part of it.
And
You have to have
congratulations on
this.
congratulations on publication of your new book.
Thank you.
I didn't
Thank
know
you.
about it, so I didn't mention it in your introduction.
That's okay.
So thank you, sir.
Satish Kumar, thank you again.
Thank you, President. Thank you, Madam, Professor Jane, for chairing the session. And thank you, Professor, for your very interesting, cute results.
Thank you. Thank you.
Yes.
We expect your support in future also.
Yeah, I'm always there with you. Yes.
Thanks a lot. Now, I think now it is the time. Let us move to the next session.
Yes.
Professor, yeah, Ron assistant is here, right? And Professor Kibi Pandey is to chair the session. Professor, my students, please introduce the chair and do the needful for supporting the chair to run the session in this way.
Yes, sir. Yes, sir. Good evening, everyone. It is my privilege to welcome you all to the technical session number 12 of day 2 of the 10th International Conference on Statistics. We are honored to have Professor K.B. Pandey, Professor of Statistics at the Central University of Jharkhand, as the session chair. Professor Pandey holds a PhD in statistics from the University of Delhi and has made significant contributions to teaching and administration over his illustrious career. He has served in various leadership roles, including Director of the School of Mathematics, Statistics, and Computer Science, Head of the Postgraduate Department of Statistics, and Controller of Finance during his tenure at Utkal University. Beyond academia, Professor Pandey has played vital roles in organizing conferences, seminars, and workshops. His dedications to the academic community is further reflected in his leadership as President and Secretary of the Utkal University Teachers Association and President of all Odisha University Teachers Association. With such an exceptional professional journey spanning teaching, research, and administrative leadership, Professor Pandey continues to be a guiding force in the field of statistics. We are also privileged to have Ron Wasserstein, Executive Director of the American Statistical Association, as our keynote speaker. His presentation, Moving to a World Beyond P Lesson Point 05, will address critical advancements in statistical practices and encourage us to rethink traditional approaches to data analysis. I now invite Professor K.B. Pandey to take over the session. Sir?
Yes, he's already here in the group. So Pandey?
Sir, I kindly invite K.B. Pandey to take over the session.
So probably there may be some network issues with Professor Pandey. I hope without wasting time, we can move to the session. In between, Professor Pandey will. Hello?
Yeah.
Yeah.
Well, namaskar to all. A very good evening, a very good morning to as the case may be. At the outset, I must thank Professor Satish Kumar for giving me this opportunity to chair this session. In fact, my laptop is showing some problem. I have joined from my cell phone. Most distinguished keynote speaker, Professor Ronald L. Wasserstein, respected Professor C. Satish Kumar ji, very distinguished statisticians and participants, on behalf of the organizing committee, ICSTC 2024, and on my behalf, I take this opportunity to welcome you all to the 12th session, day 2 of the International Conference on Statistics for the 21st century. As you all know, the star attraction of this session is Professor Ronald L. Wasserstein. As part of protocol, let me introduce Professor Wasserstein. Professor Wasserstein is currently discharging the duties of the Executive Director of the prestigious American Statistical Association, having assumed the ASA's top staff leadership post since August 2007. Professor Wasserstein is providing executive leadership and management for the association and is responsible to make sure that the association fulfills its mission to promote the practice and profession of statistics across the world. As the executive director, Wasserstein is also an official ASF spokesperson. Prior to joining the association, Wasserstein was a mathematics and statistics department faculty and administration at Washburn University from 1984 to 2007. He served as the university's vice president for academic affairs since 2000. During his long association with the American Statistical Association, Wasserstein served as chair of two sections, such as the American Statistical Association section on statistical education and the ASA section on statistical consulting. Professor Wasserstein has to his credit many awards and distinctions. Noted among them are John Ritchie Alumni Award, Muriel Clark Student Life Award, the Manning Distinguished Service Award, the George Mack Distinguished Award from Kappa Mu Epsilon National Mathematics Honors Society. Last but not least, Ronald and his wife, Madam Seri, lead a very amazing life together with their children and grandchildren in Northern Virginia. With this brief introduction, may I now cordially invite Professor Wasserstein to take over the platform. The title of his talk is Moving on to a World Beyond P less than 0.05. It appears to be quite interesting. Let me now invite Professor Wasserstein to take over. Wasserstein, please. Professor Wasserstein, please.
Yeah, welcome, Professor. Please.
All right, here we go. Thank you very much, Professor Panda, for the very kind introduction, and thank you all for the honor of being here to spend a few minutes talking about one of my favorite topics with you. I'm going to try to share the screen here, and will it let me do that? Let's find out. I click on share. So I have a slide up, but you are not seeing it yet, I assume. Is that correct? You are not seeing my slide yet?
It's not seen.
Yeah. So I'm clicking on present. And there we go. All right. I think we're in business. How's that look?
Yeah.
Are you? All right. Excellent.
It is fine.
So thank you.
It's okay now. It's good.
Perfect. So indeed, I am the executive director of the American Statistical Association. That's one thing you learned about me in that very kind introduction. The other thing you learned, if you did any math at all with all those dates that Professor Panda gave, is that I'm also old. So be sure to make note of those two things. And the third thing to make note of is the disclaimer that I have on this slide. And I'm speaking for myself today. I am an official spokesperson for the ASA, but I'm speaking for myself today. So I'd like to ask you to think for a moment. Suppose that someone in the world created the most amazing car ever, something that was beautiful to look at, it was energy efficient, and something that everyone could have access to. It wasn't just for the few people who could afford it. Everyone could use it. But it turns out that this car has a problem, and that people find it difficult to drive. And after many attempts to train them and attempts to make improvements to the car and so on, people keep driving it off the road or the wrong way down the one-way street or whatever. Well, this is my analogy for statistical significance. Next year will be the 100th anniversary of the first edition
of Fisher's statistical methods for research workers, in which this notion of statistical significance is prominently introduced. And since then, things have not gone exactly as hoped. So here's an example from the world-renowned David R. Cox, who wrote in 1986, "It has been widely felt, probably for 30 years or more, that significance tests are overemphasized and often misused, and that more emphasis should be put on estimation and prediction." So he wrote that in 1986 and referred to 30 years. So take that back to 1956, and I will prove my old age then by saying that that's the year of my birth. So for my entire life, there have been struggles with regards to the concept of statistical significance. Here's another quote from just a little bit later in 1963. The null hypothesis of no difference has been judged to be no longer a sound or fruitful basis for statistical investigation. Significance tests do not provide the information that scientists need, and furthermore, they are not the most effective method for analyzing and summarizing data. And one more from 1994 with his cleverly titled article, "The Earth is Round, P less than 0.05, Jacob Cohen wrote, "What's wrong with null hypothesis significance testing? Well, among many other things, it does not tell us what we want to know. And we so much want to know what we want to know that out of desperation, we nevertheless believe that it does." I don't know how it works in India or many other countries, but in the US, when someone is going to learn to drive, they take some classes. They take something called driver education, and then they get some training on how to drive the car. And ultimately, they receive a license to drive, able to drive with the license on the roadway. Well, with statistical significance, we've been training people and retraining people for a long time. And at some point, you have to realize that training is not the entirety of the problem. In this article from 2019, Ray Hubbard shows that there's an unfortunate relationship between the number of citations of articles critical of significance testing or warning of its dangers and the percentage of papers that are still going right ahead and using it. So the warnings are simply not working. Let's back up 100 years to when R.A. Fisher called results significant. He meant that the result was worth further scrutiny. Unfortunately, that's not any sort of ordinary use of the word significant. For example, let's take words that mean the opposite of significant, okay? Insignificant, obviously, unimportant, meaningless. Those things don't suggest the opposite of something that's worth further scrutiny. Let's take
moving.
It's not moving?
Yeah, Professor.
All right.
Okay, no moving. Yeah.
Wow. So you've missed several slides, but I will just keep going. Okay, let's take, let me back up the one slide and we'll just do it this way. You're seeing opposites of significance. Now you're seeing adjectives that go in front of that significance when used as an adjective. So for example, we'd like to get a significant increase in our pay. We have significant events in our lives, like for example, weddings or other celebrations. We even, at least in the U.S., refer to people we care about closely as significant others. Let me try a word on you. The English word mole has multiple meanings. Like up in the right-hand corner, it can refer to a creature that can dig up your yard. It can refer, as in the lower right corner, to a spy. A well-placed spy is called a mole. To a spy, it can refer to a skin is called a mole. It can refer to a skin blemish. I got a couple of these. Or for those of us who are more into science, it's a unit of measurement. But the thing is that when I use or you use the word mole in a sentence, in context, it's unlikely to be misunderstood which one of these meanings you're talking about. If someone says the spy agency has a mole, nobody thinks that there's something growing on the spy agency's skin. We know from the context what we're talking about. But science words have a context for scientists that don't exist in in ordinary use. So, for example, and let me just stop and check. You are seeing my slide that says hypothesis, yes? Good, 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 good. A hypothesis is a scientific word. It's a proposed explanation that can be tested. Okay? This means that there's some experiment that can be conducted, or series of experiments, or whatever, to test the hypothesis to see if it's true or not. But in ordinary language, that's not how people use it. They use it as just an idea. I have a hypothesis why your mother doesn't like me. Okay, that's just a thought that I have. It's not scientific. Theory is the same kind of word. It's in science, a theory, something doesn't become a theory until it's been well tested. It's been substantiated through repeated experiments or testing. But in normal language, theory is much more loosely defined than that. And then the sixth of the seventh most misunderstood, misused words in science from that article is the word significant. It just doesn't mean in ordinary language what it means when we talk about it in statistics. I like to use Tinder as an illustration. Maybe you have I assume you have the dating app Tinder in India or wherever you're joining me from today. But let's think about this not as for a moment as an app to find a soulmate, but an app that is based on research. And when you're looking at it, you find this nice p-value of 0.03. Well, if we were to correctly interpret what Fisher meant by significant, we would understand that to mean that we found something that might be interesting. We should spend more time with this result. We probably should repeat the experiment. We might be onto something, but it will take some time to make sure. But unfortunately, that's not how it gets interpreted. It gets interpreted more like this. You tiny, beautiful p-value. You're the result that I was hoping for, that I want to spend the rest of my life with. Let's publish and get grants together. I love you, tiny p-value. This is an illustration of how significant has come to be broadly misunderstood. Now, I want to change gears here. And by the way, I can't see any of you with my slides on, so if there's, again, any kind of problem, please be sure to just speak up. I want to talk about thresholds, okay? And I'm going to use athletics. I'm going to use sports as an illustration, okay? There are types of boundary lines, and I'm going to categorize these roughly in a 2x2 table, okay? There are boundary lines that are basically just arbitrary, and there's boundary lines that are rational. They are there for a reason, okay? So, for example, in soccer, in football, the The boundary lines are arbitrary. The size of a soccer pitch is not some magic thing that dropped down from the universe. It's just something that was decided on, but you need the boundaries to contain the game. Okay? The property lines are a necessary boundary. Okay? They tell you where your property ends and someone else's property begins, and you need to have those for ownership purposes, for taxation purposes, and so on. Another rational boundary is traffic lanes. You need to have traffic lanes, but I think, well, my experience driving in some big cities, well, I wasn't driving, I was being driven in um, in India, for example, is that people don't necessarily pay attention to those traffic lanes. So there may be unnecessary, but they certainly are rational. And now I will argue that the p-value of p less than 0.05 is arbitrary. It was basically made up as a matter of convenience, really, for tables and so on. And it's an unnecessary boundary. Let's keep going with the sports analogy. All right. Here are, let's think about the boundary lines for a sport. Okay. Here's actually the court for something called pickleball, which is popular in the US. I don't know if that's something in your country or not, but in baseball, in tennis, in soccer, in volleyball, if the ball touches the line, then it is still in bounds. It's still in play. Okay, the line is part of the field. In American football or in basketball, if the ball touches the line, it's out of bounds. And I am certainly no expert at cricket, but as I understand it, if the ball stops right before the rope, it's still in play. But if the ball rolls and touches the rope, that's a 4, as I understand cricket. So there's a difference between whether the cricket ball is touching the rope or if it's not. Now, we have these boundaries because we need them to play the sports game. They are what happens when you land outside of the boundary is very different than what happens when you land inside the boundary. These boundaries are arbitrary. They've been established over time and by the history of the sport to determine the size of the playing area. But you have to have them. Okay, you have to you have to be able to tell when in cricket when there's a 4 or a 6 or not, for example. Well, let's talk about this boundary. Boundary p greater than 0.05 versus p less than 0.05. Is this an arbitrary boundary? Is this a necessary boundary? This matters because landing on one side of this boundary produces a very different outcome than landing on the other side of the boundary. There's a suggestion that when p is less than 0.05 that we discovered some truth. We've learned something scientifically meaningful or meritorious. Whereas on the other side of the boundary, not so much. It's time to move on. So just like in sports, a very different outcome on one side of the boundary or the other. But this is just an arbitrary boundary. The boundary does not represent any kind of consensus perspective on what indicates merit. It's a historical convenience. And it's an unnecessary boundary because significance does not mean that the observed effect is not due to chance. It doesn't mean that the observed effect is real, genuine, true, or any of the other common misinterpretations. And a declaration of statistical significance seems like it becomes an ending point. Like, okay, it's significant. We move on, as opposed to a starting point. And this leads to unreliable results and unwarranted claims. And more,
A declaration of statistical significance does not convey anything useful beyond the information that's in the p-value itself. It doesn't add any new evidence to the discussion at all. And what it does do is it leads to something called bright line thinking, where on one side, where once you cross this line, you think differently about something than you do the other. And the problem with bright lines is that they inevitably lead to our treating results on the opposite sides of the line very differently, even if their practical implications are identical. And once you have that bright line established, then it allows people to manipulate things to achieve the goal that they wish to achieve, whether consciously, intentionally, or not. And so years ago, Professors Rosnow and Rosenthal wrote this amazing sentence: "We only wish to emphasize that dichotomous significance testing has no ontological basis. That is, we want to underscore that surely God loves the 0.06 nearly as much as the 0.05. I want to illustrate this point with some quotes. These are words that are taken right out of published articles that when someone's had a p-value about 0.06, and that's bigger than 0.05, and so now they have to explain why. So they'll say things like almost significant, almost attained significance, almost significant tendency, almost became significant, almost but not quite, almost, just barely, just beyond. So we're so close, we have to explain this somehow. How about people at a little bit bigger p-value, something more like 0.08? Well, some of those people wrote a certain trend toward significance, a definite trend, a slight tendency, a strong trend. We keep seeing trends here. It's one number. How can it be a trend? Approaching our criteria of significance, approaching. Again, these are people who are rational human beings, scientists, professionals, who have to stretch language in order to try to explain why they did not achieve the arbitrary goal of p being less than 0.05. And wow, what about people who almost got to 0.05 but didn't quite get there? Here's some things again, right from the literature. Hovered at a nearly significant level, hovers at the brink, just about, just above, just at, just barely, just borderline, just escaped, just failed. So this is where these quotes come from. Right, so with the time I have left, I want to argue that it's time for us to stop doing this contorting that we do and move on. It's time to say farewell to statistically significant, as I and others wrote in an editorial in the American Statistician a few years ago, and as others wrote in Nature at the same time. And why? Well, I've already illustrated some of the whys. Significance has lost its meaning. It doesn't mean what Fisher meant it to mean. Bright lines, as I've shown you, lead to bizarre behavior, making choices that we shouldn't have to make. I illustrated that decades of complaining, raising the alarms about significance have done nothing to change anything. I've pointed out that a label of statistical significance adds nothing to what is already conveyed by the p-value. In fact, when we dichotomize p-values, we lose information. It makes matters worse. I haven't addressed the issue of multiple analyses, but that's an important issue. And in the interest of time, I won't say a whole lot about the file drawer effect, but essentially, the file drawer effect is the idea that in the extreme, the journals are filled with the 5% of the studies that show type 1 errors, while the file drawers are filled with 95% of the studies that show non-significant results. Okay. We want to make change, but changing things is hard.
Goodman wrote in 2019, the basic explanation, why the change is so hard, by the way, the basic explanation is neither philosophical nor scientific, but sociologic. Everyone uses them. That is, everyone uses p-values, statistical significance. It's the same reason we can use money. When everyone believes in something's value, we can use it for real things. Money for food, and p-values for knowledge claims, publication, funding, and promotion. It doesn't matter if the p-value doesn't mean what people think it means. It becomes valuable because of what it buys, Goodman argues. So I'm going to propose briefly some changes that we could make. Here's is problematic, and why do I need to believe that that's somehow going to ruin all of statistics if we stop doing that? I don't see that at all. Another argument is that everything I just said about statistical significance could be true about other statistical measures as well. For example, the amazing scientist Yoav Benjamini, award-winning statistician Professor Benjamini, notes that all the other approaches, as well as most statistical tools, may suffer from the same problems as the p-value do. What level of likelihood ratio in favor of research hypothesis will be acceptable to the journal? Should scientific discoveries be based on whether posterior odds pass a specific threshold? Well, I've already argued about thresholds, and yet any one of these other things, if we treat it the same as we treat p-values, they could have the same problem. But the problem is that we know that p-values have been abused for decades, and we don't have to wait to see other methods similarly abused. They would be if we don't treat them properly. And then finally the fourth argument is, well, have to make a decision. Got to make a decision somehow. And here's one paper among several that makes this claim. Speaking directly to what we wrote in our editorial, it says inferences are unavoidably dichotomous. Well, are they? I'll get to that in a moment. The ASA itself argued that we need to keep using statistical significance. Well, I need to clarify words that I just said. The ASA didn't argue that at all. A group of people within the ASA, a President's Task Force, argued that thresholds are helpful when actions are required, and they said if thresholds are deemed necessary as part of decision-making, they should be explicitly defined based on study goals, considering the consequences of incorrect decisions. And first of all, that last statement, I'll go back there, that last statement highlighted there is undeniably true. It is also undeniably wishful thinking. Yes, thresholds should be unnecessary, should be explicitly evidence is strength of the evidence, specifically against a particular, it's not dichotomous. So I would in fact propose that we overstate what statistics is good for, and it is good for many things when we make these arguments. Okay, so what do we do instead? I'm going to fly through this because you will have the slides, because it's written elsewhere, and so on, and because you've had a long day. I'm going to keep you on time. But here are the consequences. We can interpret confidence intervals as compatibility intervals. That we just as reasonably rationally be thought of as how compatible the data are with the hypothesized model. And I have an example in my slides about how we would go about doing this. But again, there's only so much time here today. The fourth change that's easy to make
everybody should be doing this, some of this already, and a lot of people. This finding in certain ways, and many other factors that exist in any research domain. There's a movie I love that maybe you have seen with Matt Damon, and he's stuck on Mars, and he has to use science to solve his way about how to get out of the situation he's in. And that's what I think the answer to this question that I posed to you a few moments ago is, that instead of leaning on the p-value to do Alzheimer's disease that where some p-value related problems, I said that wrong, where some use of statistical significance with p-value problems has arisen and created quite a dilemma for researchers. But I will skip that example because we're about out of time. So to wrap up, it's time to stop using statistical significance as any kind of metric.
Interpretation in the case of multiple hypothesis testing problem.
Yes. Yeah, I pointed out in there that I don't address that at all because it's its whole other issue. And I don't have a good short answer for that other than to say that that yes, the whole context of multiple comparisons needs to be taken into account as well, and the various methods for evaluating them. That's important, but there just simply wasn't time focus of the.
Hello. Hello. Yes. Shall I make one point? Yes. 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 Why do you worry about the significance at all if you are not interested? You can very well say, let them find the experiment, let them do the analysis, come out with conclusion with whatever probability that they get. Don't worry about what science says. Simply say, the result is proved according to the probability 0.8, 0.7, 0.3, and leave the result to be decided by the person who is going to use that result.
Yep, that's what I'm saying.
Why are you saying yours fixed at 5% or 3% and 2%? Unnecessarily bringing names to great workers like R.A. Fisher, names to great workers like R.A. Fisher and Neyman and Pearson.
I don't think I understood your question.
Pardon?
Yeah, I don't. If boundaries for p-values were selected with the care and the strategy that Neyman and Pearson laid out in their fundamental work, where we decide things based on whether it's on one side of a line or on the other side of the line. It's fine for cricket, fine for soccer, it's not fine for science.
Well, thank you, Professor Wasserstein. With many lively and practical examples, you have presented your paper, and this is quite useful in our day-to-day life while testing hypothesis in test of significance. And it's really very wonderful presentation. I would thank you on behalf of all the participants. I also extend a very sort of warm thanks to you for your nice presentation. Let us give a big round of applause to Professor Wasserstein for his useful deliberation. Thank you, sir. Thank you so much.
Thank you. It's a very great honor, and I appreciate it. And Satish, it's always a pleasure to see you, and I'll look forward to seeing you again. Take care, everyone.
I also thank Professor C. Satish Kumar for having organized such a beautiful conference, international conference, and it is really a grand success. Thank you, Professor C. Satish Kumar. Thank you. Thank you for giving me an opportunity. Thank you so much. Actually,
Bye-bye, everyone.
my system. Yeah. Thank you so much. Thank you.
Thank you, Professor Panda. Bye-bye.
Thank you.
Thank you, Professor Vasistain, for your wonderful talk. And thank you, Professor Panda, for chairing the session in a very good way. And we are once again we are giving extending our gratitude to each one of you. Let us move to the next.
Professor Satish Kumarji,
Yeah.
I was having problem in my laptop.
Yeah, I know.
Technical problem. Then there was a dislocation. I beg apology for this because I am joining from my cell phone. Sometimes I find problem. There is network issue in my residence, so I could not connect with you properly. I beg apology for this. Thank you so much for giving me an opportunity. Okay, thank you.
Yeah, even then you managed well, Professor. Thank you so much. Thank you so much for your even the technical issues.
I have just managed. The last moment problem I found, I switched over to cell phone and I could just manage. It was not very good sort of deliberation. Anyway, I beg apology for this. Thank you.
Thank you so much.
Thank you. Okay.
Okay, now let us move to the next session. Now at 8:05, right time. So next session we have 4 speakers, and Professor Syamal Ghosh is there to chair this session. Students, please introduce the chair and support the chair for running the session.
Okay, sir.
Beautiful. Yeah, please.
Okay, sir. Now we are moving on to the 13th technical session of ICSTC 2024, which is an invited session chaired by Dr. Syamal Ghosh. Dr. Syamal Ghosh is a professor at the School of Data Science, IISER, Thiruvananthapuram. He holds a PhD from IIST Shibpur and has previously worked at IIT Guwahati, the Indian Statistical Institute, Kolkata, and the University of the Free State, South Africa. His research focuses on applied probability, statistics, reliability theory, and stochastic modeling. Please join me in welcoming Dr. Syamal Ghosh as our session chair. We look forward to his invaluable insights and guidance. Sir?
Yeah. Hello, everyone. I hope I am audible, right?
Yeah, you are audible.
Okay. So thank you for the introduction. So yeah, good evening, everyone. So let's I'm inviting all of you to the technical session 13. Okay, there is 4 speaker. So and total time is maybe we are running 5 minutes late. So maybe their total time is 110 minutes. So let's have 20 minutes each, and then 5 minutes discussion or questions.
Excuse me.
Yes.
Yeah.
Yes.
We have only 3 speakers in this session.
Oh. Okay.
One speaker has been shifted to 16th.
Okay. Can you tell me who
the first speaker mentioned earlier? Shafi shifted.
Okay. So from 2, 3, 4 will be
3 speakers.
Okay. Then maybe we can go with 30 minutes each, right? Or 20 minutes.
Are there in the group.
Please.
Vinod Kumar Arugam and Sangamitra Pal are in there. You can see in the group. Other person I am not able to. Whether he will join, I think so.
Okay, so let's have 25 minutes of talk and then 5 minutes Q&A. Okay. So let me introduce our first speaker of today's session, Will Breach. He is currently working as Principal Advanced Data Analytics in Pinnacle Group. He has more than 10 years of experience in the field of data science. And today he will talk on advanced machine learning in big data for prediction of customer attrition in the telecommunication industry. Let's invite Will Bridge for his talk.
Yes, good evening. Can you hear me?
Yes.
All right. So I joined recently. I'm not sure how this works. Should I share my presentation or should I just talk about it? Like, is there a need to actually share the deck here?
Yes, please share your screen.
Okay.
Yeah, it's visible.
Yes, can you see it?
Yes.
Okay, perfect. There we go. Good evening, everyone. So my name is Wael Baish, and I'm joining from the United States, from Los Angeles. I'm originally from Lebanon, and I'm currently working with Pinnacle Group supporting DirecTV. DirecTV is one of the biggest cable and content providers in the US market. So I work in advanced analytics as part of the Churn Insights team, and I'm here to talk a bit about one aspect of our work with customer attrition, specifically predicting customer attrition or churn, because they go hand in hand. And I'll explain a bit in a few slides in case somebody here doesn't know the difference or what actually churn is. So I want to talk a bit about this and some of the like machine learning models that our team. How can I move to the next slide? Okay, this works. Sorry, having some technical difficulties here. So here's the and the conclusion of the study. So we'll go over these quickly, and then I'll move on to the data science methodology that we used in the paper. I'll talk a bit about the process being used. After that, we'll take a look at the data sources, talk about the strategy and attributes that we have, and we'll end with the results and a brief conclusion. So here's our abstract. The title of the paper is Using Advanced Machine Learning Algorithms and Big Data for the Prediction of Customer Attrition and Sorry, I can hear an echo. Mr. Kunja, can you please? Right. So again, if anyone here is not familiar with the terms attrition and churn, churn refers to the term when a customer leaves a product. In our case, more specifically, a subscription-based product. So we say a customer churns from a product, and the attrition is the opposite, which is when the customer sticks or stays with the product. Basically, our abstract outlines the importance of churn in telecom business model. A company makes money by acquiring, excuse me, a company makes money by acquiring new customers, but it also needs to retain these customers. Otherwise, this is similar to a cut or a wound in the flesh. So the company, if it's not able to retain these customers, it's as if the company is bleeding money. So this is where the whole idea of our work comes from. We talk about the different attributes and the variables that we have, and how we use the forest, GBM, XGBoost, and how we chose random forest because it minimizes the false positives and false negative rates, and it was like it improved accuracy. So objectives of our work and of the models that we build, the papers that we write, and the work with the company. I would like to think about this as three different steps, like three main bullets. The second one is, apart from choosing the attributes, we want to identify the most accurate models that we're building. And eventually, a lot of times, data teams or like data specialists, they get lost in the data and they goal. So we want to, of course, tie that back to our original business goal, which is like predicting churn more accurately and the implication that it has on the business. And this is twofold. The first one, problems, and the second, which is also important, is to help the business redefine targets or expectations. Because let's say a business is expecting 100,000 churners in a specific year, and a model that was built and that was accurately predicting churn says that the business should expect around 130 instead of 100, then we can help stakeholders and the business partners change their expectations. Or if the model predicts less churn than what we already expect, then we can have maybe so yeah, sorry. So this is done through bootstrapping, and this is to improve accuracy and the robustness of the model. There's also the feature randomness, which is like deliberately introducing randomness at each step in order to make the model more diverse and generalizable. The algorithm splits the data into a training phase and a prediction phase. The training phase uses the bootstrap map sampling, and then there's the process of constructing the tree. And here we want to get to a maximum depth with random feature subsets. And for the prediction phase, each tree makes a prediction, and then based on this prediction, there's either a maturity voting if the in case of categorical variables, and there's averaging in case of continuous ones. The advantages of the random forest include reducing the overfitting by reducing the model bias, and it also handles missing values. It works well with the incomplete data sets, and it provides feature importance insights, which means it helps identify the key features that we're looking for. So moving on to data source. So there's no question that the telecom industry is a very dynamic, innovative, and heavily competitive industry. Anybody from the audience here who has worked in this industry would attest to that. For these reasons, developing a comprehensive churn propensity model requires a multidimensional data sourcing strategy. A strategy that integrates operational systems internal to the organization, marketing intelligence, external metrics related to customer behavior, and an advanced analytics framework in order to create this holistic view of customer engagement and potential attrition risks. So we're talking about 4 key points here. the ever-changing nature of the telecom industry, the need for a holistic approach, a multidimensional data strategy, and an understanding and mitigating of churn risks. On the right is a list of the most common attributes that we usually use in our industry. We have customer tenure. Tenure is the amount of time that a customer has been with the product, and in a general sense, the longer the customer is tenured or the more the customer has been with a certain product, uh, there are less propensity to churn from that specific product. And then we have a few other important ones, demographics, age group, of course, because different age groups behave differently, the family size, the package. If somebody is on a base package, for example, then this would mean they're probably a bit more sensitive to money, so price sensitive. That's what we call them, price sensitive customers. Then we got something related to the content preference, viewing habits, streaming frequency. So this all tells us about the way a customer engages with our product. If they have high engagement, that means they're less likely to churn. If they have low engagement, then chances are they have a higher probability of churning, and a couple of others related to the internet speed and lifestyle of the customers. So moving on to the results, specifically the results from the random forest model. Again, we split the data into training and validation, 70% training and 30% validation. This gives us around 1.2 million records. A million is for the training and 200 for the validation. The target variable for our analysis is a binary classification where 1 represents the users that would churn and 0 represents active users. The algorithm, again, is the random forest, and here we get the performance metrics. So we have an 83.4% accuracy, 79.9% the PPV, and 81.5% the MPV, which are pretty good for a model predicting churn in this kind of industry. And here we have the 10 most important attributes that we focused on for the model. Again, choosing the right variables is one of the most important steps of our work. So here we can see again that tenure, which is the amount of time that a customer has been with the product, is one of the most important attributes. The other stuff related to a customer's age, income, marital status, package, as we mentioned earlier, because the lower packages means customers are here for just like the minimal service, and they would churn in case of any kind of change in price. And then the other related stuff to the engagement. And lastly, just a simple conclusion. So our churn propensity model uses comprehensive data, and we focus on the random forest algorithm in order to achieve the 4% accuracy. Offers significant capabilities in order to predict customer churn in the telecom industry, and we use this in our day-to-day work at TV. The model highlights the importance of understanding various characteristics of customers. Again, some of the excessively mentioned characteristics are the age and the tenure and the income of a customer, And of course, there's this process of continuous improvement. So we're always refining the model and we're integrating emerging data sources. We're learning new techniques. We are always trying to be at the forefront of innovation and understanding what new technologies are out there in order to help us improve our accuracy and drive more business value. And that's it, folks. Thank you for your time. I will now hand it back to our technologies that are out there, Dr. Shamal Ghosh. Thank you for the opportunity, and again, happy to be here.
Yeah. Thank you for your nice presentation and nice talk. Okay. So, any question from the audience? Any doubt or any questions? Okay, so probably no question from the audience. So I will let's thank Mr. Breach for his wonderful talk. Yeah, it is a very nice presentation and nice talk. Okay, let's all thank Mr. Breach.
Thank you. Thank you so much. Appreciate it.
Thank you. Yeah. So then I'm moving to the next speaker. Next speaker in this session is Mr. Dinod Kumar Arumugam. So let's I invite Mr. Vinod Kumar. So he's working more than 17 years of IT. He has more than 17 years of IT experience in data engineering and science, data analytics, architectural design, development and implementation of diverse big data, cloud, data warehousing, and analytical solution across various domains, including retail, banking, insurance, digital health, etc. So today he will talk on AI in healthcare using predictive analytics. So let's invite Mr. Vinod Kumar for his talk.
Thank you, Dr. Ghosh. It's a wonder and pleasure to meet you all, and special thanks to everybody, and including the planning committee. And I hope my voice is clear.
Yes, it's clear.
Oh, wonderful. And yep, with no wait, and let me introduce myself, and thank you for the introduction as well. So, with no further time delay, I'm just sharing my screen. I hope the screen is visible now.
Yes, it's visible.
Wonderful. Thank you. Thank you so much. Okay. So, uh, being worked on many machine learning as well as in the deep learning area, and I have worked on implementation of projects in the data science and methodologies, which covers most on the customer cycle, customer retention, customer churn, customer methodology, and customer sales analytics, and etc. And I have also worked on pharmacy as well as in the healthcare related projects. And this paper is all about overview, an outliner, and this is my upcoming project to be implemented in the 2025. And I do not have much data about it. It's just an outliner, and then today I'm going to talk about the data science methodology, collection, analysis, and then conclusion. So it's just on a high level. So coming to the abstract. In healthcare, okay, not only in healthcare, like the AI has put us put forward in everywhere, and especially in healthcare, it has a super high market shift, which leads to safety of our life as well as the holistic view of our life cycle, and the complete the nature behind our health records and etc. So there were various papers and various research have been already implemented across our organization, across the world in various organizations and etc. And many of them were successful. And there were again there is a lenient towards improvement and needing different kinds of methodology, different kinds of diversible data sources, outputs, and etc. And this paper outlines it's to bring in a different metrics altogether with providing high quality data sets, high quality integration of AI, usefulness input and clinical outputs, and together deriving insights which predicts the complete holistic view of our body. I mean, with the help of our medical records and the vaccine records and a lot of other preventive analysis and etc. And going to the next slide. Okay, so uh, the WHO, World Health Organization, has keep on coming us with providing lot many insights about like upcoming issues and global warming and the chronic diseases and continuous health problems and etc. And there is always a need about thinking about something extra and analyzing and taking the metrics and to forecast our problems and provide the uh, insightful solutions. And early detection and proactive management, that's are definitely pivotal in mitigating the adverse efforts. And it's not only for the diseases, and it is for anything with respect to like inside body or outside body. And it's altogether providing the patient prognosis. And the cloud computing space and the data science space has emerged a lot over a decade and produces lot of useful opportunities for the detection as well as the management and the treatment towards. Going to the next. Okay. So there were various methodologies have been discovered and then used and then being portrayed in different manners. And random forest and gradient boosting and logical regression, these are all the common technology stack used in our data science area. And this resulted full of proven methodologies as well as the proven results in our many papers as well as in the many industries. And logistic regression, which used for the binary classification task and predicting the likelihood, and which makes also the useful boosting of our instinct feature and provides a feature selection. So it's how it works, like getting the data, the sample data, precise a sample, and tuning them with the sample data, and then change the sample data, arrive the results, and then tuning them, and then continue the tuning as well as the sampling for a continuous manner, and then get the results and the metrics out of it, and going towards a next set of sampling and then nesting. That's how the methodology together treats us providing the results. And I'm going to talk about that in little detail and the data collection in the next slide. Okay, so when we talk about the data slides, data collections, with respect to the patient records, we get from the MRIs, X-rays, CT scans, and imaging data, and uniformity of data from the hospital records, health records, and the World Organization, health department organizations, and several other NGOs who are partnering with our governments and providing the data and collection of samples from various unknown identified areas and etc. So all the data, the collection of the data was a problem and a significant, a milestone efforted issue in the over the decade, but now it's no more. And we have stabilized the methodology and collecting the data and making it the data sampling and the processing and the storage. The storage nowadays, it's no more a problem, and with respect of with the advent of the cloud technology and cloud storage, it all become possible. And then data transmission or data portation between one to another all became easily made with the help of newer technologies and the ETL mandates given by our IT sector. And what the problem, where the issue comes in is this the security and the control, the authentication, and the access. And these have predominantly laid out a different journals of our research, and the technology is being worked on it, and cybersecurity, it's a different sector in the IT, and which makes sure reliable authentication as well as the access to control. And those are managed and then under the control at the moment. So, and when we talk about the sampling, okay, the rotation, scaling, flipping, and artificially increasing the diversity, these are all the techniques used for the data sets, enhancing the robustness and providing the data for getting the various metrics and the variations of imaging conditions. And these are all processed in a life cycle manner and the time series manner, and providing insights into different versatility of various metrics. And when we talk about the analysis, and what we lay down is all about validations and the cross validations. So far we have collected the data, and a number of tuning technologies with respect to methodologies we have laid down, and uh, validations and the cross validations that certainly needed in providing the clinical insights and towards targeted actions. So the targeted actions, it's a collective effort from the outputs of our metrics and the machine learning models, and from the decisions from the human. And together, the targeted actions makes a beautiful goal-oriented and medical image, time series predictions, and preventive predictions and productive predictions. And these results in the research, in the successful researchers in the happened in the industries, have resulted at least near to the 85% of the success. And there is always a scope with respect to the security threat and storage, and then flexibility. And that's we are going towards our next stage. So conclusion, these predictions have been successful in various predominantly, and especially on the polio and echocardiograms and hypoglycemia. These are all something, and cardio. These are all something like was where exist over the decades, and then beautiful insights came in with the help of the machine learning technologies, and we predicted on the likelihood of heart attacks, on the likelihood of missing our eyesights, on the likelihood of missing our liquor addict, and resulted in many recovering disease, illness, and then stopping our aging growth, and resulted stopping our death rate as well. And yep, the COVID-19 has resulted another scope where in the rapid development of medicines, as well as in the rapid development of insights, providing the result-oriented as well as the uh, goal-oriented research with the help of various technologies. And down the line, there were researchers says that AI and nano are going to have a possible impact which altering the human brain down the line. And these all going to come with the invent of and with the usage of AI driven probability analysis, and and of course like usage of the cloud based instrumental advancing and management. And the forecasting, it's vital in everywhere, and harnessing the power of these technologies to provide more accurate and efficient care ultimately provides the quality of the patients, and pure beside our life cycle. And there were the notes I have taken from various references and laid down, and I hope to partner with future conferences and many more conferences together with all the people. And special thanks to Dr. C. Satish Kumar for providing this opportunity. And thank you so much.
Yeah, thank you, Mr. Vinod Kumar, for your nice and insightful talk. So now let's, if anyone has any query, then you are most welcome. Okay, so probably there is no query. So let's thank Mr. Vinod Kumar for his wonderful and insightful talk. Uh, okay, so let's
Thank you.
give a round of applause for his nice talk. Okay,
Thank you so
okay.
much for everyone, including especially for Dr. Ghosh and Dr. Satish Kumar. And hope to see you again. Thank you.
Thank you. Thank you. So let's move to our next speaker. So today our third and probably this last speaker for today, Dr. Sanghamita Pal. So I hope she's there. Yeah.
Yeah, I am here.
Okay, let's formally introduce her. So Dr. Sanghamita Pal is currently working as an assistant professor at West Bengal State University. She received her PhD degree from ISI Kolkata, Indian Statistical Institute, Kolkata. So her broad research area lies in the field of survey sampling, adaptive cluster sampling, randomized response theory, small area estimation, among few. She has more than 25 research publications in several reputed journals. She has also two wonderful books in her credential. Yeah, today she will talk on rescaling bootstrap in advanced cluster sampling. So yeah. So let's invite Mr. Dr. Sanghamita Pal for this talk.
Is it visible?
Yeah, it's visible.
Yeah. Thank you for the nice introduction, Professor Ghosh. Thank you, Professor Satish, for inviting me, for giving me this opportunity. Special thanks to Professor Vikas Sinha, who informed me about this nice conference. Actually, I was not aware of this conference. Thank you, everyone. Just my talk was scheduled tomorrow. It may not match with that. It was a talk on survey sampling area. It will not match actually I think, but okay, these are all statistics related, and it is a talk on survey sampling statistics, obviously. So my title of the talk is Rao and Woos Rescaling Bootstrap in Adaptive Cluster Sampling. It is a joint work, one work with myself, personal myself, and another is with my student who received her PhD degree 2 years back. And still we are going on this. So this is a estimation